Hello, hi everyone. Welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to all of you or not, because today we are going to complete organic chemistry in just one day. And thank you so much all the students out there for trusting me, for bunking your schools. I got so many telegram messages that ma'am, we have bunked our school just for the class. Now we are waiting for the class. So now we are going to start the session and we are going to do every single thing, right? Yes, disclaimer. We will be doing IUPAC naming, we will be doing GOC, all the effects, stability of intermediate, acidity, basicity. Then we will jump to isomerism as well, RSDL configuration, isomerism, optical isomerism, calculation of geometrical optical stereoisomerism. Then we will jump to the reactions part, right? That is hydrocarbons, alkane, alkene, alkyne, aromatic, all these things we are going to do, right? Okay, yes. Okay, awesome. And this is going to be worth it. You just have to say very patient here. Reason being, because organic chemistry will take a time. It will take time. Are you ready to stay here till 11 p.m.? 11 p.m. or 12 a.m. it will take me, because I will be doing mechanisms as well. The mechanisms that are useful for you, I will be doing that as well. I'll be giving you some questions as well, right? And yes, and one more thing I am thinking, because so many students were saying, ma'am, we want more question practice. So what I have done in this part, I have kept some important question, like just for you to get an idea that what kind of question they can ask you. Okay, but this particular marathon is more about theory and about sample question, like model questions, right? What kind of question they can ask you. For practicing or question, do let me know, right? After this live, all the students who are watching it on recorded as well, if you want me to take up a separate class for the important previous year questions of inorganic, physical and organic chemistry, right? So that our theory part with sample model questions we are doing, then we will, without any break, we will jump towards the previous year questions, important previous year questions, right? Okay, so you can mark this in your head, right everybody? Yes, ma'am, can we make notes? Yeah, making notes at this point, I really doubt it if it is a good idea or not. See, one thing I would advise you, take a rough notebook, and if you want to memorize something, just do that. Try to understand more, because the notes will be provided to you. But yes, I would love to see your screenshots, everything. You can send me it on Telegram or Instagram. I want to see if you're making notes, or if you're doing rough notes also. If you're making, you can send it me. I want to see that what exactly you are doing on the other hand, because you can see me, I also want to see your hard work as well, right? So everybody, let's start with the class. And trust me, it took me a lot of time to manage this PPT, this full organic chemistry. This PPT is such a long PPT. Can you guess how many pages it will be of? Right, ma'am, when is class? Array, class 12th. If you see, I'll tell you the sequence. Firstly, I'll be starting with IUPAC naming, GOC and isomerism. It will take me around 2 hours to complete that. And then hydrocarbons, I think class 12th means haloalkanes, haloarenes will start around, I feel, 4:30 something, right? But if you really want to be like JE Pro, then if you're skipping GOC and IUPAC naming, you are doing a big mistake. A big blunder you will be doing, right? There is some reason that why I have kept IUPAC naming, then GOC, then isomerism, and then hydrocarbon. There is a specific reason for that. I will be also doing rearrangement tautomerism in the first part only, right? That is in the GOC only, right? So if you're skipping that, thinking that it's not important, then that is a big blunder that you will be doing, right? But yes, if you're already pro in that, then no issues. 500 slides. Don't worry, your ma'am has managed to keep it in 340 slides. Okay, it took me literally a lot of time to manage everything in these slides, right? In 340 slides, full organic chemistry was a big task, right? And I am not skipping any as a chapter or topic here. I am doing everything here, right? So let's start. Let's start. Lunch break, I'll give you, right? I'll give you lunch break. So write it down, everybody. Spam it in the chat box. 350, 340. Target 340. What is our target today? The target is to complete these 340 slides. And for your revision, we are doing this, but you will feel like I'm teaching you in detail only. After the class as well, when I'll be starting, you can in next 20 days, again and again and again and again and again and again. If you puzzle, just go through this video, watch it on 2x or 3x speed, or go through the notes, right? The notes will be provided to you. I will also share the notes in the on the Telegram channel. I will also share the notes, the link of the notes on the Telegram channel. The link of the notes on the description will be shared to you, because these notes are gold for you, right? It took me a lot of hard work to, make all these, all the organic chemistry in just 340 slides, right? Okay. Target 340. Let's start. So the first target is, guys, IUPAC naming. Who will tell me why IUPAC naming is important? Direct question. I want to see you. You should know the reason why we are doing this. Why we are doing this. It's not like I'll be teaching you just because this is in the syllabus. There is some specific reasons that in just 20 days before your exam, I am teaching you this. I know every single minute matters to you. That is why the things that I'm teaching you here, every single page is important, right? So if I talk about IUPAC naming, right, why this is important? First is they ask you direct questions. In 2025, you pick up the shifts, you will see direct questions based on IUPAC naming. They have asked you that, right? Now, direct question they have asked you. Then direct questions may be based on polyfunctional groups, and there are so many categories of IUPAC naming, right? But then if I talk about not directly they ask you the IUPAC naming, they give you it in the option. For example, they give you any reaction. The answer will be, which of the following is the product? Now, they don't draw the structure of the product. They give you the IUPAC naming or the common name of the product, right? So you should know the IUPAC naming and the common name. Common name, the most confusing thing that students do is N-neo iso secondary tertiary, that we will talk about. But before that, we'll talk about in detail IUPAC naming, right? So if any of you has no idea about IUPAC naming, even then you will be able to grasp this, right? See, the very basic thing is, if you have 1 carbon, it is meth, 2 carbon eth, 3 carbon prop, 4 but, 5 pent, 6 hex, 7 hep, 8 oct, 9 non, right? And 10 dec, right? So that is how you should know. So everybody, that is your number of carbon and the name that is assigned to that carbon. Meth, eth, prop, but, pent, hex, hept, then you have oct, then you have non, then you have dec. 11 is dodec, right? Till there, though, they will not even go, right? So now let me tell you some examples. Examples also I have picked very wisely, right? So if you see this over here, the first thing that you need to do in IUPAC naming is, what will you need to do? First, ma'am, inorganic chemistry notes, they are already there in your description, okay? They are already there in your... Acha, if it is not there in your description, today I'll check after the class. In the break also, I'll check if it is not available to you. Then I'll make it available. Don't worry, right? Okay? I'll ask the team that is it available or not. According to me, it should be available because I have already sent it to the team, right? Okay. Now focus here, everybody. Please don't distract yourself. Yes, don't distract. Yes, this is more than enough. You don't have to do anything apart from this. You don't have to do anything apart from this. That's my promise to you. That's my guarantee to you. That's why I am asking your 10 hours. 10 hours it will take me to complete all of that, right? This is more, you can just relax and sit here. Just relax and sit here. and take out your rough notebook and write down. Don't make notes, but try to understand everything that I teach you. Okay, please, yes, this is very, very helpful for NEET aspirants as well. Very, very helpful, right? Okay, yes, now shall we focus? Bacha, everybody in the chat box. Let's focus. No distraction, no distraction. One thing keep in your mind, everything that I'm teaching here is more than enough for you. You don't have to do anything else apart from this in organic chemistry. One more thing, I will not be doing purification, qualitative, quantitative analysis in this marathon. I will be doing it in physical chemistry marathon, because organic chemistry was too big. So, so many chapters were not possible, right? So that is why I will do purification, qualitative, quantitative in physical chemistry. Rest of organic part I'll do today, including biomolecules, right? Shall we focus now? Yes. Now, if you see this here, first thing is these kind of situation, this is the most simple structures of IUPAC naming. Just to mention you the rules here. First rule is that always see the longest chain here. Like if I see 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 1, 2, 3, 4, 5, 6, 7, 8. Now I know that the longest chain is this, right? So I can just mark it here. This is the longest chain. Once you know the longest chain, after that you will see the substituents. Substituents should be at the lower positions. So if I started from this side, then the substituent will be 1, 2, 3, 4, 5. First substituent will be on the 5th position. And here you are getting the first substituent on the 3rd position. So you will mention that this particular naming is the correct one. And here if you see, what is this? This is nothing but CH3, right? Whenever you have a condensed structure means like these are the condensed structure. Here this means you have carbon is not written in condensed structures. Hydrogen is not even mentioned in condensed structure. If you see, point means carbon, this point means carbon, this point means carbon, this point means carbon, this point means carbon. And hydrogen is not even mentioned by a line. So that's why carbon always wants to have 4 tetravalency completed. So that is the reason here you will have hydrogen, hydrogen, hydrogen. Here you will have 2 hydrogen. Why I am teaching you this? Because this is the most confusing part. Students don't know, ma'am, how 2 hydrogens. 4 tetravalency should be completed. So you have 2 hydrogens here. Here you have 1 and 2 hydrogens. Here you have 1, 2, 3 hydrogens. Okay, that's how you see the condensed structure here, right? Okay, everybody, do let me know if condensed structure is clear. Now, if you see, this dot means, this line means this is carbon, and to complete the tetravalency, there will be 3 hydrogens here. This means 1 carbon. To complete the tetravalency, it will be 2 hydrogen. This is carbon, 2 hydrogens will be there. This is carbon and 3 hydrogens will be there. Now, as you can see, on the 3rd position, you have a methyl group. On the 5th position, which group you have? You have a propyl group, right? Alkane is methane, ethane, butane. And whenever you write whenever from the alkane, you take out 1 hydrogen, that becomes alkyl group, right? So it is methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl. Okay, that is how you write the substituent. So it is 3 methyl and 5 propyl, no name. Right? Okay, and remember that this, whether you will write propyl first or methyl first, that will also be decided according, and they ask you these simple IUPAC naming question in 2025. They have asked you this in 2 shifts. They have asked you this, right? So if you see this over here, this will be according to the alphabetical order. It is A B C D F G H I J K L M N M N O P. M is first and then there is P. Right, that is why we have written methyl first and then propyl. Okay, right, first. Then there is second where you have ene. Ene means alkene, right? Double bond you have. Now in this case, what you will simply do, either you can have 1, 2, 3, 4, 5, 6, or you can have 1, 2, 3. Both are same only, it doesn't matter to us, anything we can do. Now, where the alkene is starting, you will not write 3, 4 alkene, no. Where the alkene is starting, it is starting from third position. So it will be total number of carbon is hex, 5, 6 carbons you have, that is hex. Now this is supposed to be hexane. Now what you will do, you will replace this ane and you will put in which position you have ene, third, 3e. Instead of ane you will put ene, right? Okay, if you have a triple bond here, let's say you have a triple bond, you will say hex 3-ine. If you have a triple bond here, right? Okay, now what about this thing? Here either 1, 2, 3, 4, 5, but I don't want to do this. Why? Because I want my multiple bonds to have lowest number, and lowest number will be from this side. So I can see 4, 5, and here it will be pent 1-ene. What I said, pent 1-ene, right? Okay. No, here you don't have any. That's what I told you. I'll take you from this and I'll keep you there, right? It's not like I'm already assuming students know everything. I am not assuming that only. I know if you knew everything, right? You were like, if you're here, I know what is the reason you are here. The reason you are here is, ma'am, I know little bit, but I don't know how will I be able to complete it in one day. I don't know what are the parts, how to revise them fastly. I know that, right? I know you want to save your time from revision. You want to do the revision here. Then you want to invest your time in question practice. Because question practice, better you do, more the self-study you do in question practice, better it will be for you. Right? So why I am saving your time in revision? So that you can do more question practice. Right? That's why I know that you, at this point, I want to take you from the basic. And this is the basic. Right? So this is pent 1e. Right? Now, what if I have compounds containing cyclic and chain parts? Cyclic and chain parts. Cyclo and straight chain having more number of carbon in parent chain is selected. Now, what if you have a cyclic and a parent? Now, this is a cyclic chain, this is a parent chain. This is a cyclic chain, this is a parent, this is a open chain. The question is which one to be selected as the main thing, as the parent chain. So what we are saying, having more number of carbon, whether it's cyclic, whether it's open chain, doesn't matter. The one which has more number of carbon will be selected as the parent chain. So if I apply this rule here, this is 1 and 2 carbons here. Here 1, 2, 3, 4 carbons here. And sometimes students, what they do, they include this carbon as well in the open chain. No, this carbon is a part of this cyclobutane. So that is the reason I'll choose this as my parent chain, because here this is the substituent connected. I'll start from here 1, 2, 3 and 4. On the first position you have a substituent, and because it has 2 carbon, so the name is ethyl, right? So what is the answer? 1-ethyl. This is the substituent. Substituent always will be alkyl, right? This is the parent chain, right? Parent, right? And this is the substituent, right? Kid of the parent, right? So 1-ethyl, this is cyclo because this is cyclic, and this is butane. There is no double bond, no functional group attached here. So simply you write cyclobutane. Right? Okay, simply you can write it. Ma'am, what if, ma'am, I have some chlorine over here? Then you write 1-ethyl 3 chloro. Okay? You write 1-ethyl 3 chloro, then cyclobutane. Right? So accordingly, whatever you have the substituent wherever. Ma'am, what if I have a double bond here? Then what I will do? Acha, this now I'll teach. Dekho. What if you have a double bond here? Then the numbering will change. Because always multiple group are preferred over the substituent. The number, less number is given to multiple groups. So if you see a double bond here, then it will not be 1, 2. No. Then it will be 1. You need to keep this over here. This is 1, 2, 3, 4. Then it will be what? It will be what? because these two bonds has to be, this multiple bond has to be in the sequence, right? So it is 1, 2, 3, 4. Now it will become 3-ethyl. Now the game will change. This is 3-ethyl cyclo. This is bute. This is 1-ene. Do you get it? Why the numbering has changed? Why the numbering has changed? Right? Do you get it? This is 3-ethyl cyclobutene. What if, ma'am, I have a double bond here? Ma'am, what if I have a double bond here? Then there is no issue. Then it will be 1, 2, 3, 4. Right? Then you can say 1-ethyl cyclobutene. Then that will be the answer. Right, everybody? Tell me. Right? Okay. I'll give you the priority order. If you talk about, I'll just write here only. Right? Always remember multiple. सबसे पहले you have functional group. Functional group has the highest priority. This is just for the numbering, okay? Then you have multiple groups. Then you have multiple groups, multiple bonds, multiple bonds. Multiple bonds means double bond, triple bond. Then you give priority to them. Then in the end you have substituents. Then in the end you have substituents. Okay? This is the main rule. Tell me till here if you have any problem. Tell me till here if you have any problem. Right? Right? Okay? Functional group or double bond. Highest priority will always be to the functional groups. Then there will be double bond, triple bond. Then the lowest priority will be to the substituents. Right? If I see there are no double bond, no functional group, I'll give priority to this one. If I see a double bond here, then I'll start numbering from here. If I, let's say, see a double bond as well, if I see a CHO group here as well, then I'll start the numbering from here. 1, 2, 3. Okay? But functional group, I'll move to that. Okay? I'll tell you that. Right? As of now, just see this. Right? Tell me now here. This says, if same number of carbon is in open and closed chain. Ma'am, now what to do? Same number of carbon, ma'am, we have. Ma'am, here also 1, 2, 3, 4 carbon. Here also 1, 2, 3, 4 carbon. Now what you do? Now what you do? Right? Now what you do? Very good. 1-ene. Yes. Is it 2-ethyl cyclobutene? Where, beta? Where? Here you are saying, see, if I put this here, dekho, see, if you have no double bond is there, then what we will do? We'll give priority to this one. 1, 2, 3, 4. This will be the name. Let's say double bond is over here. Then I'll give priority to this one. 1, 2, 3, 4. Then it will be what? 3-ethyl cyclobutene. Okay? Understood? Is that point clear to everybody or not? Is that point right? Okay? Tell me. Is that point clear to everybody? Yes. Two-ethyl butane, I didn't get you. Beta, where before page why it is methyl? Because this is methyl, this is propyl, that is why it is methyl and propyl, na? अरे भाई देखो, see, I don't know, those to whom it is clear, do let me know. And those who have a better, I'll teach you functional group. Can you please have some patience? Okay, can you please have some patience? Right? Okay? Okay? Please have some patience. Right? Tell me if that thing is clear. Now, ऐसे तो बेटा I'll not be able to teach. Okay? Don't do this kachar pachar here in the chat box. Right? Tell me if there is any problem. Methyl, ma'am, where methyl? Beta, methyl, there will be methyl na here. Because this is CH3, this is 3, that is why it is propyl. That's what I have taught you here. What I have taught you here. Methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl. Don't ask me those questions so that I stop looking at the chats, and those students who have some genuine problem, I don't see their chats. ठीक है, ask some genuine problem, right? Don't ask those questions which have no sense, right? Teacher is teaching you that in the first page, you are asking on the fourth page that thing, so that other students, right? I don't want to spoil anyone's time here, right? I have responsibility of so many students out there, right? Okay, so I don't want to spoil their time, so please focus here. When I am teaching you, you are getting distracted here and there. Then in the fifth page, you ask me the thing that was done on first page, right? And then I am not going to entertain those kids here, right? I am not going to entertain you. I'll focus on only those doubts which are actually on the same page. You ask me doubt about this page, then I'll answer you. Dekho, firstly tell me if that thing is clear, right? If I say this here, this is if you have same number, if you have two different number of carbons in the parent chain and here, then you will select the one which has more number of carbons. So that is why you will select this 1, 2, 3, 4, right? Substituent, you will start the numbering from the substituent. But then I told you, what if you have a multiple bond here? Whenever you have a multiple bond, according to multiple bond, you will decide the numbering. That is 1, 2, 3, 4. In that case, this will become 3-ethyl cyclobutadiene. 3-ethyl cyclobutadiene. Okay, it will become this, right? Tell me if there is any problem. Why this is ethyl? Because this is 2 carbons, that is why it is ethyl, right? Okay, tell me if this thing is clear, this point is clear to all of you or not, right? Okay, right? Now if you have this thing here, when the number of carbons are same, let's say in the open chain and in the closed chain, the number of carbons are same. This is 1, 2, 3, 4. This is 1, 2, 3, 4. So the number of carbons are same. Then that's the problem, which one to choose. Now in this case, whenever the number of carbons are same, then open chain is selected as the parent chain. Now in this case, you will select open chain as the parent chain, and that is the reason this will be selected as a parent chain. So it will be first carbon here, 1, 2, this is third, and this is fourth. And that is the reason it will be 1 cyclobutyl. Now because this is the substituent, and substituent is treated as alkyl, right? So it is on first position, you have cyclobutyl, and this is butane, right? Okay, tell me. Then you have compounds containing multiple bonds. Now whenever these compounds have multiple bonds, then what will happen? Multiple bonds have more priority than the substituents, as I have told you. Multiple bonds always have more priority. If more than one double bond present, then the suffix will be hexa, means there will be A over here. Multiple bonds have more priority than number of carbon in the parent chain as well. Let's talk about this. Now these are the questions of multiple bonds, that is double bond and triple bond. If you see this here, now multiple bonds have more priority as compared to substituent. These are the substituent and these are the multiple bonds. So I will number it according to multiple bonds. So I will do it 1, 2, 3, 4, 5, 6, 7. I could have done it like 1, 2, 3, 4. But then the ene will have number 4. Here ene is having number 3, right? So that is the reason I will choose this thing, right? And total number of carbons are 7, right? So what you will do? Hept 3ene, right? And what are the substituents? Substituents are chloro and bromo. Bromine, B is before C. That is why according to alphabetical order, it will be 5 bromo, 3 chloro. It will not be written as 3 chloro, 5 bromo. It will be written as 5 bromo, 3 chloro because of the alphabetical order here. This is because of the alphabetical order here, right? Okay. Tell me if there is any problem in that. Right? Then again, when you talk about this thing here, in this case, what you have? This is 2 multiple bonds. Whenever you have 2 multiple bonds, then what you do? You write it You do number it from the substituents, from the multiple bond, 1, 2, 3, 4, 5, 6. Right? Now this is 6, that means it will be hex. Ma'am, why there is hexa here? Ma'am, why this is A over here? Because whenever you have more than one double bond, what we said, if more than one double bond present, then the suffix is A. That means you put instead of hex, you will have hexa 1, 3. On the first position you have ene, on the third position you have ene. So it will be, instead of hex 1, 3 diene, it will be hexa 1, 3 diene. Right? Okay? Understood? Tell me. One more thing to remember here. After A, if you have I, O, U or Y, then A will be cancelled here. A, E, I, E also can be there. After A, anywhere in the numbering, in the naming, after A you have vowels. Vowels like A to is there only. E, I, O, U, E, I, O, U, or you have Y. Then this will be cancelled. Now reason why here this A is not cancelled, because after this you have D. So when you have hexa 1 E, now after A you have E. That is why this is cancelled and we directly write it as hex 1 E. Got it? But here, because after A you have D, that is why it is not being cancelled. Right? Okay? Yes. Done. Now next thing is this one. In this case, if you talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, you can see that here you have 9, but in that case, the multiple bonds are not there. So that is the reason we have this rule here. Multiple bonds has more priority than number of carbon in the parent chain. So if I choose this parent chain, 1, 2, 3, 4, 5, 6, 7, 8, 9, number of carbons are 9 here, but multiple bonds are not included. But if I choose this multiple chain here, 1, 2, 3, 4, 5, 6, now the number of carbon in the parent chain are 6, but the multiple bonds are included. So what I will choose? I will choose the parent chain which has multiple bond, even though its number of carbons are less, and that is the reason I chose this particular thing here. And that is the reason on third carbon I have 1, 2, 3 propyl, okay, and here I have 1, 2, 3, 4, that is butyl. Now see one thing. Here on the third carbon it will be propyl, on the fourth carbon it will be butyl. But B is before P. So if I can, if possible, can I give lowest numbering to B? Is it possible? Yes, that is possible. How that is possible? It is possible if I do it like this: 1, 2, 3, then 4, then 5, then 6. Now this is getting the numbering 3 and this is getting the numbering 4, and we are very happy about it. Right? 3 butyl, 4 propyl, hexa. Why hexa? Because whenever you have two multiple bonds, it is A here. Hexa 1, 5 on the first position. Wait a minute. It is 1, 5 diene. Wait a minute. 1 hai. Haan. This is on the first position. This is on the fifth position. Yes. So it is 1, 5 diene. That becomes your answer here. Right? Okay. Yes, everybody. Tell me. Done? Yes. Is that clear? Is that clear? Now next is when substituents is complex. Now here when the substituent is complex, okay, see, you want to have the maximum numbering here. In the longest chain you have the maximum numbering 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that is 9. Now, if I start from here 1, 2, 3, 4, 5, even then it is the same. But ma'am, why you are not including this here? Then it will be 1, 2, 3, 4, 5, 6. है ना? If I include it here 1, 2, 3, 4, 5, 6. But if I choose this longest chain, if I choose, I will have the maximum longest chain here, that is 9, right? So I will choose this. But then this substituent become very complex substituent because it is not a very straight substituent. You can't just say methyl ethyl here, right? So you have to number this substituent as well, that you will number, you will select the longest chain here as well, that will be 1 dash, 2 dash and 3 dash. On 1 dash you have 2 methyl groups here. So what you will write here, on the 5th position you have a substituent where on the first position 1 dash 1 dash you have 2 methyls, then this overall is a propyl, this overall is a propyl, so you will write 1 dash dimethyl propyl, right? And the overall it is nonene. Tell me, is that clear? Is that clear everybody or not? Is that clear? Okay. Previous question is also having multiple bonds. Yes, that is why we have written hexa here. This is why here also we have written hexa. Okay, that is the reason we have not written hex, we have written hexa there. Right? Any problem here? How do we answer it? Next is, right, that also I'll tell you, don't worry, right? Okay. Now let's talk about the functional groups, right? If I talk about the functional groups here, you have alcohol, ether. These are the, structures of functional group that you must know. Alcohol is OH and it is, instead of ene, you write alcohol, right? So that is alkanol, right? What you write here, like you have pentanol. So instead of E, you replace E by, you have in alkane, you have ane now. You replace ane by ol. So it becomes alkanol. This becomes ether. We'll talk about how to do the numbering, how to do naming of ether. Then you have aldehyde that has al. Then you have ketone that has on. Then you have carboxylic acid that is oic acid. Then ester is O8. Then amide is amide. Then acyl halide is oil halide, right? In detail also I'll tell you how to do that, right? Alkyl halide also I'll tell you how to do. Anhydride is oic anhydride, right? Then alkene is ene and alkyne is ine, right? Let's talk about one by one how to do the numbering with the help of examples, right everybody? Yes, yes. Now let's see alcohol here. If you see simple alcohol, this is useful in the reaction part, okay? Simple alcohol, if they have given you, then you do how to write it in the form of your longest chain you want to write. So this will be 1, 2, 3, 4, 5, 6. On the third you have ol, on the fifth you have 2 methyl. So it is 5,5 dimethyl hexane 3 ol, right? If you talk about here, right, in this case you have 1, 2, 3, 4, 5. So what you have here, 5 carbons, that means it will have pent. On the third position you have ene. So you'll write pent 3-ene. And ol is always the suffix, right? So what you write, see, pentane. This is simple pentane, right? Firstly, you want to write ene. So it will be 3-ene, right? Then it will be on the second position, you have ol. But ma'am, why there is no E here? Ene is supposed to be E and E. So what exactly happens here? Cut E in suffix of parent chain when E is followed by A, I, O, U or Y, right? So what you will do in the same manner, if you have E, after E you have A, I, O, U or Y, then you cut this E, right? When you cut this E, it will be like this. Okay? So that is why here you don't have any E. E you don't have here. E is, you will cut it here, right? That is because of this rule over here, right? Okay, done. Then you have ethers. In ethers you write it like this, that is alkoxyalkane, right? Now alkoxyalkane, what do you mean by that? Let's see that. Alkoxyalkane, alkoxy is the part, chain with less number of carbon. Alkane is the part, chain with more number of carbons. right? So ether is, that is ROR. You have two chains here, right? The one that has, in this case, so you have symmetrical. Symmetrical will be simple methoxymethane, right? Symmetrical will be quite simple here. Let's write something unsymmetrical here. Let's say you have unsymmetrical here, and that unsymmetrical, let's say you have wait a minute, right? Let's see, you have something unsymmetrical here. That means you have something like this. This is O. Let's say this is C2H5. This is CH3. Now, how do you write it? Now, how do you write it? You will simply write it like this. This has less number of carbon, less number of carbon. This has more number of carbon. So more will be alkane part, so this is ethane, right? Less will be alkoxy part, so this is methoxy, methoxy, right? Okay, that's how you're going to write it, right? Okay, tell me. Yes. Then there is ketone. In case of ketone, how do you write it? Just simply write on here. So ketone always is RC double bond OR. That is ketone. Right. So how do you write it? Firstly, you name it fully. The numbering you do 1, 2, 3. 1, 2, 3. Right. On the second position, you have on. So it is called as prop to on. Right. Prop to on. Right. Or let's say you have another example. I'll just write it like this. For example, you have this thing CH2, CH3. Now what will be the name? Can you all tell me what will be the name now? Numbering will be done in such a way that this double bond O gets the lowest number here. So it will be done like this. 1, 2, 3, 4. So it is called as butana. So it is butane instead of E, butane. This is 2, this is on, right? Butane 2 on. Right now I'm just giving you quite simple IUPAC namings, right? That will be useful for you when you're answering the questions, right, of reactions, right? Then you have this part, that is aldehyde. So it will always be terminal. That is why it will always start from this. You will never have 2-ul, 3-ul, 4-ul. You will always have 1-ul. That means it will always be on the terminal position because it is RCHO, right? So it will always be on the terminal position. I'll write here as well. It is RC double bond O R dash. Right. So here it will be 1, 2, 3, 4. So here answer is going to be but. But means 4 carbons. Butane 1-ul, and always it is going to be 1-ul only. Right. Then carboxylic acid. Carboxylic acid always it is going to be terminal. So it is 1, 2, 3. So it will be 3 carbons. So that is why it is propanoic acid. Then you have acyl halide. It will be 1, 2, 3. Acyl halide is always oil halide. Oil. Here answer is oil halide, and that is the reason it is 3 carbon. No, so it will be propanoyl chloride because here halogen is chloride. These are very, very important, right? Okay. Very simple, very important that they can ask you. You know how they ask you. It is reacted with propanoyl halide, propanoyl chloride. Now, students sometimes they don't know only what is this propanoyl, right? That's where they stuck. Okay. Amide is written as simple amide, so it is 1, 2, 3, 3 carbons you have, and you will just write propane. Write propane. Replace E with amide. That's it. Propanamide. Propanamide. Okay. And this is always terminal. COH is also terminal. COCl is also terminal. These are terminal. Aldehyde, carboxylic acid, acyl chloride, then amide. All these are acid derivatives. They are terminals, right? Anhydride, that is formed by carboxylic acid, right? By taking out water. For example, you have RCOOH, and then you have another RCOOH. You take out water from here, it will become this COO, COO. Okay? C double bond O, O, C double bond. Right? So, how do you write anhydride? Anhydride will be, you will firstly see this chain and this chain. Okay? Now, how do you write it is, this particular thing is from ethanoic acid. Okay? This thing is from propanoic acid, right? And that is the reason you will write ethanoic, propanoic anhydride. You will write it in a way from the carboxylic acid from where it is made from. You will write it from there. So it is ethanoic, propanoic acid. That's it. Okay? Ethanoic for example, here you have C2H5. This will be propanoic anhydride. That means two propanoics are used here, right? So what is the acid from where it is made? We'll write it that way, right? Okay. Then you have ester, very important, right? Ester is actually RC double bond O R dash. This is this thing, right? Now it is written as alkyl alkanoate. What is alkyl alkanoate, bacha? What is alkyl alkanoate? What is alkyl part? With oxygen atom, alkanoate part is with C double bond. Okay? Alkyl part, that means this will be the alkyl part because this is with the oxygen atom. This is with C double bond O, so this will be your alkanoate part. Alkanoate part. So alkyl alkanoate means this will be ethyl methane, ethyl. No, alkanoate, so you will use this full na. This carbon also you will use here, right? So this will be ethyl ethanoate, right? Now if I give you something like this, let's say you have C2H5, C double bond O, O, C H3. Can you tell me what is the answer for this one? Can any one of you tell me what is the answer? In the previous slide for ether, if it's symmetrical, can you explain again? Okay, Sharda, I'll just see. After the firstly you answer this, right? Dehydration of COH is ethanoic acid, right? Dehydration of what you're saying, I think you want to say, Nitesh, that after dehydration of carboxylic acid you have anhydride. Yes. Okay. What is this? Less, if you see, with the oxygen part you have alkyl attached. With the C double bond O part you have alkanoate attached. So this will be called as, very good, you are writing it right in the chat box. That is methyl methanoate. This is propanoate. Okay. Yes. Now tell me what you were saying. You were, I think, asking about this thing. Is it ether? Where was ether? Here. If you have symmetrical, see in symmetrical, so it's quite simple. In symmetrical, you will have simple thing. Then so there is not even a question. This is methoxymethane. If it is symmetrical, then so we don't even have to think which is methoxy, which is alkoxy, which is alkane. But if you have unsymmetrical, then you will have to think. For that, the simple thing is alkoxy part will have less carbons, alkane part will have more carbons. Okay, tell me, any problem? Till now, tell me if there is any problem, because we have completed the simple that part. And one student was asking double bond and triple bond, which will have more priority. Double bonds have more priority, okay? Right? Tell me, is that clear? Any problem till here? These were the simple, when you have only one group. Acha, when you will use this only one group, they don't ask you directly these questions, right? They ask you these questions in like reaction part. Which is the product that will be formed. Maybe the product will be this thing. Then they will give you the name of the product in the comment section. I am saying in the options, they give you the name of the product. So name you must know. ठीक है, sometimes students don't know, especially ether and ester. There students find confusion. Ether, ester, and acyl chloride. Other are so simple only. Ether, ester, and acyl chloride. That's why I have specially mentioned this is ether. Sorry, this is ester. Then ether also I have specially mentioned this part here that you have to remember. Right? Okay. Ma'am, for more branching, is there priority for that? More branching priority? No, no, no. Longest chain is selected. That's it. Right? Okay. Now let's talk about polyfunctional group. Now polyfunctional group, if they ask you, they will ask you directly. Right? Direct question will be there. The IUPAC naming of this. That's it. Okay. And if they ask you if they ask you direct IUPAC naming question, it will not be very simple. It will be polyfunctional or some twist will be there. Okay. So let's talk about what kind of twist can be there. So the order of decreasing priority for the function group you must know. I'll tell you a very simple way. Firstly, you have carboxylic acid. This is what you have to remember. This is carboxylic acid, cute centa and ester, right? Cute centa and ester. Halley ate chocolate ice cream. Just Merry Christmas went now. Halley ate chocolate ice cream. Edward King. This is King, okay? Edward King, Edward Kind or King, whatever you can remember, right? Edward King arranged the amazing event. There was Merry Christmas and Edward King arranged the event, right? Carboxylic acid, cute Santa and Esther Halley ate chocolate ice cream. Edward King arranged the amazing event, right? Ma'am, do you also remember it like this? No. This is just for you guys. Mnemonic you were asking. That is why I had made this mnemonic for you guys. But, you know, how I remember is I'll give you a simple way of that. You can know from this also, that also. How I remember is firstly you have carboxylic acid, then you have sulfuric. It is CS. Cute Santa. Cute Santa, so you can remember. Carboxylic acid, sulfonic acid. Then you have the derivatives of acid. That is anhydride, ester, halide, and amide. These are the derivatives. These are the derivatives. It starts from A, E, H, then amide. Alphabetical order is first you have anhydride, then you have ester, then you have halide. In the end, you have amide. Okay? Right? Done. Then you have cyanide and isocyanide. Right? Then after that, see, carboxylic acid, its derivatives. Then I'll start with triple bond. This is actually triple bond. Triple bond functional group are only cyanide and isocyanide, right? Then I start with double bond. These are double bond. These are double bond, right? Then there are single bond. These all are single bond, right? Okay? Single bond. Okay? Then it is alcohol, thiol. Thiol is SH. Alcohol is OH, right? Then you have amine, right? Then you have ether, that is ROR. Done? Tell me. No, I didn't made it with ChatGPT, frankly. This is very old trick. That time, I never knew that ChatGPT, I think it was not even there. I didn't knew ChatGPT. This trick, on my NEET channel, there is like Gopika ma'am. She made it for me. She was like, I'll make it. Right? She made it. Then we were discussing over call, and then she said, like, let's do this Santa, and Christmas is going on. Right? So I'm like, okay. She's bio teacher, na? She's very good in making mnemonics and all. She made this. Right? It's not ChatGPT. But how I remember is cute Santa, carboxylic acid, sulfuric acid. Then you have the derivatives of carboxylic acid. Then triple bond, double bond, and single bond, right? Okay. Now, let's see this here. Now, let's see this here. Acha, let's see. This is main functional group. This is substituent. Acha, Have this ever happened with you? Sometimes you are the main character, right? In front of your younger sibling, you are like, bro, I am the king here. What are you doing? You have to listen to me. Do you get it? Your parents are not at your home, right? You're like, do you get it? Please bring water for me. Do this for me. Do that for me. You are the king, right? But as soon as your parents come home, then you are like, I'm cute, I'm innocent, right? I'll go and pick my own bag, pick my own water bottle, everything. I'll not scold anyone. I am, because now you are the junior, right? Now your parents are like this, right? But when your parents sees your grandparents, they are like this. They are like, okay, yes, we will do that. Yes, we will do that, right? Isn't it? It's a chain, right? So same thing happens in case of these functional groups. When they are the main group, then to whatever I showed you before, that will be the correct one. Like alcohol will have ol, amine will have amine, then ketone will have on, aldehyde will have al, ester will have alkyl alkanoate, acyl halide will have oil halide, amide will have amide, cyanide will have nitrile, right? Sulfonic acid, ether alkoxyethane, alkane, carboxylic acid, oic acid. This all we have done before, right? But now, when they are behaving like a substituent, I'll give you examples here. When they are behaving as a substituent, alcohol now becomes hydroxy. Amine now is becoming amino. Ketone is not on. Ketone is oxo. Now aldehyde also is oxo. Ketone is also oxo. Ketone is also called as keto. In options you will see. From options you can eliminate that. But whether they write oxo or keto, that is the same thing only. In aldehyde, in some specific positions, compounds we use oxo. Sometimes we use formyl. You can't interchange these two things. Keto and oxo can be interchanged. These two things you cannot interchange. I'll tell you when to use formyl, when to use oxo. It's a very, very, very important point. Based on this, they can ask you the question. Okay? Then ester is alkoxycarbonyl. Ester is not alkyl alkoxynate. This is alkoxycarbonyl. Acyl halide is halocarbonyl. This is alkoxycarbonyl. Amide is carbomoyl. Can you see? These are some very, very different names. Cyanide is not nitrile now. It is cyano. Sulfonic acid is not sulfonic acid. It is sulfo. Can you see their cute names here? Right? Ether is not alkoxyethane. It is alkoxy. Carboxylic acid is not oic acid. It is carboxy. Can you see the cute names now they have? Right? Very cute. There's like, we are Chintu, Mintu. We call it a Chintu, Mintu, Shintu, Dintu. Right? Pappu, Mintu. Right? All these names are what? Right? Now it is like Diksha, Kaushal, ma'am. What if in my home they call me Gudu? You'll be like, ma'am is Gudu? Really? Huh? Someone's name is some big Rathor and all kind of name. Their name is Pappu at home. So these are their home names, right? Hydroxy. Now tell me in the chat box, right? Okay. Tell me in the chat box, what is the name for cyanide? What is the substituent name of cyanide? It is cyano. Right? What is the substituent name of hydroxy? Hydroxy, I am saying. Okay, which one to give you? Chalo, I'll ask you, what is the substituent name of ketone? What is the substituent name of ketone? Very good. Cyno. Right? My name is not Guddu, guys. My parents didn't have my nickname only. I to ask them. I said, I need a nickname. They were like, no, you're Diksha. I'm like, okay. You give me nickname, I'll be very happy. Right? Now let's see how it is applied. Okay. Now see, you don't have one functional group. You have two functional group, 1 and 2. Right? Which one is more priority? The one that have double bond always have more priority as compared to single bonds. This is just a way to remember it. Otherwise, so I told you there is a proper priority order. right? So here this will be acting as a substituent, right? As substituent, amine is nothing but it is amino. So what you will write? Parent chain will be this 1, 2, 3, 4, and it will be 3 amino butanol, because here it is a main group. Main group will be butanol, right? There is no difference in that, right? What about this one? Here it is NH2 or OH. NH2 or OH. If you see this group here, if you see this priority order here, amines are last second, alcohols are here. Alcohols have more priority as compared to amines. So can you write it over here that again this is the substituent, that is amino, and here this is the main. So it will be 1, 2, 3. 2 amino, and what is this? This is butanol. Sorry, this is propanol. Propanol, right? Okay. Done? Yes. Now, next is what? Next is what? Yes. In this case, if you see, what are the groups that you have? What are the different groups that you have? Right? No, that's not my nickname, yeah. It is just an example. My cousin's name is Guddu. My name is not Guddu. Right? But you can call me that. I don't mind, guys. I'm very chill. Don't worry. Right? So, 1, 2, 3, 4, 5. I don't know what is the numbering. First, I'll just see. There is this ketone group here. This is alcohol. This is amine. Which one will be the main group? Ketone. It is the main group here, right? So that means this is the main group. These two are the substituents. So this will be named as amino. This is named as hydroxy. 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 Right? Done? Amino, hydroxy. A should have low priority, low numbering, low priority, I am saying low numbering. So it is 1, 2, 3, 4, 5, isn't it? So that is why it is 2 amino, 4 hydroxy, and this is pentanol. It is pentanone because this is ketone. Pentane 3-one. Pentane 3-one. That will be the answer. Then you have this one. Here you have, this is acid. Can you see this is COH? Acid. This is ketone. What is the name of ketone? Tell me. What is the substituent name of ketone? I have also written it there as well. Answers are already written. You just have to see what to pick. Let's see how many likes you have. It should cross 200 by now, right? Okay, yes, very good, done, good. So you have ketone, you have an acid. Now the question is, ma'am, this is ketone, this is acid, ma'am, this is the main group, ma'am, this is the priority, this is the lowest. Very good. So ma'am, it can have keto also, it can have oxo also. There is no preference here. Both are right. Okay. There will be no answer where if they give you both as the options, then it's a bonus question. Okay. It's a bonus question then. They should not give you both as the option. Okay. Both are written right in NCERT. It's from your NCERT data. Right. So it is 1, 2, 3, 4. You will start it from here 1, 2, 3 and 4. On third you have oxo. You can write it 3 oxo or you can write it 3 keto. 3 oxo or 3 keto, and this is 1, 2, 3, 4 butanoic acid. Right? Okay, done. Done. Next is this one. Let's see. This one, let's see. These kind of questions they can easily ask you in the exam. And I would say it is just solved in few seconds. It's just a few second question that you have. Right? How do you solve this? Can you see which one is the priority here? Cute Santa. Cute Santa. Santa is cute, huh? Santa is cute. So cute is our acid. This is the main. This is the main. And this is substituent. This is substituent. This is substituent. Right? If you see this here, this is nothing but keto. Double bond O. This is keto. You can write it oxo as well. your choice. In this case, you have amino. This is sulfo, right? Now, what is the answer? 1, 2, 3, 4, 5, 6. Okay, this I'll teach you. This abhi ke liye don't look at this. Okay, as of now, don't look at this. Just look at this one. So what you have, 4 amino, 2 oxo or keto also you can write 2 oxo or keto, 3 sulfo, 3 sulfo. This whole is hexanoic acid. Hexanoic acid. This will be E will not be there. Okay, E will not be there because after E, if you have, I told you now, after E, if you have A, I, O, U or Y, then this E is cancelled here, right? So E, you will not write it there. ठीक है जी, okay. Dhanush, very good point, right? As of your syllabus is concerned, you will not see carboxylic acid as the substituent. Okay, done? Yes, let's see. See then why you are writing it the last? Because suffix is written in the last now. All these are suffix, right? Okay, this is the parent chain. Main group is always written in the parent chain. This is the parent chain, right? And all the substituents are written as a prefix, right? So main is always written in the end, right? Hexanoic acid. Others are substituent. Firstly, you have substituents, then you have the parent chain, right? Done. Now, if you have this here, then you have this thing. If you see this over here, this is very important. I'll tell you why. 1, 2, always start it from the main. Dekho, you have CHO, it will be substituent, and this will be substituent, this will be substituent. This is hydroxy, this is hydroxy. This thing I'll tell you what is this. This is amino. I told you that aldehyde can be oxo or formyl. But the question is, ma'am, where it will be oxo, where it will be formyl. See this. Whenever you have aldehyde as a substituent, if it is included, it will be oxo. If it is excluded, it will be formyl. Included means included in the parent chain, right? We will try to include it in the parent chain, but here we are not able to include it in the parent chain, right? So here it is not included in the parent chain, right? So here it is 1, 2, 3. You can't say 4, otherwise it will be only 4, right? You want to make the longest chain, now you want to include these as well. So it is 1, 2, 3, 4, 5, 6. Tell me, is there a way to include this CHO in the parent chain? Is there any way? Can I include this in the parent chain? I can't do that. Otherwise, who will take care of this OH and NH2? How will I have the longest chain? Not possible for me. That is why whenever it is excluded from the parent chain and it is acting as a substituent, it will be formyl. And that is the reason you have here 5 amino, A for amino, then you have A, B, C, D, E, F, then you have H, right? Alphabetical order you will write 5 amino, 3 formyl, 4 hydroxy, hexanoic acid, because 6 carbons are there, right? Okay, yes. Now here you have double bond also is there. So now this is substituent. Let's firstly mark the substituents, okay? This is substituent, this is substituent, this is substituent, this is substituent. It is 1, 2, 3, 4, 5, 6. So you can write firstly B bromine, then you have C chloro, then fluoro, then FH, then hydroxy. So 5 bromo, 3 chloro, 6 fluoro, 4 hydroxy. This is according to alphabetical order that I am writing it. Then this is hexanoic acid, but in hexane it is 2-ene, hex 2-ene oic acid. Oic acid, That is why it is hex to E, oic acid, and here also E will be cut. Can you tell me why E we will cut it? Because after E you have O. That is why we'll cut this E. Right? Tell me. Is that clear? Right? How can we know if it is included or excluded? I'll tell you. Let's say, I'll see if there is any example. Okay, I'll just make one example for you where it is included. Okay, let's see. I'll just make there one example. I'll make there where it is included. You will have a choice. If there is a choice of inclusion, you will include it. Let's say you have this kind of thing. This is COH, this is CHO, and this is also CHO. Okay? And this is OH. Now see, one will be included, one will be excluded. Can you see that? See, this is the main group, this is the substituent, this is the substituent, and this is also the substituent. Can you see that? Let's see the parent chain. Parent chain will be 1, 2, 3, 4, and this is 5th. Ma'am, why you have included it? I will include it. I want to make the longest chain. Here, though, it's my, I can't. Hello, hello, hello. It is audible, na? Huh. Here, even if I try, I won't be able to include it. Here, I can include it, so I will include it. So that is the reason. Here, it will become hydroxy. On 4th position, you have hydroxy. This will become formyl, okay? Because this is excluded, so this will become formyl. Formyl, okay? This will become, if you see this here, this will become oxo. This will become hydroxy. Right? Now, if you write the substituent, you will write firstly formyl, that is 3-formyl. Then you will write 4-hydroxy, right? Then you will write O, that is you will write 5-oxo, right? On 5th position you have oxo, right? That is included here. And this is pentanoic acid. Pentanoic acid. Okay? Understood now? Yes. Tell me. B will be first, so bromine is first. Yes, very good that you guys are answering each other as well. Right? Got it now? This is the example where this is also aldehyde, this is also aldehyde. But one is, this is excluded, this is included. And excluded and included will have different names. Right? Okay? That is a very important thing. Acha, now we will see some questions here. Right, after that we'll move to carbaldehyde, another main feature of your IUPAC naming. If you see JEE Mains 2023 question, it is not a very old question. Can you see that is how direct questions are asked to you? This is polyfunctional only. If you see it will COH you have this thing here. Very simple question it is, right? If you can see, I have given you more complicated questions here. They have given you simple only. Okay, so you have taken a good level questions you have done. This will be very simple for you. 1, 2, 3, 4, 5, 6. This is keto, right? 5th position you have keto. 2nd position you have methyl. So 2-methyl, keto will be there. That is not methyl. So 5 keto or oxo you also can write. So 5-oxo. Formyl will not be there. Formyl, this is 2-oxo, that means they are starting it from here. Not possible, not possible. You can see 2-methyl, 2-methyl, 5-oxo, hexanoic acid. That is absolutely correct, right? So such a simple question, isn't it? Right? Those who are saying, ma'am, C, you are taking this numbering 1, 2, 3, 4. This is the main. So you will start it from the main group. Numbering will start from the main group. Right? And that is why answer will be D is the correct answer, right? Okay. See. Then JEE 2022 question which is directly based on your priority order. Direct question from priority order they have asked you. The correct decreasing order of priority of function group in the naming of organic organic compound as per IUPAC system is what? Okay, this is the question. So firstly you have COH, then ester you have, then amide will be in the end, right? Then you have here, you have CHO, COH, CNH2, halide, cute center and ester, cute center, right? And ester, haliate. See, cute center and ester, right? Ester, haliate, chocolate ice cream. This will be anhydride. Okay. Let me see that. COH, CONH2, amide, and then you have this. So this is the wrong, right? Then you have SO3H, then you have COCl, then you have amide, then you have CN. This is seeming to be correct as of now. This is ester, then you have halide, then you have NH2, but after NH2 you can't have aldehyde. This should be before, so this is also incorrect. This is again you have this ester, after ester you have amide, then you have halide. This is also not correct. So answer is B is the correct answer. Okay, right? Okay. Don't worry, we'll do acidic strength, right? Okay, done. Now we have when you have carbaldehyde, right? You have carbaldehyde. Okay, first 11th class, right? So when C is not the parent chain, carbon of the aldehyde or these all functional groups have carbon. So what is supposed to happen? That these functional groups should be in the parent chain. But let's say they are not in the parent chain because of some problem. That problem also we'll discuss. They are not in the parent chain. Then CHO will be carbaldehyde. But then ma'am, when you said when CHO is not in the parent chain, it should be formyl. Now you are saying for carbaldehyde. There I said that CHO will be substituent. If it is a substituent, if it is not included, it is formyl. If it is included, it is oxo. There I talked about they being a substituent. Here they are all main groups. They are all main groups. They are not substituents. They are not substituents. Got it? They are not substituents here. That is why formyl, oxo, all these carboxy, right? All these names that we have given, right? That is, they are acting as a substituent. Here they are not acting as a substituent. They are the main group only, right? Now what will happen, even if they are main group, but they are not included in the parent chain because of some reason we will talk about, right? Give them carb to eat. Carb they will eat. This aldehyde will become carbaldehyde. Carboxylic acid will become carboxylic acid. If you remember, acyl chloride will become carbonyl chloride. This amide will become carboxamide. This ester will become carboxylate. This CN will become carbonitrile. Okay, give them carb. Okay, then you have, let's see how to answer. Okay, let's see what are these problems, ma'am, where they are main but they are not included in the parent chain. It's like usually what happens, right? Hero is always in the movie, right? But sometimes hero, right, is in the movie, but hero is still not in the movie. Sometimes, have you seen those movies where hero is shown as villain, right? In the end, hero will be like, I am hero, I am not a villain, right? Same thing here. Okay, hero is there, but hero is hiding, right? He is not included in the parent chain. So let's see our hero here. Two things can happen. First is if it is symmetrical. Symmetrical means like this. Now, can you answer me why this is not included? Can anyone answer me why this is not included? This is, ma'am, why it is not 1, 2, 3, 4, 5? Ma'am, it should be included, right? It should be included. Why, ma'am, then you are, why I am saying this is incorrect numbering and this is the correct numbering? You should have 3 parent chain, 3 carbon. Why? Reason is, if you have same functional group, out of that 2 groups you are able to include and 1 you are not able to include. It's like your parents have 3 kids. For example, there are 3 siblings, right? 3 siblings are there. Parents are like, this 2 siblings will take them with us to watch movie, but this 1 sibling has to stay at home. That is partiality. That is biasness. Will parents ever do that? No, they will never do that. They will be like, no, unless and until you have your exam and they have to make you stay at home. If you're free and even then they say, okay, we are going to take your brother and sister, not you, you will feel very hurt, right? Same with COH. Why you will do this to COH? That is the reason we will never include. Either we include all of them or you exclude all of them because they are all CHO. This is also CHO, CHO, CHO. So what I'll do, I'll exclude all of them. Now in the parent chain, there is no group. In the parent chain, there is no function group. When in the parent chain, there is no group and the main function group is outside the parent chain, then you have these numbers here. Then you have these namings here, right? In this case, simple, right? That will be 1, 2, 3, simple propane. You will write propane. E you will not cancel here. E will stay here. Why E will stay here? Because after E you have T. So you don't need to cancel it. So propane 1, 2, 3 tricarbaldehyde. That will be the answer, right? Then you talk about this one. Here you can have 1, 2, 3, right? 1, 2, 3. This is the parent chain. Now some students might say, ma'am, can you do this, ma'am? Please, ma'am, can you do this? Why? Why? What about this CHO? What he has done? Why you're excluding it? Why including it? You have to behave the same way with all of them, right? So that is why I will behave the same. 1, 2 and 3. Diksha ma'am is not at all biased, right? So here you have CHO, CHO. So you will write propane 1,3 dicarbaldehyde, propane 1,3 dicarbaldehyde. This is the substituent. And this substituent is what? Methyl formyl. Formyl, why? Because CHO is acting as a substituent and it is outside the parent chain. That is why it is formyl. Okay, so it will be 2-methyl formyl. Okay, that will be the answer here. Right? Okay, yes. Tell me, is that clear? Is there any problem in that? Is there any problem in that? Do let me know. Similar case, one more case I'll give you here. That is, where should I write it? I want to write it on the same page. You know what I'll do? I'll write it here. Propane 1, 2, 3 tricarbaldehyde. So we can write it here as well, right? So I'll write this here. Propane carbaldehyde. Acha, either it can be symmetry or there is one more thing that will make this happen. That is if you have a cyclic ring where you have the attachment of CHO. Now this CHO cannot be included inside the ring, right? This is 1, 2, 3, 4, 5, 6. So you will write cyclohexane 1 carbaldehyde, right? Let's say there is 1 and 3, this will be 1 3 dicarbaldehyde. Accordingly, you will answer this, right? Okay, tell me everybody. Ma'am, what happens when we take second position CHO in the parent chain? There is no possibility of taking that. How can you include all of them? 1, 2, 3, 4, 5. If you include 1, 2, 3, 4, then this will be outside, right? So there is no possibility only that you take all of them inside the parent chain, right? Okay. So that is what we call that if you have symmetry or it is a ring, then you use carbaldehyde. Tell me if there is any problem in that. Tell me students if there is any problem in that. Now let's see benzene compounds. There are some important compounds that you must know, and before going towards that I must tell you, see, according to our rule it should be benzene carbaldehyde, because here CHO is linked directly to the ring, it is not included in the ring. It should be benzene carboxylic acid, it should be benzene carbonitrile, but still according to IUPAC, it's like some people have their real name as, uh, you know, some really hi-fi name like, okay, Diksha Kaushal, right? But then they get famous by Dosa ma'am. So everyone is now calling them Dosa ma'am, right? So what is happening now? The thing which is happening that the actual name has to be benzene carbonitrile, benzene carbaldehyde, benzene carboxylic acid, but they are so famous by this name that we use this name only, right? Okay, so you can see this over here, some very important names. This is benzonitrile, CN, phenol, OH, toluene means CH3 on benzene, benzoic acid is COH, benzaldehyde is CHO, acetophenone, very important. This is the very repeated. These also still you know, but acetophenone students like gets confused in acetophenone, right? So acetophenone is COCH3 on benzene. Then you have styrene is not so important, anisole is important. Okay, where I am marking that you have to learn this, that though you can't skip. Styrene you can skip, but still if you can do, please learn that, right? Anisole is you have OCH3, aniline is NH2, then benzosulfonic acid is SO3H. Xylene is when you have CH3, orthoxylene means they are at this position. Metaxylene means it will be meta to each other. Paraxylene means it will be para to each other, right? Okay, that is xylene. Mesitylene again important. Here CH3 are at 1, 3 and 5 position. Okay, that is mesitylene. Then you have phenol, this so we have done na. Aniline we have done. Here you have nitrobenzene that you must know. Then halobenzene you have CN over here, right? Others so we have done there as well. Yes, benzamide, benzaldehyde, benzoate. See, this is benzoate. Okay, right? Tell me. Tell me. When benzene, now let's talk about this. Some IUPAC naming of benzene, let's talk about that. If you talk about when benzene is main and methyl ethyl are substituents, then what you do, right? Okay, benzene is the main and methyl and ethyl are the substituents, then what you do? See, this is benzene, right? Okay, and these are the substituents here, right? These are the substituents. So if you have benzene and you have only methyl CH3 or you have CH2 CH3, then to benzene will be main. Okay, I'll just write it here. If you have methyl or ethyl, then benzene is main. If you have methyl or ethyl, then benzene is main. So it is called as, let's say this is 1, 2, 3, 4, 5, 6. Because of alphabetical order, this E comes first. So this is ethyl here, this is methyl here. Acha, can you tell me how I will write it now? I will write it as 1-ethyl, 3-methyl benzene. Benzene. If methyl and ethyl are the substituents, then you will write benzene as the main, right? What if methyl and ethyl are not the substituent, right? You have some different substituent, then you will take this as the main. Then this will be main, that is 1, 2, 3. Now on first position you have phenyl, on first position you have methyl. This becomes now phenyl. This becomes now methyl. So it is 1-methyl, 1-phenyl propane. Tell me, is that clear? Is that clear, everybody, or not? Right? Dhanush, very good. You can also write it as 3-ethyl toluene. You can also write it that way. Okay? If you're including it like this can have so many names. If you include it like this, I am doing proper IUPAC naming. I am not including only any toluene or aniline here. If you include that, then so there is no problem. If you take this as toluene, then you will take numbering from here, right? Okay, then you can write 1-ethyl toluene as well, right? Okay, yes. See what I am saying here. If I say two possibilities are there. If benzene has methyl or ethyl as the substituent, then you will take benzene as the main, right? Okay, you can write it as 1-ethyl, 3-methyl benzene. Then benzene will be main. Others will be substituents, right? If you have some big substituent on the benzene like this, now you will take this as phenyl. That means you will take benzene as substituent. Now this will be substituent. Okay, so when benzene is main and methyl are substituent, that means you can just write it here. Benzene is here, you can just, I think English is wrong here. Okay, benzene is main when methyl and ethyl are substituents. Okay, when methyl and ethyl are substituents. Right? Okay, ji. Shall I move ahead? Tell me. Now let's see. If functional groups are present in the structure, the one ring having functional group is the main chain, right? Let's say any functional group is present here. I would actually now here, let's say, okay, so what I'll do here, I'll do one thing. I'll have to make a different, I'll do one thing here, okay? See. For that, I will make one. For that, I'll make one structure for you here, right? Which defines this rule, okay? Which defines this rule. So if you see this here, if functional groups are present in the structure, the one having functional group is the main. For example, this is benzene, and let's say here you have COOH, okay? And let's say here you have benzene, and here you have COH, and this is this part. Tell me. Now, which one will be main? Can you tell me? Yes. If functional groups are main, if I say functional groups are present in the structure, then the one having the functional group is the main, right? So this is 1 and this is 2. This becomes main and this becomes the substituent. That means this will become phenyl. So you can say the answer will be 2-phenyl, 2-phenyl. This is main, so it is ethanoic acid. Ethanoic acid, ethanoic acid, right? But if I say functional group is present, here though no functional group were present. Here I defined a general rule, right? If ethyl and methyl. Here if I say functional group is present, right? Then I will not choose that rule. I will see where functional group is present, that is main. Okay. So here function group is present. So this will be main 1, 2, 3, 4, 5, 6. So I can see this is 2 ethyl. This will be the substituent, that is ethyl. 2 ethyl, and this is nothing but this is benzoic acid. Benzoic acid. Okay, you can write it 2 ethyl benzoic acid. Right? Yes, everybody? Tell me, is that clear? Is that clear? Is there any problem in this? Now let's see the next one. If function group are present in the this though I told you. Now let's see some one, two more examples here, right? Done. Let's see those examples here. Here what you have, in this case, this is benzene where two substituents are present. But in this case, this is chloro and this is some other substituent here, right? So what you can do, right? Either if there is only this group present, then I'll take it as 1, 2, 3, and on third 1, 2, 3, 4 position you have this substituent. If Cl was not present, then I would have taken this as main. But because Cl is present here, apart from methyl and ethyl, if you have any substituent present, you will take benzene as main. So here benzene is taken as main, and here you will write this will start from here 1, 2 because it is C, this is 4, this is 5, it is 6. This is complex substituent where it is already, it is complex substituent where it is already what? Where it is already 1, 2, 3, 1 dash, 2 dash, 3 dash. 1 dash you have 1 methyl. Okay, firstly I'll name this substituent. This is 1 chloro, 1 chloro. On fourth you have a substituent. That's why you will write it in bracket. And this is a complex substituent. It is 1 dash methyl, 1 dash methyl, and overall it is propyl. Then this is benzene, right? Complex substituent. You have read benzene as well here. So many things, right? Over here, see what you have. different ways to write it. If you want to write it in the form of toluene, apart from methane, if you have any other methyl or ethyl, you have any other substituent, that will be your main. Benzene is main. So benzene is main here. So how do I write it? I will write it like this. Let's say this is toluene. So it is 1, 2, 3, 4, 5, 6. So it is 3 bromo 4 nitro, right? Sorry, 2 bromo 4 nitro, 2 bromo 4 nitro toluene. If I want to write it in nitro form, this form, I think this toluene one is better, but still if you want to write it this way, then this will be 1, 2, 3, 4, 5, 6, 2 bromo. Then nitro, so we will not use. This is 1, this is 2, this is 3, this is 4. 1 methyl, 2 bromo, right? And for 4 nitro, benzene. This also you can write if you take all of them as a substituent. Or you can take this as nitro. Nitrobenzene, right? You can take this as nitrobenzene. You can start it from here. 1, 2, 3, 4, 5, 6. Then it will be 3 bromo, 4 nitro. Now it depends upon which one they give you in the option. But the best one is this toluene one. Okay, that is the best one. Okay, right? Okay, tell me. Now this is a very important question, right? If they ask you, that means something different they have asked, right? So what you have here, priority order is functional group, then multiple bonds, then substituent. That is the priority order here. This I told you before also that this is the priority order, right? But in some cases like this, the priority order is shifted. I'll tell you why. If you see this here, right? It should be, this is the priority, this is main, and this is the substituent. So it should be 1, It should be here, no? If it is not included in the ring, we can't include it in the ring, okay? 1, 2, 3, 4, 5. Right? This way we will write it. Functional group is COH. That is why it is cyclopent, right? You can say on 5th position you have substituent CHO. That is nothing but 4-mile. So you will write it 5-4-mile. This is cyclopent. This is 2-ene carboxylic acid, right? But can you tell me one question, one answer here? Why, ma'am, I have not taken it like this? 1, 2, 3, 4, 5. Why we have not taken it like that? Why we have not taken it like that? Right? Who will tell me? Why this numbering? If you can predict that, na, that means your brain is working on next level, right? Tell me. Why we have not done it like this? Any answer? A simple reason here it is. Simple reason is now this is a substituent. Why you are thinking it as a very good, very good, very good, Nivi, because this is a substituent here. This is not a functional group. This is a functional group. So substituent will be given lower priority. Why you want to give substituent higher priority? That is the reason it is 1, 2, 3, 4, 5. That's it. Okay, that's it. That is why the answer was this thing, right? Okay. Yes, because CHO is not a group now. CHO is substituent. Then we will talk about bicyclo compounds. Guys, let me complete naming firstly, then I'll give you break. Right? Okay, let's complete naming firstly. Right? If you see this here, bicyclo compounds, fused or bridged. Right? Two kinds of bicyclo means two cycles are there. In the bicyclo compounds, they are fused means when two carbons are in common. Bridged means when more than two carbons are in common. Right? How do you write the numbering? Simple. Very simple way we will write it. Rules are select the longest ring. Longest ring you will have to select. Go from maximum to minimum. Right? Maximum to minimum you will have to go from. Means more number to less number you will have to go from. Right? For example, this is the ring. Okay. Now let's see. Longest chain you will have to select. Right? Let's select that. Let's see. I'll start from here. Right? I'll start from here. 1, 2, 3, 4, 5, 6, 7. Yes. From here I'll start now. 1. The option is either I can go here or I can go here. But what they told me, they said that select the longest ring. Longest ring you select. I said okay. Then that means this is ruled out. I'll select the longest ring here. 1, 2, 3, 4, 5, 6, 7, 8. That is how you do the numbering. Here also select the longest. So I'll start from here, let's say. Okay. I want to select the longest. Okay. So I will select 1. Here it is 1, 2, 3 carbon. Here it is 2 carbon. I'll select this one. 1, 2, 3, 4, 5, 6, 7. Then you do it from here. 8, 9, 10. Then you come back to bridged. Firstly longest, then smallest, then the bridged. Okay, what I did, see. Either you start from here, doesn't matter. 1, 2, 3, 4, 5. You can start from here as well. 1, 2, 3, 4, 5. But just remember that substituent should get the lowest numbering, right? So it is 1. Let's say here I have a substituent. Then I'll start from here. If I don't have a substituent here, then I'll start from anywhere, this or this. So I'll start from here 1, 2, 3, 4, 5. Then move to shortest one 6, 7. Then move to bridge. I can give 8, 9, 10 here as well, but then the numbering will be, chlorine will have 10 number. If I can give it 8 number, I will give it 8 number. 8, 9, 10. So got it now? How I do the numbering? How I am doing the numbering, right? Okay. This is how numbering is done. By selecting, this is in bicyclo, you select the longest ring. You firstly go to longest, then go to shorter ring, short ring, then you go to bridged carbon, bridged carbon. Okay. Now, I'll have to write it in brackets from maximum to minimum. How do I write it? Firstly, write bicyclo, then have a bracket. Here, don't include these two carbons. In the longest, you have 1, 2, 3, 4, so write 4. Shortest, you have 1, 2, write 2. Bridged, you have no bridge, write 0. Right? Here, what you have? Write longest, 1, 2, 3. It is 3. This is 1, 2. It is 2. It is 1, 2, 3. It is 3. Okay. Got it? How do I write it? From longest to smallest, in the end, I'll write the bridged one. Tell me, is that clear? How do we number it? Bicyclo and then this bracket, right? Then we write total how many numbers you have. Numbering is 8. Maximum number it has gone to 8. 8. Then you write the, if there is any main group present there, substituents you will always write in front. Right here you have substituent, that is written in front. This is the substituent, right? Here you have ene or ine, that will be in the suffix, so it will be written as oct7ene, just like you did before, right? Here also, just like you did before, it will be total 10 carbon, so it is decene. But here you have, let's say you have okay, I'll make one more question here. Let's say you have here, let's say you have CHO here, which is present, let's say CHO is present. Where should I make it present? Then it will behave as a substituent. Okay, so let's see, here you have the presence of CHO, right? Okay, now see, the numbering is restricted. Now I'll give you lunch break, right? Okay, if you want to go, take a lunch break, na? I can't have lunch while I'm teaching. You can have your lunch while you are studying. I have to done it so many times, right? So it is 1. I am not starting it from here. I am now starting it from here only. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, now if you see this here, bicyclo, because it's a bicyclo, right? Bracket will be 1, 2, 3. This is 2 and this is 3. Then if you see, before bicyclo at 8 you have chloro. So you will write 8 chloro, right? 8 chloro bicyclo 3 to 1. 8 chloro bicyclo 3 to 1. 8 chloro bicyclo cyclo 3 to 1. 3 to 3, right? Now on the first position you have CHO. How do you write it? See, you will write decan, let's say decan 1 carbaldehyde. Can you tell me why I have written carbaldehyde? Because the main group, this is main, right? This is main but outside, So don't write it fluoroformyl. This is not formyl. This is carbaldehyde, right? Okay. Understood? Tell me. Okay. If left side is benzene, then it is not a bicyclo compound. Then it will become something else only. Okay. So these are bicyclo compounds, right? Now you have spiro compounds. If I talk about spiro compounds, what you will have here? In this case, only one. These compounds have only one shared carbon, right? Like these are the compounds which has only one shared carbon. These are spiro compounds. Now, spiro compounds is select shortest ring here, opposite, and go from minimum to maximum. Okay, so how do I select it? Shortest ring, this one. So I go from here, right? 1, 2, 3, 4, 5. Okay, that's how I'll start. 1, okay, 1, 2, 3, 4. Then you have 5, 6, 7, 8, 9, 10. You go it like this. 1, and you never go like this. 1, 2, I say never. Okay, you do it like this. 1, 2, 3. Okay, that's why I started from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. Now on this side you have spiro 1, 2, 3, 4, 4, and here 1, 2, 3, 4, 5, 5. Spiro 4, 5 decay in 1 ohm. I think the compound is wrong here, right? It should be double bond O here. Okay, let's see. Here if it is double bond O, it will be like this, right? Okay, decay in 1 ohm. On first position you have ketone, decay in 1 ohm. If you have this thing here, then what will be the answer? You start from here. I'll start from carboxylic acid. If I start from here, this is 1, 2, 3, then it is 4, then it is, because now, if you go 5, 6, 7, then this will have very high priority. Then what I will do, I will start it like this. 1, 2, 3, 4, then 5, then 6, then 7. Okay. Now what you can see, this is the main group, main functional group. It is outside, that is why it is called as carboxylic acid. It is on the second position. So it is overall, it is 7 carbons, it is heptane 2 carboxylic. Instead of heptane 2 oic acid, it is heptane 2 carboxylic acid, because this is outside and it is a main. If this is main, this will become substituent. In substituent, whenever it is outside, it is called as formyl. So it will be 5 formyl, then spiro, and why 3, 3? Here you have 3 carbon, here you have 3 carbon. Okay, tell me if that is clear, do let me know, right? Okay, if that is clear, it's the number of carbons only. Yes. Square bracket, yes, this square that you have here, square brackets. In this, what you will do, here it is mentioned, minimum to maximum you have to go. Students, see, in bicyclo, you will have to choose longest ring, then go from maximum to minimum in bracket. Longest ring I'll start from here, from this point. But in the case of spiro, I don't start from this point. No, I'll start from this point, right? Or this point, or this point, or this point. I'll start from shortest, that is why either this point or this point I'll start. Because here you have double bond, that means this is the function group, so that's why I started from here. In this case, I could have started, ma'am, can I start from here? Definitely not. Either you can start from the common carbon, next to the common carbon you will start it, right? Either from here or here, right? In this case, both are same number of carbons in both the spiro. That is the reason here, because it has function group, I'll take this, I'll start from here, not from here, right? Tell me guys, any problem? Ma'am, is it numbering starting from COH? Yes, exactly, because why it is not? Because according to spiro rules, the rule is that it will start from here, 1, 2, 3, 4, 5, 6. Okay, done? Tell me. Oxo is used for both ketone aldehyde. Will it be used with included aldehyde group or ketone? No. See, oxo is used for aldehyde and ketone both, right? Okay. So ketone to oxo or keto, you can interchangeably you can use that. But oxo and formyl in case of in case of aldehyde is used oxo when it is included, formyl when it is excluded. You can't replace these two words. Keto and oxo can be replaced in case of ketone, but oxo and formyl cannot be replaced in case of aldehyde. Okay, understood? Clear? Now I'll do some few more things and then your numbering, this IUPAC naming will be done, right? Then I'll give you the break, right? Yes, right? Students, what if they ask you, right? Okay, so that's why I have included it here. Bicyclo and Spiro. It's quite simple. If they ask you, they will ask you very simple compounds. If they ask you, I have included it here because you never know. Sometimes some questions might surprise you. So I don't want you to take any risk there. So that's why I have given you very simple formula for that, how to write it. So that at least if you have an idea and what if they ask you, so that you can know that okay, this so easily. If they give you, they will give you very simple question on that. Very simple and very, very simple compound will be given. Right? Okay, because they expect that students will not know that much depth of bicyclo or Spiro. Right? So common names, this is very, very important. Right? This you must know. See, if I talk about primary carbon. So one thing now I'll okay. So primary carbon, one carbon attached here always. So to the main group, the carbon that you have, to that one carbon will be attached. When two carbon attached is this secondary, three carbon. Okay, so I'll do one thing here. Okay, instead of this way, na, I'll teach you one more different way, right? Okay, I'll teach you that way. Firstly, let's understand primary, secondary and tertiary. Primary is when you have, let's say you have some group that is attached to the carbon which is attached further to only one carbon, that is primary, right? When you have some group, it is attached to that carbon which is further attached to two carbon, it is secondary, right? When you have some group that is attached to that carbon which is further attached to three carbon, that is tertiary. I am not defining that this has to be CH3, this has to be what. I am just saying that this should be attached to the carbon and that carbon should be sp3. This is everything that I am saying, right? Primary is when your carbon is attached to only one carbon, when your carbon is attached to two carbons, when the carbon is attached to three carbons, that is tertiary. Got it? Now we will understand what is iso and neo. See what is iso and neo. If I talk about, let's say N means there is straight chain. Okay? N means there is straight chain. Chalo. If I talk about primary, they can say primary means that, for example, there is some X here that is attached to the carbon which is only attached to one more carbon, that is primary. And if it has a normal chain, all the carbons are in the state normal chain. Okay, I'll not intermix this actually, no? Then you will get very, very confused. Okay. So I'll just give you this N, right? Then you have iso. Secondary is used when a functional group is attached to 2-degree carbon, that we have seen, right? Okay, wait a minute. Yes. Wait a minute. I'll just simplify this thing for you. Yes. See what you have here. If I say there is a chain where you have this kind of situation. This is X, this is C, then this is C. Now, this is not normal, but this is primary. Okay? This is not normal. Normal means there should be no branching only. This is not normal. This is primary. Okay? This is not normal, this is primary. because in this case, the halogen is attached to that carbon which is attached to only one carbon, right? So this is under the category of primary, right? You can't say this is, beta, let me just complete names, right? After that, I'll give you the break. At least one part we'll have to do now before the break, right? If I say this part, I don't care whatever is after this. I don't care whatever is after this. It is branching or no branching, it doesn't matter to me. What matters to me is this halogen is attached to that carbon which is further attached to only one carbon. Here what matters to me is that this halogen is attached to only that carbon which is further attached to two carbon. It doesn't matter after this it has branching, no branching, this and that doesn't matter to me. I am not looking at that only, right? Similarly here, if it is attached to three carbon, it doesn't matter. If here whatsoever you have, if this carbon is attached to three carbon, it is tertiary. Okay, that thing is clear. Definitely you can watch this. That thing is clear. What is primary, secondary and tertiary? Now I'll teach you, right, what is N, iso and neo. In case of N, there is no branching. No branching. In overall chain, there should be no branching, right? If I say this here, overall it should be no branching. Overall no branching means what? Overall no branching means if I have some X here, this has to be CH2, CH2, CH3. Now this is nothing but this is N-propyl. That means there is no branching. No branching should be there. It should be a straight chain. Simple, right? Then in case of iso, you will always have branching here and you will have to the last second carbon, you will have the attachment of two methyls, and then after it doesn't matter whatsoever you have, right? If you have this group, it doesn't matter means it actually is not like it doesn't matter only. It should be like this. Like after this, you have directly halogen attached, or halogen means halogen, I am talking about any group. It can be OH also, any group, let's say. Directly that group should be attached, then it will be iso. If after this you have CH2, then that is attached, it is called as 1, 2, 3, 4. 4 carbon means it is isobutyl, right? Okay. If I say it is like this, C, CH3, then you have that group attached. Then it is not an iso. Then how you will answer that this is second position, right? Then you can't answer it that way, right? So iso is defined in this way, that this particular group is iso, right? That means here if you have this carbon, this is attached to one CH3, this is attached to one CH3. After this you have CH2. This particular group is iso group, right? Overall you have 4 carbons here, so it is isobutyl. If you have this situation, let's say you have this situation, this is CH3, this is CH3, this is H. Now what you have, this particular group where carbon is attached to 2 methyls and 1 hydrogen. It should always be 2 methyl and 1 hydrogen here. Always like that. Okay. If here you have attachment of something else, if here you have, let's say CH3, it will not remain iso. So 1 hydrogen, 2 methyl to the last second carbon, that is the iso group, right? And to the iso group, right, 3 carbons are there. So it is called as isopropyl. It is also called as isopropyl alcohol. Ma'am, is it also secondary? First, let's see, is this secondary? This group is attached to that carbon which is further attached to only 1 carbon. So, is it secondary or primary or what? Students, what they do, all N-butyl or not N are secondary, that's not right. All N are primary, that's not right. Okay? Secondary, primary, tertiary is judged on a different basis. N-iso and neo is judged on a different basis. They are all different, right? If I talk about this particular thing here, this is attached to that carbon, which is attached to only one carbon. So this is definitely primary as well, right? Okay. So if I talk about this thing, this is attached to that carbon, which is further attached to only one. This is primary. But what about this one? This is attached to that carbon, which is attached to two, so it is secondary. So primary also can be iso, secondary also can be iso. Understood? Primary has a simple way. Primary, you will judge it when it is connected to only one carbon, when it is connected to two carbon, when it is connected to three carbon. Okay. N-iso neo, how you will judge that? Let's see. Okay, I'll just make a simple data for you here, right? So that you can see it in comparison, how you will judge N-iso neo. It is also judged in a very simple way. See how? If I talk about N, this is N, this is iso, this is neo. N means no branching, no branching, no branching has to be there. It's a normal chain, straight chain, right? Iso means you will always have one carbon, the attachment of one hydrogen and two methyl. That group is iso, right? This third can be after this na, means if I say this is carbon, this is CH3, this is CH3, this is H, this is CH2, this is X. This is isobutyl. If I say this is CCH3, this is CH3, this is directly, this is isopropyl. Okay? So accordingly, this is isopropyl, this is isobutyl. Similarly, if you attach one more carbon here, that will become isopentyl. Okay? Neo is different here. Neo is when you have a carbon which has attachment of three methyl groups, but one more carbon is there. That is neo. That is neo. Okay? What is neo? Tell me, what is neo? In iso, I am saying one hydrogen and two methyl group. It doesn't matter if here you have carbon or here you don't have carbon. If here you have carbon, you will combine that carbon here, it will become isobutyl. If here you don't have carbon, it will become isopropyl. Okay? But in neo, I am specifying after three methyl group, one carbon extra should be attached here. One more carbon, it is attached to four carbons, where three are methyl. Four, we are not specifying whether it should be methyl or not. Right? That is neo. Tell me. Is that clear? So, if I say, let's talk about the neo group here. If I say this particular group here, tell me whether it is neo or what. Is this neo? No. Carbon is attached to three methyl group. It is not attached to fourth carbon. Fourth carbon is not there. This is not neo. This is the biggest mistake that students do. This is not neo. This is only tertiary. OH is attached to that carbon, which is further attached to three carbon. It is tertiary butyl because four carbons. Neo-butyl does not exist only. Neo-butyl does not exist. This is neo. Here you have the attachment of three methyl group and there is some carbon here. So if I say this particular group is neo, so this is neopentyl, right? Okay, tell me. Done? Tell me. Now see other things now. Let's see. Now let's see other things. If you have all these are data from your NCERT, right? So I have given you all of this here. what is secondary, neo, tertiary, vinyl, allyl, right? Achha, one more thing I forgot to mention, allyl, vinyl and that, right? Okay, others are to your data only from your NCRT, so I'll just show you allyl and vinyl here, right? Okay, let's do allyl and vinyl. Let's see allyl and vinyl. Okay, so you have four things here. You have four things here that we will talk about, right? Four things here that we will talk about majorly. First is allyl, very important. First is allyl, then there is vinyl. First is allyl, allylic, then there is benzylic system, right? Then there is which system is this? Arylic system. Then there is vinylic system. Okay, so what you have here, let's talk about that, right? Little bit faster. Okay, I'll do that, right? So if I talk about allyl, right, beta, I have to, I'll chalo try, I'll do faster, right? Okay, actually when I go fast, then you start asking me so many queries, and that's why I'm being slow, right? Okay, so if I talk about allyl, allyl simply means you have a C double bond O, and to this carbon double bond O, you have carbon where that group is connected. Then this particular carbon is called as allylic carbon. For example, this is the thing, right? Here you have, let's say, this double bond. To this carbon is connected where halogen is connected or some group is connected. Or let's say this carbon is also allylic. This carbon is also allylic, right? When you are not connecting the external group to the double bond, but to the carbon next to double bond. When you are connecting it directly to the double bond, right, that is vinylic. For example, here I am connecting it directly to the double bond, that is vinylic. Benzylic is when you have a benzene, right, and you are connecting a carbon here to which the group is connected, that is benzylic. And here again you have benzene, and directly to the benzene you have the connection of that group, that is aryl. Okay, tell me if that is clear to all of you. The carbon which is connected to the sp, no, allylic is to a carbon which is connected, yes, that is correct. It is sp3, this is sp2, it is sp2, this is sp3. So these two are connected to sp3, these two are connected to sp2, right? Okay, that becomes the thing here. Now I have given you all this data here of your NCRT so that you don't skip anything, right? This is your homework, right? Like what all you have to do is, I have told you what is vinylic, what is allylic, right? What is tertiary, what is neo, what is secondary, right? You just have to see whether you are able to understand why their names are like that. Ortho means always remember what is ortho, meta and para. If I talk about ortho, meta and para, so if I say this is the position, this will be ortho, this will be meta, this will be para. Ortho, meta, para. Okay, that is how you name it. So you can write it. Okay, all these names are from an NCRT. I'll just show you that. All these names. Orthochlorotoluene, benzyl. Why this is benzyl? Because this is benzylic system, right? Then remember that this is CH2Cl2 is called as methylene chloride. That is a very important common name, right? This is N because it is simple chain. Carbon tetrachloride. These are called as chloroform, bromoform, CHCl3, CHX3 is haloform basically, right? So these are the names that you have. Then if I talk about this thing, right, common names of haloalkanes and haloarenes. So now this is the very, very important data that I have, right? So if I talk about this, these are meta to each other, that is metabromodiene. This is symmetrical, that is why it is called as symmetrical tribromobenzene, right? Then you have from alcohol phenol ethers, you have some very, very important data. Again, what is N, what is iso, what is N, what is secondary butyl, all these structures. Because this OH is connected to that carbon which is further connected to 2 carbon, it is secondary. It cannot be iso because C is not connected to 2-methyl. But here C is connected to 2-methyl, so that is iso. This is normal, so it is N. This is normal, so it is N, right? Okay. Then isobutyl, because this group is iso here. That is why it is called as isobutyl, because here CH is connected to 2CH3 here. That is why it is iso. Can I say this is neo? This is not at all neo. Why? Because fourth carbon is not there. It is only connected to 3 carbons, so this is called as tert, right? Then if I talk about, this is ethylene glycol, important. This is glycerol, this is important. These are some important common names that you have, right? Okay. Then you have, this is called as phenol. When you have CH3 and OH here, this is called as orthocresol. Meta, they are meta to each other. This is metacresol. This is para to each other. This is paracresol here. Then you have catechol. When two OH are ortho, when two OH are para, that is resacinol. When two OH are para, this is meta na, this is hydroquinone or quinol, right? Okay. Then you talk about ethers here. So these are some of the important names. Okay, so from your NCERT as well, whatever you need, I have written it here. I am marking it also that you must remember. Like this anisole, so you can't skip, right? Then the common names, anisole you must remember, and phenetol. Phenetol also, this is your PYQ where they have asked you phenetol. Okay, so they have not asked you from some out of the NCERT thing. This was from NCERT only. Okay, so you must remember these common names: phenetol, then anisole, then other are to simple, right? Then vanillin you can skip, but cinnamaldehyde, because cinnamic system now we will understand, it's something important in reducing agents, will understand about this, right? So this cinnamic system you remember, right? Salicylic aldehyde, though it is also there in your reaction part, so you'll remember it from there as well, right? Then you have acetaldehyde, benzaldehyde. This should be on your tips. What is the name, right? Okay. This is like beta bromo, on beta position, your bromobutyraldehyde. This is also simple, right? Then acetone you must know. You must know acetophenone, OCOCH3, right? Propiophenol, propiophenone. Then you have benzophenone. Okay, so all these 4 common names you must know. They are very highly repeated, very highly repeated names. Then guys, you have, see this, formaldehyde, acetaldehyde, right? These are very much repeated. Acrolein, this is repeated. This is also your PYQ, right? You must know this. If you don't want to remember all of that, please remember whatever I am underlining. Okay, acrolein is important. What if you have answered this? What if in some reaction this answer is made? They will give you which of the following is the product. You don't know what is acrolein, how you will answer that? Okay, so this is important. Then you have this to simple only, right? You don't have to cram. Mesityl oxide. Okay, mesityl oxide. Remember this. What is mesityl oxide, right? Then out of this, so isoethyl, it's the same, right? Okay. Then you have, okay, just remember one thing. RNH2 is amine. If you replace this hydrogen with some alkyl, that is called as N. Okay, so that is why here it is, the longest chain is this thing. So it is called as, these two are the substituents here. So N diethyl, this is butylamine. Got it? So here just remember this thing, when you replace H here, more than one alkyl group is there, that is NN. Okay, because on N position you are substituting. Then you have this aniline. Okay, para-bromo, N dimethyl is also very famous one, right? Okay, otherwise you should go through all of them. That is why I have written it here, right? Okay, so all the names from your NCERT, more than this you don't need to do, right? Okay. Let's see some questions here. Yes. Done? Yes. No, cumene is something else. I'll tell you when we do cumene process now, we'll understand that. So JEE Mains 2025 question that was asked here, what is the correct IUPAC name of this one? Right, so here if you see, this is COH, it will start from here, then it can start from here or here as well. So this gives it less numbering, so it is 1, 2, 3, 4, 5, 6, right? So on second position, you will have hydroxy, B for bromo, this is B, this is H, this is N, right? So you will choose B, so it is 3 bromo, 3 bromo, 3 bromo, these two are ruled out, right? Then after B you have H, and hydroxy is at second position, so it is 2 hydroxy, 5 nitro, benzoic acid. Such a simple question, right? In last year they asked you, so I am telling you, I have taught you very high level, good level question. So easy questions, so you will do like this, right? Difficult question also I have prepared you for that. Okay, so don't worry, you are already prepared for IUPAC naming. You can see this over here. JEE 2025 question, this is based on sp to sp3 hybridization. We have discussed that in chemical bonding. Right now I'll tell you how to do from here. Right, so here firstly, so you need to understand what is this compound they are asking you. They are saying 3,3 dimethyl hex 1 in 4 ine. So firstly there is hex, that means 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, hex 3, 3. 1, 2, 3, let's say here you have methyl, here you have methyl. Right, then you have 3 dimethyl hex 1 ene. 1 ene, that means here you will have ene, and this is 4 ine. 1, 2, 3, 4, 1, 2, 3, 4. So here you have a triple bond, right? Okay, so now they are asking you, what is such a simple question, guys, right? Okay, this is H. I just want to complete the tetravalency 2, 3, 4. This is 2. Now, who will tell me whether there is how many SP, SP2, SP3? Right? Okay. Good attending this. Great, great, great. Right? Guys, chalo, I'll not say anything. Right? Okay, I'll not scold you now. Right? Please see this. Right? Do you want me to behave like that? Ki IUPAC naming half I'll do now, then I'll give you 30 minutes break. Do you know that my throat is also paining? Right? Do you think it is easy to, like, take out your throat and speak continuously? No, right? I'm doing that. Is it my exam? No. Have I taken money from you? No. I am doing that. I am standing here, right? Why? Because I want that the flow should not break, so that you get everything, right? I can't leave this in between, right? So I have to complete that. I know when to give you break, right? It's not like I have camera on and you can't take out some biscuit and you can't eat that, you can't eat some milk. It's not like that. You can have that because I am writing, I am in front of the camera, you are not, right? Okay, so have that kind of thing. And an essay you don't complete organic in one day, right? So you have to have the patience. So you guys have already answered it. I'll tell you. So if you have 4 sigma, it is sp3. If you have 3 sigma, it is sp2. If you have 2 sigma, it is sp. So it is 1, 2, 1, 2, 3. It has 3 sigma, it is sp2. It has 1, 2, 3 sigma, it is sp2. This is sp3. This is also sp3. This is also sp3. This has 2 sigma, it is sp. This is sp. This is also sp3. So how many sp3 are there? 1, 2, 3, 4. 4 sp3, right? You guys are answering C. Have I done any mistake? No. 4, what they are asking, there are this hybridized carbon atom. 4 sp3, so answer is coming out to be A only. I don't know why you guys are answering C, right? Then you have sp2. sp2 is this and this. These two are sp2, 1, 2 sp2, right? 4, 2. And how many sp I have? 2 sp I have. So answer will be A, right? Okay. Done, right? So now let's see this question here. After that, I'll give you this is the last question. After that, have your lunch, Come back and we'll start GOC, right? Okay. So match list 1 with list 2. If you start it here, match list 1 with list 2. Let's see here what will happen. List 1 with list 2. See, first thing is this is a spiro compound. As you can see, it only one carbon common. So this is definitely a spiro. See, if I don't teach you spiro, this is asked in 2022. Though naming they don't ask, but you should know what is spiro, what is bicyclo. See, they have asked you this. Okay. Now, surprisingly, of this year they ask you spiro and bicyclo naming. Then you will be like, Diksha ma'am, you said everything will be from the video, but it was not there, right? So I don't want you to feel depressed in the exam, right? So C is spiro, bicyclo. This is like two carbons in common. So this is bicyclo, right? So you can see C is one where? C is one here, C is one here. So these two are eliminated, right? Then B is 4 here. So answer is C is the correct answer. We have our answer. Then you have non-planar heterocyclic. See, this is planar because this is sp2, this is sp2, this is sp2, this is sp2. sp2 means trigonal planar, so it is a planar structure. Okay. Even here, I'll tell you this why it is planar, because whenever now this is a very simple rule of organic chemistry. The lone pair which is involved in delocalization is not involved in hybridization. So this is involved in delocalization. So this is not involved in hybridization. This is involved in hybridization. So this oxygen has 2 sigma plus 1 lone pair. That is why it is also sp2. That is why this is planar. Okay? So they are saying it is aromatic as well. Yes, this is planar. All of this is planar. Is it aromatic? I'll teach you that. Don't worry. I'll teach you about aromatic character, but as of now, you have your answer here. This is aromatic. Why it is aromatic, that I'll tell you. Heterocyclic is whenever in place of carbon, you have any other oxygen or nitrogen compound, that is heterocyclic compounds. It is non-planar because this is sp3. This is also sp3. Tetrahedral, hai na? So it is non-planar. So it will be this. Why this is aromatic, that we will understand in GOC. Okay? PCC followed. Yes, very good. Okay? GOC, now you're going to have fun in GOC. But before that, you guys, ma'am, please give us lunch break, ma'am. Why are you doing this to us? Okay. So now let's have lunch, right? I'll also have my lunch. You also have your lunch, right? Okay. Option C, definitely that is correct. Definitely that is correct. Now after lunch, we are going to start with GOC, right? GOC and isomerism we will cover, right, after lunch, right? Okay, everybody. Now I think the class will go up to 12 a.m. Okay, will you be there? Right? I want to complete it today itself. I don't know what will happen to me after that, but I'll do that. Okay? Oh my God. Ma'am is already losing balance. Okay. Benzyl propane. Benzyl, if you have benzene, okay? On benzene, if you have propyl, those who want to go can go. I'm just answering the queries here. Okay? So now I'm not doing GOC. You can go and have a lunch, right? So I'm just answering this query here. If you have this thing, I told you, if there is methyl or ethyl, then only choose, if you have methyl and then choose benzene. Now you will choose here 1, 2, 3, and this will be not benzyl. When benzene is the substituent, that is called as phenyl. Benzyl is this compound. Benzyl is this thing. Benzyl is this thing. This group is benzylic group. Okay? So this is phenyl. This will become phenyl. So answer will be 3-phenyl propane. Propane. Okay? That will be the answer. Okay? Right, everybody? Tell me. Right? Don't worry, I'll make you Mechanism Pro. Now we are going to see you at 4 p.m. I think that is enough. 4 p.m. Right, I'll see you all at 4 p.m. Right, that is enough. We will be with you, doesn't matter, you tell, we learn. Very good. That's the energy that I want from you, right? Very good. So now, do you want like 4, 5, like 25 minutes will be also good, and I think 20 minutes. I'll have lunch now only, है ना? So yes, okay. So now you guys also have your lunch. I'll just give you the break time. Okay, this is the break time. Why break time? We'll say lunch time. Chalo, we'll say break time. Okay, see you all. Done? What lunch? Yes, you'll have to have your lunch, right? I'll also have my lunch now, right? Okay, 20 25 minutes. Do you want it? Chalo, 4 5 I'll say. I think more than that you don't need, है ना? Either you will have to make lunch yourself, then to I can say, है ना? For eating I think this much time is enough. But a more time I give you now, more delayed will be, lecture will be more delayed, right? Okay, yes. So I'll see you all at 4 5 p.m. sharp here, right? Extra 5 minutes I have given you, so sharp I want to see you here. Hello. Hello everyone. So I am back. Do let me know if I am clearly visible and audible to all of you so that we can start with GOC. Yes, everybody, let's start with GOC. Just give me that green signal that yes, ma'am, you are audible, you are visible, right? So that we can cover GOC and isomerism. So the target for GOC and isomerism that I have kept is 7 p.m. Okay, let's cover it by 7, or I would say 6:30 also we can do it. 6:30 p.m. let's complete it. That will be your second break. Okay, after that we'll start with hydrocarbons and all. Yes, everybody? Yeah, I had my lunch. So, now first is GOC. For GOC, see one thing. You have reactants. Reactants react with reagents, right? Then from mechanisms, right, we make the product, right? And the questions that they ask you are based on products. So GOC is not only important because individual questions are asked. Definitely you will see in 2025 there were like only two shifts were there where GOC direct questions were not asked. Otherwise, from GOC, 3 to 4 questions are easily expected, right? Direct questions, I am saying. See, direct matlab that I am not saying GOC application in reaction, that is there, but direct questions are also asked, right? Okay. So for the reactants, we will see all the different functional group: alkane, alkene, alkyne, alcohol, phenol, ether, as aldehyde, ketones, carboxylic acid, amines. That individual chapters we will study for the reactant, right? Then reagents also I'll teach you there, like nucleophile, electrophile, that I'll teach you there. Then guys, you have transition state. This is the mechanism. Now here you have the formation of intermediates, and in GOC we mostly talk about intermediates, like what is the stability of intermediate, because intermediates is a part from reactant to products. You have intermediate, so you must know which is stable, which is non-stable, and for the stability of intermediate you go through these electron displacement effect that are here. So if you talk about two kind of electron displacement effects are there, one is permanent, other is temporary. Permanent effect can be inductive, mesomeric, hyperconjugation. Resonance and mesomeric is the same. I'll tell you the slight difference that they have, right? Then you have electromeric effect here, right? If you talk about this, we'll talk about later which one is more and which one is less. Firstly, let's talk about what is inductive effect, right? Inductive effect is based on the electron negativity of the atom. So if you say this is carbon, right, and this is halogen, let's say here the electrons are placed somewhat here. Let's see, the electrons are placed here, right? Now because now it is connected to some electron donating group that is giving the electron, what will happen? The electrons will be displaced here. So the difference that they have is delta x, that is displacement of electrons, right? Here you have electron withdrawing effect, the group that withdraws the electrons from the carbon. So initially if I say here you have the electrons, let's say after withdrawing the displacement happens and it comes here, so this is the delta x, right? So overall we can now understand one thing, that two things are there: one is electron donating, one is electron withdrawing. The one that is electron donating group, it shows plus I effect. The one that is electron withdrawing shows minus I effect. Plus I effect and minus I effect is there. Then it operates only on the sigma bond. Pi bond it will not operate. Then distance dependent. That means if you talk about the second carbon, third carbon, it will still be, effect will be there. So it's like when you have control over only your neighbors. You can't ask the some other society to operate like that. You can ask your neighbors not to do this, right? Do this, matlab, you can ask them to, not to park this car here or there. You can tell them, but you can't tell this to some other society, right? So more is the distance, less will be the effect. It is a distance operated effect, right? Then results in development of partial charge. Like here you will have, because it is donating, so here you will have partial negative and this is partial positive charge. Here you will have partial positive and this will be partial negative charge, right? If you talk about what are the groups that shows plus I effect, then simple thing is plus I effect. Plus I means electron donation. For electron donation, they should be having some electrons, and for that they will be negatively charged here, right? So that is why negative charge. But now the second question is, ma'am, why they have this kind of order? So the simple way of answering that is, if you talk about this, which is more electronegative, oxygen, or you can say carbon less, then nitrogen, then oxygen. Now that means this carbon is not electronegative. This carbon is not like I want to keep my electrons with myself only. It is like, okay, I will donate, right? So he will donate. This nitrogen is like, I am electronegative, so I am not that much capable of donating as compared to carbon. And oxygen is like, I am very clever. I am like, I can't give you my electrons. So that is the reason this will be least. And here, ma'am, why about these two carbons? This is more and this is less, because here there is delocalization. Here the electrons are delocalized on these two oxygen. That is why the oxygen does not have all the electrons with itself. It is sharing those electrons with that oxygen as well. And that is why it is not completely available, right? Okay. Then this thing. More is the degree, more is the plus I effect, right? So here you have CH3 that has more donation here. 3 CH3 means more donation. 2 CH3 means less donation. Only 1 CH3 you have. So remember one thing, it will be 3 degree, then 2 degree, then 1 degree. But if same degree, then what you will do? Then you will say plus I effect depends upon number of carbons. Okay, so they both are primary, but this has more number of carbons, so it has more plus I effect. Is that clear to everybody? Right. Tell me, don't spam anything in the chat box, right? Then this one is tritium, deuterium and hydrogen. This is also very important, that tritium, these are the isotopes of hydrogen. Tritium has maximum, then you have deuterium, then you have hydrogen, right? Now let's talk about minus I effect. If you talk about minus I effect, what is this minus I effect? Let's talk about that, right? Minus I effect, right? That means they want to withdraw electrons. They will be electron negative. So this is basically the order of minus I effect. If you see, right, here you have OR2, OH2, NR3, NH3, right? This is the order. This is the order. Okay, this is the order of all the minus I groups over here, right? You can take the screenshot and that will be very, very useful for you, right? Okay, now next thing is how it is obeyed, right? So I'll give you one simple way that how it is obeyed. See, if I talk about distance and weak multiple, you have, okay, let's talk about these two groups, which has more, which is, I would say, more stable, right? For stability, what we see, stability, always remember, whenever you have carbocation, you give the electron to carbocation, this will be happy, because when carbocation, you take it as a money. When you give money to someone, they become happy. When you take out money from someone, they become sad. Okay, carbon ion is different. When you give money to carbon ion, this becomes unhappy. When you take, this is not money, this is like a stress. Okay, carbocation is like money and this is like stress. Okay, remember this is very useful, right? Carbocation, when you give it, it is happy. When you take it, it is sad. Carbon ion is like stress. When someone gives you stress, you are unstable. When someone takes away stress from you, you are stable. Right? Okay. Now, let's see this thing. If I have to mention which one is more stable here. Right? So, if I see this here, this has minus I effect. Right? This also has minus I and minus I effect, as you can see from here. Which one has more minus I? Fluorine has more minus I as compared to chlorine. See, this now you have to learn it yourself. That's why this I am giving you the table. This is your homework. After the class, you have to revise everything, all the data that I have given you. Okay. So now, here it is 2 carbon away. Here it is again 2 carbon away. But here you have only 1. Here you have 2. So which one? This is strong. This is strong minus I, but only 1 here. This is weak, but here you have 2. So if you have weak multiple group, that is more dominating as compared to single strong group. That means if you have one side, you have someone very strong, only one person. You have weak, but 2 persons are there, right? So that way, this will be a better minus I effect, right? That is the reason when you take out electron from carbocation, it is not stable. It becomes very, 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 very unstable, and that is the reason, right? When you take out electron, it has more minus I. You can say more minus I. This has more minus I. It will take out the electron. It will make it very unstable. So that is more stable, right? Okay, right? Done. Now, if you see this from here, this is about distance, right? So if you see after 1 carbon, you have a strong group, right? This is next to it, you have a weak group. So now which one will dominate? Will the distance will dominate or the strength of minus I will dominate? Because these are important here, these are little abnormalities here. That's why I have specially mentioned it here. So in this case, you have minus I, but this is strong, but here distance is more. So distance always dominates over these two things, and that is the reason. Here you will say this will have, because this is closer, so this will have more effect, and that is the reason here the minus I group will be more strong, and that is the reason this will be more stable. Tell me if that is clear or not, right? Okay, tell me everybody, distance, number, and then power. Yes, DNP. What you say? DNP. What is this? Distance, DNP. Distance, then number of groups, then power of the group, right? Okay, DNP. Spam the chat box with DNP, right? Okay, now let's talk about resonance. If you talk about resonance, resonance is delocalization of pi bonds. So in this case, what happens? The atoms will stay on the same place, right? The sigma bonds will not change, they will stay on the same place. But what will change here? The pi electrons are going to change here, right? So there are 3-4 cases, so I'll tell you about that. Firstly, let's talk about alternate double bonds, right? Double bond, let's firstly talk about double bond and p orbital. If you have double bond, then single bond, then p orbital. So basically what you have, double bond, single bond, lone pair, double bond, single bond, negative, double bond, single bond, positive, double bond, single bond, free radical. These are the 4 cases that you have. That means this p orbital can be 2 electrons with a lone pair or negative charge, or 1 electron or no electron. That is carbocation, right? Okay. This is called as carbocation. This is called as free radical. This is carbanion. This is with a lone pair. For this, remember one thing. What is the difference in lone pair and negative charge? And negative charge. What is the difference in lone pair and negative charge? Students, see, both of them has 2 electrons. But what is the difference here? That in case of lone pair, both electrons are off. Like you have oxygen, it has lone pair. So these lone pairs are from its own octet. It has not taken it from someone else, right? So it is its own electron. Both electron are of its own. Both electrons are its own. Are its own. If you talk about negative charge, that means some bond was there, right? Two electrons were there, 1 and 2. That means initially there was some bond here. A and B had some bond. Covalent bond was there. One electron was of A, other electron was of B, and B is more electronegative. That is why it took both the electron and it became A positive and B negative. Now both the electron are not of this B. One electron is of B, one electron is of A, right? Only one electron is its own. That is negative charge. Okay, understood? Now it will make it easy for you to understand that, right? One can involve in resonance, ma'am. Yes, only one will involve if something has two lone pairs, right? So if you see double bond, single bond, lone pair, what will happen? Lone pair to bond pair to negative charge. Okay, so in this case what we are doing, lone pair to bond pair means here you will have pi. Now whenever lone pair is being shifted, always there will be positive. See, if you see negative, this is lone pair, this is negative to bond pair to negative. Now if you see this here, whenever negative is being converted to pi bond, this is neutral. When lone pair is being converted to pi bond, lone pair is being converted, this becomes positive. Simple reason is this one, because if you have money of your own and you have to give it to someone, you will feel like deficiency. If let's say you have shared it with someone, let's say 10 rupees were of your own and 10 rupees were of someone, then you have to give 20 rupees to someone else. You'll still be like, okay, only 10 rupees were of my own, right? And that is the reason here when negative charge, always remember when lone pair is converted to pi bond, it is neutral. Positive. When negative is converted to pi bond, it becomes neutral here, right? Rest is same. Pi bond is always converted to negative charge, as you can see this over here. Then you have this thing. In this case, what you have, a double bond, single bond, positive charge. Now these two are almost same. What will happen here? Pi bond will shift here. Because see, electrons only can shift, right? So here, instead of pi bond, you had unpaired electron. That's why unpaired electrons were jumping. In this case, this is free radical. No, this is carbocation. So they don't have electrons. So what will happen? Pi bond will shift here. This will become pi bond and this will become positive, and that will be the case. Here pi bond will shift here. But you know how it will shift? It will be homolytic cleavage. Homolytic cleavage means when a bond will break and only one electron is here and one electron is here. Here one electron from this and one electron from this, and this will become a free radical. Tell me, is that clear? Is that clear? 4 kind of resonances we have just seen, right? 4 resonances we have seen. Then you have alternate, double bond, single bond. In this case, what you have, this bond is shifted here and this bond is shifted to the negative charge. This is negative. Whenever someone has electron, they become negative. Whenever someone gives electron, it will become positive here. That means it will become carbocation. And also one more thing, charge will remain same. Neutral. This is overall neutral. This is overall negative. This is overall positive. This is overall free radical. Charge will remain same. This is overall neutral. This is overall plus minus neutral, right? Then you have very important back bonding. That is a case of resonance only. In this case, you have lone pairs. Then 2 things that are next to each other, let's say A and B. One will be electron rich, one will be electron deficient. If these 2 things are side by side, that is called as back bonding. Now, a very important thing from inorganic chemistry that you will apply here, that second element of group will have vacant d orbital. This is from p block that you apply this. Now I'll tell you what is this is a very important line that we apply from inorganic chemistry to organic chemistry, right? Okay. So for example, this is electron deficient because it's a carbocation. This is electron rich because it has lone pair. So what can easily happen? This will donate its electron and here it will become pi and this will become positive, right? One more thing I am writing here. Oxygen always form. Oxygen wants to form two bonds. When it is forming three bonds, it will be negative. When it is forming three bonds, it will be positive. When it is forming one bond, it will be negative. Similarly, nitrogen, it wants to form three bonds. When it is forming four bonds, it will be positive. When it is forming two bonds, it will be negative. Okay, these are some really, really important things that will help you in organic chemistry. It will help you. So when it is forming three bonds, 1, 2 and 3 bond, 1, 2 and this is third bond, it will be positive here, right? Now in this case, this is electron rich and boron because it has only 6 electrons. Now octet is not completed, so it is electron deficient and that is why this will take place, right? And one more thing you must know, that is, for example, you have CH2. Now C, let's say it is connected to Cl. Now tell me, is it possible for the back bonding to take place? Or let's say this is SH. It's very famous. Tell me, back bonding will take place or not? Yes, it is going to take place because this is the second element of the group. So it is vacant. You have chlorine here, that will also take place. You have phosphorus here, it is also having vacant d orbitals. It is also, when there is vacant d orbitals and negative, it will back bonding will take place, right? Okay. Yes, everybody, this shifting will also happen here, right? Next is crossed and extended structures. If you talk about crossed and extended structures, right, here the simple thing is, crossed means this resonance can also happen, this can also happen. Extended means it will happen like this. It will shift here, this will shift here. It is extended. Always what you remember, that extended structures are always more stable as compared to crossed structures, right? This way directly they can ask you, right? Now let's see the stability of resonating structures. Based on this also they ask you, very simple, this is very simple questions they ask you, right? Okay. Right? Yes. So if you see this here, Comed K, then you need to apply. I'll make a video on that, don't worry, right? Okay. Stability of resonating structures. First thing is, always see, this is step by step you have to see. Okay, you have to follow this step by step. Firstly, you will see, is there any neutral structure? This is of same resonating structure I am telling. Same compound has different resonating structures. Which one is stable? First, you will see neutral. If something is neutral, that is always more stable as compared to charged. Let's say all of them are charged. Then what you will see? You will see the number of pi bonds. More the number of pi bonds, more will be the stability. Then, let's say, ma'am, number of pi bonds are also same. Then what to do? Then negative charge more stable down the group. Remember, positive charge, negative charge is stable down the group and along the period it is more stable. For example, you have oxygen, sulfur, and here you have oxygen, this is nitrogen, this is fluorine. Along the period, negative charge is more stable. That means it is because of the electronegativity. And down the group also, sulfur negative charge is more stable. Why? Because of the size. Okay, because of the overlapping, right? Okay. Then more charge separation. Charge separation means what? Let's say you have two compounds here. Let's say here it is positive and this is negative over here. Here this is positive and negative. So more is the charge separation, less is the stability. So here less charge separation, more will be the stability. That means the distance between the charge, the less it is, more will be the stability. Okay, that is charge separation. Then let's talk about this for benzenoids, benzenoid rings, right? Stability is equals to benzenoid means these kind of rings. Okay, these are benzenoids. For benzenoid, where you have benzene rings, more than one benzene ring, stability is equals to number of more the benzene ring, more the rings, more will be the stability, right? Then separated rings are more stable than fused. Separated means if I have this thing, this is separated and this is fused. This is fused. Okay, so separated rings are more stable as compared to fused ring, right? Okay, tell me, that is clear everybody? Then equivalent resonating structures, such equivalent resonating structures are what? C. If you talk about C double bond O negative, right? What will happen here? This will shift here, this will shift here. This will be RCO negative, this is double bond O. They are equivalent because here the charge, they're both looking the same, right? Here also O negative, one double bond O negative, one double bond O. There is no difference in this structure, right? That is why they are equivalent structure. And you know, even if you have, this is a very important line from your NCRT, phenol, carboxylic acid, or you can say CH3COH is more acidic as compared to phenol. This has 5 resonating structure. I will draw it as well. This has only 2 resonating structure, but they are equivalent. But they are equivalent. So equivalent resonating structures are more stable, and that is the reason CH3COH is more acidic as compared to phenol. Even if it has 5 resonating structure, this has only 2. Right? Right, everybody? Now, before moving ahead, let me also tell you about the dancing resonance. So, where should I tell you about it? Wait a minute. Okay, so I'll tell you about dancing resonance. Here, moving like with so much speed, huh? Okay, so I'll tell you about dancing resonance. I'll tell you on the next, right? So firstly, JEE 2024 question, which is based on the correct stability order of following resonating structure. So that is based on the stability of resonating structures, right? Okay, right, okay. Tell me. Now, if I talk about the stability of the resonating structure, Piyush, if I shows you if my energy is low, you feel this energy is low, then what I can do? I can't do anything about it. Okay? Content is low, then you can tell me. You're not able to understand, then you can tell me, right? Okay? Not able to understand, then you can tell me, right? If you think that ma'am will, loudly speak, right? And after that, 2-3 hours only, I'll be able to speak loudly because I am a human. I am not a robot, right? Then who will complete full organic? Sometimes you people say few things that literally irritates the other person, right? Okay? So think before speaking. You are not kid, right? You should have that much sense. So JEE 2024 question you have, that is correct stability order of the following. See here, this is neutral. So this will have maximum stability. So third will have maximum stability. All of them are eliminated. C is the correct answer. Then after that, oxygen has negative. Here carbon has negative. This is carbon, this is oxygen. Along the period, negative charge is stable. So this will be more stable here. Then you have 2, then you have 1. Answer is C is the correct answer here. Right? Okay. Now, let's talk about what is the difference in resonance and mesomeric effect, right? See, resonance is not because of some other group on the benzene ring. So that is, on benzene ring you have resonance, this bond is shifted here, this is shifting here, this is shifting here. It is because of the alternate double bond single bond. It is not because of some other external group here. But when you have resonance because of some external group here, see, this external group here, this is causing the resonance. When you have resonance because of some external group, that way we define it as mesomeric. Okay, this is external groups that are causing the resonance here. Now, ma'am, who will tell me whether it's plus M or minus M? Do I have to cram it? Let's see. So if on the benzene ring you have a group that has lone pair of electrons directly, you have benzene ring, on that you have a group where you have lone pair of electrons directly, that will always show plus M. Why? This will shift here, this will shift here, it is plus M, it is giving electrons to the ring. And what about this one? You have benzene, here you have a group, that group is less electron negative as compared to this X here, right? So this G is less electronegative as compared to X. That is why this X is like, give me the electrons, and this is always attached with a multiple bond. When to the benzene ring you have attachment of a group that is attached to a more electronegative atom with a multiple group, that is called as minus M. It will take out electrons, it will take out electrons from here. That is minus M. The examples are very simple. I'll show you. So if you talk about definition here, operates on pi bond, only pi bond this will operate. Permanent effect it is distance dependent. Actual charge development is there. If you see, actually there will be charge development. I'll just show you here how actual charge development is there. This donates pi electrons to the conjugated system. This withdraws pi electrons from the conjugated system, as you can see. This is donating, that is withdrawing, right? Then see, what are the, here you don't have to learn all these things. Nobody is asking you to learn it. Simple thing is just see if they have lone pairs. Directly, negative charge and lone pair is one on the same thing. Lone pair, it has lone pair, lone pair, lone pair, lone pair, right? Ma'am, why phenyl? If phenyl is attached to some phenyl, directly, no. So it does not have lone pair, but it has pi density, no, right? It will take out the, it has pi density, so it can give the electrons here, right? So phenyl also we'll talk about. Fluorine has lone pair, lone pair, lone pair, all of them has lone pair. This has lone pair, all of them has lone pair, right? Again, all of them have lone pair, lone pair, lone pair, lone pair, lone pair, okay? All of them have lone pair. This has negative charge, right? And that is why it is going to give. Like for example, you have phenoxide ion like this, right? You have phenoxide ion. It will give the electron, right? Okay, understood? Now, minus M effect. Whenever you have the attachment of a less negative to a more electronegative with a pi bond, all of them are the examples of that. What is important for you to know? This is CH3. Why this CH3? If you have on the benzene ring, if you have CH3 here positive, right, then what will happen here? This is going to take out, this is supposed to be CH2, okay? This will take out the electron here. That is why this CH3 positive shows minus M effect, okay? Similarly with B, boron, it is electron deficient, so it will also take out the electrons, right? Okay, understood everybody? Now let's talk about activating. Activating means, see, plus M effect always, plus M effect are activating groups and ortho para directing. See, one thing, this is generally we are saying, plus M, usually what it do, what it does, so here it is donating, plus M is donating, so it is activating this ring. This is taking out, so it is deactivating this ring, right? So this is activating and this is deactivating. So see one thing. Generally, I am saying plus M are activating groups and ortho para directing. Now, why, ma'am, they are ortho para directing? Someone who can tell me why they are ortho para directing and they are meta directing? Anyone here? Firstly, I'll talk about why this is ortho para directing. See, you have any group I'll talk about. Let's say I'm talking about OH, right? You give the electron here. Can you see on the ortho para position? Right, this is negative, this is double bond O positive, right? Can you see again, this will shift here, this will shift here. Can you see that on the ortho para position, meta position, nowhere you are getting the negative charge. You're always getting the negative charge on the ortho para position, isn't it? 5 resonating structures. This is double bond OH, this is positive, this negative, it will shift here, it will shift here, it will give you this thing over here. Tell me, can I say that ortho para has negative charge, so that means it is ortho para directing? Can I say that? Is that clear? It is ortho para directing, isn't it? Tell me, everybody. Confidently we can say it is ortho para directing, right? Okay, why? Because ortho para position, it is having negative charge. Okay, now can anybody tell me why they are ortho, why they are meta directing? Why these are meta directing? Why these are meta directing? So I'll just show you that. Oof, where should I show you that? Okay, so I'll just make it here only. I don't want to increase the slides here, right? See, if you have N, this is double bond O, this is like nitro. Okay, or I'll just show you this one. Okay, CH3 positive, let's show you that. CH2 positive. So what will happen? This bond will shift here. It will be like this. Okay, it will be like this. 1, 1, and this is 1. This will be double bond. This is CH2, and here, because you have taken it out, this will be positive over here. There will be no negative charge. On the ortho para position, it is positive. So tell me, electron density will be more on what? Then same, this electron will shift here. Positive will be on para. Positive will be on para. Then this electron will shift here. Then again, positive will be on ortho. So can you see this? Always positive charge is on ortho. Always positive charges on ortho and para. That means meta is having more electron density. Electron density is more on meta position. That is why towards electrophilic substitution reaction, they are meta directing, right? Okay, they are meta directing. That's why we have written here ortho para, and here we have written meta. But there is an exception in it. What is that exception? The exception is that in case of halogens, what you have, usually mesomeric effect is more dominating as compared to inductive effect. But in case of halogens, mesomeric effect is less dominating and inductive effect is more dominating. Halogen, because they have, because they are electronegative, they shows minus I and they shows plus M because of the lone pairs. But here their inductive effect is more dominating, and that is the reason what they will have their plus M effect. Their inductive effect is so dominating that overall they are going to be deactivating groups. But because of this plus M, they are going to be ortho para directing. Otherwise, the plus M groups, right, they are ortho para directing and activating. But halogen is that group which is deactivating and ortho para directing. Is that clear? Right? Done, everybody? Tell me if that is clear. So that is the reason if you say rate of reaction will be less. That means if you compare phenol and chlorobenzene or halobenzene, which will have more rate of reaction? Benzene. Which will have more rate of reaction? See, this is activating, that is towards electrophilic substitution. Some electrophile, something which is electron loving is attacking. So this will be more, see, both of them will have ortho para directing only as the answer. What is happening? Some weird noises. Can you also hear? I think someone is, oh God. Actually, our neighbors, na, they are, they are renovation and all is going on. So now they are using some machine and all. So that is actually some drilling or something is happening there, right? So phenol and this is halobenzene. Phenol will have more rate of reaction. Okay. Now this is JEE 2023 question, that is, which will undergo deprotonation more readily in the basic medium. Base always have a work of taking H positive, abstracting H positive. That is the work of base. So this is the H positive. Here you can take out H positive and you can have negative here. You can take out H positive here and you can have negative here. You can take out H positive here and you can have negative here, right? Okay. If this is negative here, the two conjugations can happen, right? If this is negative here, but this lone pair, what will happen? The conjugation is also happening here. Okay, conjugation is also happening here. Then this pi bond is not available to have conjugation with this negative, right? Here, what you can see, this is pi bond and this is negative. Here they can easily conjugate, but here this pi bond is not available for the conjugation as such. So here you can see you have the maximum conjugation because both the double bonds are available here. That is why A is more readily, right, able to give react in basic medium, right? Okay. Then you have resonance. Let's talk about that, guys. Tell me if that is clear, right? Okay. Done. Chalo. Everybody, hyperconjugation. So in hyperconjugation, what exactly happens? In this case, you have resonance only, but in this case, you have resonance of sigma bonds, right? So what exactly happen? I'll make a structure for you here. For example, you have this carbocation here and alpha carbon. Two conditions that you have here is alpha carbon should be sp3 hybridized. That is the first condition. The second condition is alpha carbon is sp and it should have at least one hydrogen here. So what will happen now? How this works? Firstly, let's understand how this works, right? So what exactly happens here? This is the hydrogen, this is this bond will shift here, and here you will have the formation of, this is C, this is whatever bond is there, this is double bond, this is C, and here you will have H positive. And that is why it is also called as no bond resonance. Okay, this is also called as no bond resonance. Resonance is happening, but here when this is not ion, this H positive is not an ion. Okay, it's just that here sigma electrons will break and you will make a bond here and this will happen. Let's say you have this also H, this also H. Then three hyperconjugating structures you can form, right? So more is the number of alpha hydrogens, more is the hyperconjugating structures, and more is the hyperconjugating structures, more will be the stability here. And that is the reason we tell that we just want to calculate the alpha hydrogens. This is just for understanding purpose I taught you, right? And one more thing, remember here that in this case what you have, this is the hyperconjugation is happening between this orbital is this orbital is what? This orbital is actually this orbital and this orbital it is happening. This is empty p orbital of carbocation, and this is sp3 and this is S1s, right? This orbital has 2 electrons here, and these 2 electrons are 1s and overlap of 1s and sp3 hybridized, right? So that is the thing here, right? In this also happens in case of free radicals. Similarly here you have free radicals right? Free radicals you have here, this is alpha, this is hydrogen whatsoever. This will shift here and there will be homolytic cleavage, and that is the reason here you will have only one electron shifting will be there, and here you will have the formation of C double bond C, and this is H free radical, and this it will be the hyperconjugation, right? More the number of alpha, I just showed you with one alpha, more the number of alpha, more will be the hyperconjugating. Then alkene also shows the same. In alkene, this is alpha. Let's say here you have one hydrogen, here what will happen? In this case, what exactly happens? In this case, this will shift here and this will shift here, right? Okay, this is pi electrons now, this will shift here and this will shift here, and that's how in alkene, right, the hyperconjugation is happening. Again, this is alpha carbon, more the number of alpha hydrogen, more is the hyperconjugating structures, right? This is all you have to remember in hyperconjugating structure. And remember that carbon ion does not show, carbon ion, this statement also they can ask you, carbon ion does not show any hyperconjugating, they don't show hyperconjugating structures, hyperconjugation, but there is one compound of carbon ion, if you have, it is connected directly to Cl instead of hydrogen, right? This is the carbon ion, right? Okay, yes, this bond will break. Wait a minute. If this is C, this is carbon ion, this is connected to C, Cl. Instead of hydrogen, there is Cl. So now what will happen? This bond will shift here and this Cl will leave from this side. So it will show minus H only. When instead of hydrogen, you have some very electronegative element, only then it shows minus H. Otherwise, carbon ion does not show any hyperconjugation. Is that clear? Carbon ion will not show any hyperconjugation otherwise, right? Okay, done. Now let's talk about this thing here. This is a question on JEE 2021. They have asked you a statement based question here. See, in this case, though, what you have here, wait a minute. Wait a minute, here I have showed you opposite. Wait a minute, my bad. This will not be this thing, okay? This will, then it will become minus now. It will shift here and this will shift here, okay? Yes, okay? It will shift here and this will shift here. That will be the hyperconjugation here. So why I want to show you this? Because I just want to show you that where this will happen. From sp3, this is sp3 and 1s hybridization to MTP, right? Here what is happening? Same sp3, 1s hybridization to half filled P, because this is going to half filled, it is already half filled. Here this is going to anti-bonding pi star. So you can see this electron is moving from which to which? This is going to pi star. sp3, 1s to pi star anti-bonding. This is moving towards pi star anti-bonding. That is a very important question. That here it is moving to half filled, but here it is moving to anti-bonding orbitals. These electrons are moving to anti-bonding orbitals of this carbon. Okay? Right? Now let's see this question here, that latest question of your JEE, that is hyperconjugation is permanent effect, right? So if you talk about hyperconjugation, yes, it's a permanent effect. We saw it on the first slide, right? Then hyperconjugation is ethyl cation involves cation. It has sp2-1s, not at all. It is CsP3 hydrogen 1s 2 MTP orbital, that is correct. So this statement is false here. Statement first is true. Statement 2 is false. So answer is B is the correct answer, because it is not sp2, it is sp3, right? Okay. Done. Now let's talk about aromaticity, right? Okay. Yes. Aromaticity. Let's talk about that. How do you define aromaticity? See, whenever you have carbocation in conjugation, that is also sp2. If you have carbanion in conjugation, that is also sp2. Just remember this thing, okay? Right, they are always sp2. So sometimes students say, ma'am, this is sp3. No, this is sp2 because it is under conjugation. If you have simple carbanion, right, this thing is sp3. But if carbanion is under conjugation, then it is not sp3, then it is sp2. Okay, remember that. Why I am telling you sp2, sp3 here? Because here, to understand aromaticity, three conditions you have. PCC, that is Priyanka Chopra. No, ma'am, that is planar, cyclic and conjugated. Cyclic, it should be there. Conjugation means overall the ring conjugated. There should be no breakage of conjugation in the entire ring, right? Then planar, all the atoms in the ring should be sp2, right? If it is PCC, it is not following PCC, it is automatically non-aromatic, whatsoever is the reason. Maybe it is not planar, maybe it is not conjugated, maybe it is not cyclic, it is non-aromatic, right? But if it is following PCC, it will have 2 electrons, either 4n plus 2 pi electrons or 4n plus pi electrons. If it is 4n plus 2 pi electrons, it is aromatic. In this case, it is anti-aromatic, right? Okay, now let's see some examples here of aromatic and anti-aromatic. Let's see, right? So if you see carbocation sp, all of them are sp2. See, carbocation in conjugation is sp2, double bond also is sp2. So this is sp2, all of them are 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 sp2. All of them are cyclic, all of them are conjugated. Can you see there is no breakage of conjugation here? PCC is followed in all of them, none of them is non-aromatic. So let's calculate the electrons, right? See, 1, 2 pi electrons. It is 1, 2, 3, 4 pi electrons. 1, 2, 3, 4, 5, 6 pi electrons. 1, 2, 3, 4, 5, 6, 7, 8 pi electrons. 1, 2, 3, 4, 5, 6 pi electrons. 1, 2, 3, 4 pi electrons. See, in this case, what exactly we have? 2 pi electrons, 4n plus, this falls under the category of 4n. If you put n is equals to 0, that is 2. So it is aromatic. This is 4n pi, this is 4n pi electrons, anti-aromatic. If you put n is equals to 2, n is equals to 1, that becomes 6. 4n plus 2 pi, so it is aromatic. This is 4n pi, 4 into 2. It is anti-aromatic. This is 1, 2, this is again aromatic, 6 electrons, 4 electrons are again anti-aromatic. And this is a very important and direct question they ask you from anti-aromatic, aromatic, right? Okay, understood, right? Now let's see this one. This is when you have heteroatomic ions in between, right? Heteroatoms in between. Then what you do? This is quite important. Let's talk about that, right? First thing is you have to calculate the pi electrons, right? So just remember the electrons, the lone pairs, write it here, or I would write it here, lone pairs in delocalization involved in, lone pairs involved in delocalization are not included in hybridization. Just remember this thing. If a lone pair is involved in delocalization, it will not be included in hybridization. So here it is involved in delocalization. This. So lone pair in delocalization is the pi electron. It is involved in pi electrons. It will be involved in calculation of pi electrons. So it will be 1, 2, 3, 4, 5, 6 pi electrons here. Okay, this will be in delocalization. So it is 6 pi electrons here. 2 lone pairs you have. One lone pair will be involved in the delocalization. This lone pair will be not involved, so this will be in the hybridization. right? This lone pair will be involved in delocalization, so that is pi electrons. So it is 1, 2, 3, 4, 5, 6. That is why it has 6 pi electrons. Got it? Why it has 6 pi electron? Why this is not involved in hybridization? Here you have these lone pairs, but it is not involved in any delocalization, right? It is not involved in any delocalization, so this will be involved in hybridization. So if you see 1, 2 sigma plus 1 lone pair, it is sp2. 1 lone pair, 2 sigma, it is sp2. 3 sigma, it is sp2. Okay? So here it has 6 pi electrons. 1, 2, 3, 4, 5, 6. These lone pairs are not involved in delocalization. If you see these lone pairs, tell me, will they be involved in delocalization or not? Let me see. Akhilesh, no. Organic chemistry is not there in GOC, right? And sorry, organic chemistry is not there in JEE Mains. I am just doing this for fun. We are doing it. We were just thinking that 20 days are left. What to do? Let's do something, no? So organic chemistry is there in the exam of this CA exam, chartered accountant. If you want to become, then organic chemistry is a must. So JEE aspirant, NEET aspirant, don't study organic chemistry. Don't worry about that. Right? Okay. So now what you have, this is involved or not? Tell me. These lone pairs are involved? No, they are not involved. Right? So not involved. They are not involved. Delocalization, what we studied in resonance, bacha, resonance is delocalization only, na? Delocalization is when the lone pair are not localized, they are moving here and there, right? Okay. So this is involved. This is pi bond, single bond, lone pair, single bond, double bond. That is resonance, no? So it is, this is involved in resonance, right? So this lone pair is definitely involved in resonance. It will be showing resonance here. That is why it is included in the pi electrons, and that is the reason 1, 2, 3, 4, 5, 6, 7, 8 pi electrons you have. Tell me, is that clear to everybody or not? Right? Okay? Yes. So this is aromatic, this is aromatic, this is aromatic, and this one is anti-aromatic. You can see it from the Huckel's rule. How? This was the Huckel rule. Okay, this was the Huckel rule. Right? You can see it from the electrons. Which one is which? Right? Okay. Tell me, if there is any problem over here, do let me know. If that is clear, just spam the chat box with green hearts if that is clear, right? Okay. Yes. Now what you have, now let's talk about, now that we have done, now let's talk about anolines. Anolines are monocyclic, only one cycle is there. Monocyclic, only one cycle. Alternate double bonds. Alternate double bonds. That is anolines. So if you talk about anolines, no, I'll just directly tell you, because based on this also they ask you the questions here. So what is that? Planar anolines, all these are, say, planarity and non-planarity, I'll tell you, all these are planar, 4, 6, except for 8, 10 and 12, all are planar. I'll tell you why they are non-planar. 8 is non-planar, it is a very important thing. Why 8 is non-planar? Because it exists like tub-like structure. That is why it is non-planar. So it exists like this, okay? So it is existing like this. Very important question this is, why 8 aniline is non-planar? Because of its tub-like structure, it is non-planar. Then why 10 aniline? Because of hydrogen and hydrogen repulsions here. They are non-planar, it goes out of plane. 12 aniline is also non-planar because of the same reason, because of the repulsions. They both are non-planar because of repulsions. HH repulsion, there is angle strain, that is why they are non-planar, right? So that is why these three are under the category of non-aromatic, 8, 10 and 12, right? And if you talk about planar, all these are planar. You just have to see the whether they fall into 4n pi or 4n plus 2 pi. Accordingly, you can answer. For example, 6 pi electrons are this. Then you have 14. Wait a minute. 8 is there. 4 will be here. If I put n is equals to 3, 4, 3, 12. 12 plus 2, that is this. So 14 will fall here. If I put 4 here, this will be 16. If I put 4 here, 16 plus 2, that is 18. So these are aromatic, these are non-aromatic. These are anti-aromatic, right? Okay? Yes. Tell me, tell me, tell me. Yes. Tell me. Is that clear? Actually, I'm in 9th standard. That's why I'm asking. Okay. Yes, organic chemistry is a part of chemistry. Okay? So, JEE 2022 question. Okay, so let's see. Assertion is, see, they have asked you 6 aniline, 8 aniline, and this is cis 10 aniline are respectively what? See, I told you 8 aniline is 6 aniline is nothing but it is benzene only, right? 8 aniline, I told you this is non-aromatic. This 10 aniline is also non-aromatic. 12 is also non-aromatic that we just saw. 6 aniline is aromatic because it has 6 pi electrons, that falls under aromatic character, right? Just remember that 8, 10 and 12 are non-aromatic. Others either can be anti or aromatic or anti-aromatic. You can calculate the number of electrons and see whether they are aromatic or anti-aromatic, right? Okay. So aromatic, non-aromatic, non-aromatic. So they are saying it is aromatic, non-aromatic, aromatic. That is incorrect, right? Planarity is one of the requirements of aromatic systems. Yes, that is the requirement. That is true, right? So it is non-aromatic. This is non-aromatic because it is not planar, right? So answer will be E is incorrect and R is correct. So answer is D is the correct answer here, right? Okay. Let's see JEE 2022 question over here, right? Okay. What is there? Which of the following compounds is not aromatic? Not aromatic means it can be not aromatic. They are not saying non-aromatic. They are saying not aromatic. Not aromatic means it can be anti or it can be non. Both are not aromatic. So it is 1, 2, 3, 4, 5, 6 pi electrons. So this is aromatic. This is definitely not aromatic, non-aromatic. This is also aromatic because 2 benzene rings are fused. Aromatic. This is 2 pi electrons. That is also aromatic. So this is not aromatic. Others are aromatic. Right? Okay. Yes. Thank you, Nanda. Thank you. Thank you so much. I hope so you are liking organic chemistry as well because a lot of hard work has been put into this. It took around 2 days to make this PPT, right? So let's talk about electromeric effect now. Let's see electromeric effect now. What is electromeric effect? Let's talk about that. Yes, everybody. Let's see. Electromeric effect, basically, it is a temporary effect. Okay, firstly, to remember that it's a temporary effect. For example, you have a reaction like that, and here you have the reaction of H positive. Let's say you have H positive attack here. H positive attack will be electrons are moving to this side and hydrogen will also be attacking on this side. right? Okay, or I would say attack, you write it like that. See, because this is partially positive, this is partially negative. So electrons will move here only, right? And this electrons, this H will also attack here. So we can say when the movement of electron and the attack of reagent are on the same atom, that is plus C. Okay, if I say that you have this thing, this is C double bond O, and here you have the attack of Cn, right? This is partially negative, this is partially positive, this is partially negative. They are attacking here and the electrons are shifting here. So the attack and the shifting of electron are on two different atoms. So that will be minus E. Okay, that will be called as minus E. Definitely you can do. Nobody can beat you after that. Right? Let's see this question here. JEE 2024 question that says, right? Which of the following is incorrect statement? Electromeric effect dominates over inductive effect. Electromeric effect is temporary effect, and the organic compound shows electron in the presence of reagent only. Halogen ion shows negative electromeric effect. See, hydrogen ion, if you talk about, this shows positive. If you see this here, hydrogen ion was showing positive effect because electrons are shifting on the same atom where hydrogen is getting attached. Okay, the reagent will be like this will be positive, this will be OH. The attack of hydrogen is on the same position where the electrons are shifting. So that is the wrong statement here, and that is why D is the incorrect statement. That is the correct answer here, right? Okay, yes everybody. Now let's see Barhi. What is Barhi? Let's now, these were the questions that they ask you individually, right? Now we will talk about questions which they ask you on the stability of intermediates. Let's talk about that. Okay, yes everybody. Stability of intermediates, how it is done, that is based on Barhi. What is Barhi? Simple is, it is back bonding. Actually we are telling that how it works, right? So it is BARHI, right? It is back bonding, aromaticity, resonance, hyperconjugation, then inductive. This is the order, right? Okay, and I'll just want to show before this, there is also one more thing, that is dancing resonance. Okay, I'll just show this thing over here. Dancing resonance is even more. Whenever you see dancing resonance, just remember D Barhi. D for dancing resonance. And you know what is dancing resonance? Can anybody tell me what is dancing resonance? Dancing resonance. See, here you will have a compound that has a structure. This shows dancing resonance. Here what happens? This bond shifts here, it will become this double bond, this, and this is positive. Or this bond can shift here, this can become this double bond and this positive. So that is resonance only. But what is happening, why this is called dancing? Because it feels like the molecule is dancing, one leg up, one leg down, right? So this compound shows dancing resonance, where this bond will break, you will have a double bond here, you will have positive here. Or this bond will break, you will have a double bond here and positive here, right? That is called as dancing resonance. Okay, right everybody? Tell me, is that clear? Dancing, wherever you see, first you will see dancing resonance. If it is present, then it is most stable intermediate. After that, you will see back bonding, then aromaticity, then resonance, then hyperconjugation, then inductive effect. For example, I will show you some effects here, which, how do you define the stability here? Let's talk about that. Let's talk about that. Let's talk about the stability here. So if I talk about these two, I'll firstly see Barhi, Barhi. So I'll firstly see back bonding. Is there any case where back bonding is possible? Yes. This back bonding is possible. Automatically this becomes more stable. Done, done, done. Now I'll see here. Okay, this is the exception. Okay, this is the exception. This I'll teach you after this. Firstly, let me teach you this. BARHI. Okay, BARHI, this is Barhi. Now, can you see anywhere back bonding? No. Can you see aromaticity? No. Can you see resonance? No. Can you see any hyperconjugation? Here only you can see hyperconjugation. These two cases, there is the how you will compare. Hyperconjugation should be in all the structures, no? So that you compare this. So that is also not possible. Last is inductive. Inductive is defined for minus I or plus I. Electronegativity. We know that this carbon is sp3. This carbon is sp2. This carbon is sp. So always electron negativity order is sp, sp2, sp3. So sp3 has least electron negativity, and that is the reason if I say sp3 has least electron negativity, what it will do? It will not be able to sorry, sp3 has least electronegativity, so it will not be able to pull the electron, making it highly stable. When you withdraw the electrons from carbocation, you make it unstable. When you give the electron, carbocation is money. When you give money, it becomes happy. When you take money, it becomes unhappy. Right? So you are taking money here with maximum strength. Right? Sp maximum electronegative, you are taking money with maximum strength, so that becomes least stable. Hence, this is the order here. Tell me. Done? Okay. Now, this is under the exception. So how you will see this? What should happen if I talk about Barhi? Back bonding is not there. Aromaticity is not there. But resonance, you can see here, it is resonance. Here you have no resonance. So according to you, this should be more stable because, ma'am, here you have resonance, here you don't have resonance. But what happens here? Why this becomes less stable as compared to this? So here you have 3 inductive effect. Here you have only 1 resonance. If you have 1 resonance and 1 inductive, you will choose that. But here you have 3 methyl groups and here you have only 1 phenyl. That is the reason this becomes more stable. Okay. Carbocation is poor. Carbocation needs money. When you give money, carbocation is happy. When you take out money, carbocation is unhappy. Now let's see this. See, in this case, this is a very important thing. Sometimes you can't directly see that what is applied, right? Okay. Let's see that. Okay. So if you have this compound here, in this case, if you see back bonding, directly you can't see aromaticity, you can't see resonance also, है ना? Resonance also, ma'am. This resonance is present everywhere if you see this here. But it is not differentiating. Everywhere this resonance is present. So how will you differentiate it? So you can't answer it according to resonance. Hyperconjugation, ma'am, how hyperconjugation is not presence? No, hyperconjugation is present. How? How hyperconjugation is present? Let me teach you that. So what exactly happens? We know that whenever you have positive here because of minus M effect, positive will be here and here as well. Ortho and para position, you will have positive. So if you have a group at ortho or para position, what you will say? If you have a group at ortho and para position, that means hyperconjugation. I can see here, this is carbocation and this is CH3. This is 3 alpha hydrogen. This has how many alpha? 1 and 2 alpha, right? This has only 1 alpha hydrogen. This has no alpha hydrogen. Understood now why it is like that? It was not directly visible to us that hyperconjugation is present, but it is hidden somewhere. Let's not take care of these things, right? Okay. So hence the reason is maximum hyperconjugating structure. That is why A, B, C, D is the correct answer here, right? Same question, students, they can ask you, right? With the back bonding, I'll just make one more compound for you. Same situation, same thing. Let's see here, right? Let's see here. Okay, I'll just give you two compounds here, right? Two compounds here. See, this is NH2 and this is PH2, right? Okay, tell me which one is more stable. Can you tell me which one is more stable? Which one is more stable? Guys, see, one thing, if I say back bonding, is it present or not? Tell me back bonding is present or not. Let me see how many of you are able to identify that. Back bonding is present or not? See, if I don't know that here hyperconjugation will apply, if I don't know whether resonance structure, if I don't put positive and positive here, then I'll say no, back bonding is not present. But here I can see positive will shift here as well because of resonance. And that is why here in this case, back bonding you will see over here. Why? Acha, wait a minute. If I see, wait a minute, back bonding, no. Here it is vacant, this also is vacant. So if I talk about this thing here, back bonding is present. Okay, back bonding is present, it has lone pair of electrons, right? It has lone pair of electrons, right? And that is the reason back bonding is present here, right? Vacant d orbital, and they can also give you one more thing. In this case, so if you have to see which one will donate the electron with more efficiency, the one which is less electronegative. This is a less electronegative, so it will give lone pair with more efficiency. So answer will be this one. Okay. What if you have here negative? Let's say you have negative there. Let's say you have a compound. Let's say you have a compound. I'll just draw that. Let's say you have a compound. Okay. You have this kind of compound. Okay. Where you have CH2 negative. Okay. Here also you have CH2 negative. Now what will happen? Let's say here they have made, now tell me, back bonding is present where? Because this is negative, what will happen? Ortho para, you will have negative here as well. Ortho para, there will be negative, and that is the reason here this is electron rich, but this is not electron deficient. This is electron deficient. Okay, and that is the reason this will be more stable. Okay, so answer, you have answered it according to back bonding, right? Done. Tell me everybody. So these are some different questions that you must know. Now let's see what kind of question they have asked you in JEE 2024. Let's see this question. Okay, yes everybody. Yes. Now if you see this here, which of the following carbocations from the following is most stable? 2025 question it is. Most stable. Okay, this is positive, this is positive, this is positive. Just apply Barhi here. Okay, so BARHI. Back bonding, first I'll have to see. Okay, back bonding directly, so I can't see present anywhere. But if I see, this is lone pair, single bond, double bond is not here. Okay. This is lone pair, single bond, double bond. If it shifts here, this will be positive. Okay, right? There is resonance. Here you see resonance here. Okay. In this case, you can see resonance here, right? Here you can see resonance, double bond, single bond, lone pair. And you can see resonance here, right? Lone pair here as well. What about this one? In this case, better resonance, I think so. Because here you have, if I say this is lone pair, single bond, double bond. If it shifts here, right, that is first thing that can happen, then it will be positive, positive, that thing can happen. So if I see this here, this is also the same situation, but here these lone pairs are also under resonance with this one. So these lone pairs are not available with resonance with this one. Okay? So the most stable yes will be this one. C is the correct answer here. Because here lone pairs are also under the resonance with this one. They are not completely available for this thing. Right? Here though you can't see any resonance like that. So here this resonance is also there, double bond, single bond, lone pair. But fluorine is like very much electronegative, so it will not be able to give the electron. So that is also ruled out. These two are quite similar, but it's just that this lone pair is also involved in resonance with this one. So it will be cross conjugation, right? It will be cross, like you have lone pair here, it will be available there, it will go here as well. This is extended only, lone pair, single bond, double bond, single bond, free radical, right? Okay, tell me everyone, is that clear? Next is the correct order of reactivity of electrophilic substitution reaction of following compounds. Electrophilic substitution reaction of following compounds. Is not very good. Very good, lucky, very good. Cross conjugation is not making it stable. Correct order of reactivity of electrophilic substitution. If you see this here, electrophilic substitution, now. So if you see, this will have minus M effect. This will have minus I effect. This will have plus M and minus I effect. This will have plus I effect, right? Okay, and this is nothing. So last will be D. Okay, D will have correct order of reactivity towards reactive, whether it's ortho or whatsoever, it should be reactive. So because of this minus I, it is making it deactivating. So maximum will be B, then there will be A, then there will be C, then there will be D. B, A, C, D. Okay? Understood now how we got this answer? How we got this answer? Because we know that what exactly is happening here, this is minus I is dominating here. So it is also deactivating. This is also deactivating. This is activating. This is no effect. So maximum is B, then A, which has no effect, then C, then D. Right? Okay? Here this one is more deactivating because here minus M effect is also applied. Here only minus I effect is applied. So answer will be B. Next is you have question on stability of carbon ion. They are asking which one is more stable. JEE 2024 question, that is again based on aromaticity. So let's see if you can answer this or not. This aromatic and non-aromatic, that means you have to tell, right? If you see B and C are non-aromatic, right? Let's talk about A and D. This is 1, 2, 3, 4 pi electron. This is anti-aromatic. This is 1, 2, 3, 4, 5, 6, 6 pi electrons. That is aromatic. So D will be maximum stable. So these two are already ruled out. After D, you will have an anti-aromatic is the most unstable thing. Always remember, you have aromatic, then you have non-aromatic, and then you have anti-aromatic. No compound wants to be anti-aromatic. It is that unstable. Okay, so A will be least stable, that is here, so answer will be D is the correct answer here, right? Okay, D, then you have C, then you have B, then you have A. Ma'am, why C is more stable than B? Because here it is 5-membered ring is more stable than 4-membered ring. Okay, yes, everybody, tell me. Yes, yes, tell me, everybody. D answer, ma'am. Mechanism part, ma'am. Don't worry, Lucky, I'll make you pro. Don't worry. Right? We'll do that. The part that you're scared of is actually very easy. Right? The increasing order of stability of following free radical is what? Free radicals. Free radicals are like carbocations. They are like money. When you give them money, they become happy. When you take out money, they become sad. So you have to give electron donation there. So if you see, when you have C6H5 to the benzene ring, when they are connected, they will show resonance. So resonance is making them stable. More is the resonance, more is the stability. Here you have 3 resonances. Here you have 2 resonances. Here you have, wait a minute. After this, okay, right. You have 3 inductive, then you have 2 inductive. So answer will be B is the correct answer here, right? Okay. 4-membered ring is more stable, very good. We'll actually see the stability of ring as well in rearrangement, right? Okay, let's see. Let's see. Now what you have, now let's talk about acidic strength. Okay, now let's talk about acidic strength. Yes. Hello Ayush, hello Ayush. So acidic strength, let's talk about that. If you see acidic strength, right, we'll see carbon ion stability. See, a good acid will be good when after losing H positive, it is stable. So if this is stable, this is a good acid, right? So you'll have to see the carbon ion stability. This is the order of acidic strength: mineral, then sulfonic, then picric, squaric, then dinitrophenol, carboxylic, carbonic, mononitrophenol, phenol. Right? All these are the orders that you can remember. Right? This is a remembering thing, right? But I'll show you what exactly it is, right? So you'll have to see the stability of carbon ion, that's it. Carbon ion means carbon ion stability. More is the electron withdrawing, more is the stability, more is electron donating group, less is the stability. Okay? So now let's see the ortho effect in acidity. What is the ortho effect? Let's see that. Ortho effect is whenever group at ortho position increases the acidic strength of the benzoic acid. Group means group should not be like this. Very small group we are not talking about. We are talking about big groups like you have NO2, alkyl, CHOX, all these are the big groups, right? So conditions are, firstly, it is only applied to benzoic acid. Secondly, it is applied to the bulky groups, right? Okay. So for example, I ask you, this is benzoic acid. Let me see if let's see if it is there. Okay. This is COH, right? This is COH, right? So let's say here you have any group. Let's say it is OH, and any group you have an ortho position. Here OH is on the para position. So because OH is on the ortho position, it will automatically make it more acidic. So whenever you have any ortho substituted benzoic acid, it is automatically more stable as compared to other things, right? Okay, that you must know. Now let's see JEE 2025 question on the acidic strength. Shall we see that, everybody? Silent, I am seeing you. I have been seeing your chats from the last 30 minutes, right? I don't know why you're doing this, right? But let me be clear to all the students, because I don't care about you. Definitely, I can see it through your chats, and I don't care about students like you, right? But definitely, those students who will feel panic. Oh my God, ma'am is not teaching questions. I'll be taking your one big marathon on simply questions. All PYQs I'll do, right? Okay. Firstly, right now I'm focusing on theory so that I don't want you to cram the questions. You have to solve the question. It's not physics, it's not maths, it's chemistry. More theory you know, better you will be in solving the questions, right? Okay. Yes. You should be ashamed of yourself. And my throat is literally paining, and that, even then I'm not stopping. You should be literally ashamed of yourself. If you don't want to study, nobody is asking you to study from here, right? Go and study from somewhere else. If you don't want to see theory, you're not on gunpoint that you have to watch theory. Go and see questions, practice questions. Go and do that. Why are you doing this? Huh? The compounds that produce CO2 with aqueous, this means they're asking you the compounds that are acidic in nature, because an acid only with that NaHCO3 it will produce this. So we need to know which are acids, which are good acids. Let's talk about that, right? So if you talk about, this is COCH3, this is OH. Here you have OH, and you have minus I group here, minus withdrawing group here. This is benzoic acid, right? So they have to be really strong acids. Firstly, A is definitely a very strong acid. Then you talk about B, with because of these minus with electron withdrawing groups. So what will happen? You will have this phenoxide ion. Okay. Then you have NO2 group here. So these electron withdrawing groups are going to fetch the electrons, and they will make it even more stable carbon ion, right? So B will also be there, right? Then I talk about if you want to withdraw the electrons, right? Okay. A, B. If I talk about I want to withdraw the electrons, acha, this is C, na? A and C. E and C is there. If I talk about B, E will not be there. Then you talk about D, right? So you can say A, C, and B. Can I see that answer here? A, C, and B is not there. So I think E and C to will definitely be there, right? So answer yes, A, C, D. This is because of this COH group, na? This is because of the COH group that we have taken this D here, right? So this though will not be there, because here it is providing the electrons here. Something is already having this O negative, and you're giving the electrons. You're making it very unstable. So carbon ion is stable. How will it do that? So this is definitely not there. Phenol is acidic, but it is not so acidic to release OH. So this will also not be there. This is COH group, that is carboxylic acid group, that will be there, right? Okay. Then you have this value here. Let's see this, right? Okay. Because all the acids, they react with the NH. This you have seen in lower classes. Acids, if you give them any NaHCO3 or Na2CO3, they will produce CO2 and water, and they will make a salt, right? Okay. Salt plus water and carboxylic acid, right? Okay. Match list 1 with list 2, list 1 and list 2, right? So what you have? Ethanol, phenol, metanitro and para nitrophenol. Remember that pKa is inversely proportional to Ka, acidity. Now, if you see, this is ethanol, that is C2H5OH. This is phenol. Okay. This is meta-nitro. Now, this is very important for you to understand. Let's talk about phenol. Very important thing we are going to do here. This is meta-nitrophenol, right? And this is para-nitrophenol, right? This is para-nitrophenol. So if you see this over here, right? If you see this over here, meta-nitrophenol, para-nitrophenol, right? So definitely phenol is more stable, more acidic than ethanol, right? But you will see one thing here. At meta, remember this thing, at meta position, mesomeric effect is not applied. Mesomeric effect is not applied. Please remember this thing, okay? Mesomeric effect is not applied at meta position, okay? At meta position, you will not apply mesomeric effect. So if you see this here, meta position, you will only have minus I effect. Here you will have minus I and minus M both, right? Here there is no effect. So you have carbon ion, right? Carbon ion means it will lose and it will give you negative, positive, negative, positive, negative, positive. You want to see the stability of this carbon ion here. So in carbon ion, more is the withdrawing, more is the stability. So para will be most stable here, right? So acidity will be D is maximum acidity because it is maximum stable. Then this will also be stable because at least minus I effect is there. Then it is C. Then there will be B because there is no effect. It's okay. But because of resonance, it is more stable. Then you talk about ethanol. There is no resonance. Then there will be A. So this is the order of acidity. pK will have the opposite order. That is A, B, C, D. A, B, C, D. Where, then it will be A maximum, then B, then C, then D. Wow, right? So A will have maximum value, that is 15.9, that is 2. A is 2. Then B will have less value than that, that is B will have 1 value, okay, less than that. Then C will have even less value than that. A is 2, this is 1, this will be 4, and then there will be 3. Yes, so D is the correct answer. Okay, right, everybody? You can watch this, but please watch it from the starting, right? Because it is only beneficial to watch it from the starting, right? Okay, if you watch in between, then this part though you will not be able to understand, because this is, I have worked hard on students for like 2 hours, then we are getting on to this point, right? Okay, now basic strength, let's talk about basic strength. Just remember, basic strength is directly proportional to availability of electrons. It is directly proportional to electron donating group, inversely to electron withdrawing group, right? Okay, yes. Will have more acidity than para? No, 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 no. If you talk about ortho effect is not applied on phenol, right? Okay, then you will HMCK. It's a very nice question. Let's say you have ortho as well. Let's say you talk about ortho and para. Firstly, here ortho effect is not applied because this is not benzoic acid. Okay. Now see one thing. Distance orientation you have to see. Here you have minus M and minus I both. Here also you have minus M and minus I. But in this case, distance orientation is there. That means distance orientation means In this case, it is distance oriented, so that's why more effect will be there. So more effect means it will make it more stable, so that is why ortho will be more acidic, not because of the this wait a minute. No, here it is opposite. You were right. Here it is opposite. Why? Because here it is hydrogen bonding as well. Na? Oops. Here you have hydrogen bonding as well. Because of this hydrogen bonding, right? This is nitrogen. You need hydrogen here for the hydrogen bonding. So it will not be able to lose the electron. So para will be more. Right? Okay? Yes, definitely right. Because of hydrogen bonding, it is opposite. But in other case, for example, there is something else where there is no hydrogen bonding, then you will operate it by the distance. Right? Okay? Tell me. So basicity is this, which are, if you see, basicity is directly dependent upon the availability of electron. That means directly proportional to electron donating and inversely to electron withdrawing. Now, if I talk about this thing over here, that ma'am, what is ortho effect in basicity? So ortho effect says that if you have 2 degree or 3 degree amine, then it increases basicity. If you have ortho substituent on 1 degree, then it will decrease the basicity. Okay. So if this is 3 degrees, so that's why basicity will increase here, right? Here you have 2 degrees, so it will again increase here. But for example, you have aniline, you have ortho group here, then basicity will decrease here. Okay, simple thing, right? Everybody, tell me. Now let's see this JEE 2020 question, right? Let's talk about this, right? Everybody, it can definitely form hydrogen bonding. Whenever hydrogen, you have fluorine, nitrogen and oxygen, it will definitely form, right? So increasing order of basicity for the following intermediates, let's talk about that. Basicity, acidity, basicity questions are very, very important, right? So if you see this here, it is donating. Basicity, anion you are talking about. Anion is like stress. Okay. When you give stress, you become unstable. When someone takes out stress from you, you become stable. Okay. So here you are giving stress. So it is unstable. Here you are taking out the stress here by resonance. Here if you see, this is on C, you have this negative. This is on CH3, you have this negative. So most unstable will be this, most stable will be this. It is connected to SP. That is also very good in taking out the withdrawing the electron, right? Okay. And yes, so minimum stability will be of 1. That will be minimum least basic, right? Because we have to see, they're asking you increase. Achha, wait a minute, they're asking you increasing order of basicity, not carbon ion stability. I am doing carbon ion stability. Wait a minute. Increasing order of basicity of the following intermediate. Basicity, to more the electron, more the electron donation, more the electron availability, more will be the stability. So here the availability of electron is very high because 3 donation you have. Here the availability will be low, right? So this is most basic. So you can say first is most basic, right? Okay. So that is how you have your answer D as the correct answer. Like in one word you have your answer. Okay. But still I'll tell you all of that. So answer to you will get from only one thing, that more is the electron availability, more will be the basicity. So only here I can see the donation of electrons. Anyone in other compounds, I can't see the availability of electrons. Here I can definitely see the electrons are being delocalized, right? So it will also be lower on side. Here also you are taking this because of this SP. Here also you have nitrogen attached to it, so that is why nitrogen is highly electronegative. But in fourth, if you can see, In this case, you have hydrogens that are attached here. So after this, you have 4. Why? Because fourth does not have any compound that is taking away the electron. Here it is giving the electron, but here no one is taking away the electron. So it is like no one is giving also, no one is also taking. So it is also happy. That's why this is. Then after that, you have delocalization here, and here you have sp, and here you have nitrogen. So nitrogen will take out the electron with maximum efficiency, hence it is the least basic. And out of this this third and this is because sp is attached next to it, that is why it will take out the electron. That is why it is if you can see third here. And then there is fourth, which is more basic as compared to this, because here resonance is happening, right? Okay, done. Answer though was there, like when you knew just one thing, right? So answer was not difficult, right? Then you have JEE Mains 2024 question, the correct order of basicity, basic strength of pyrrole, pyridine, and this. Availability of lone pair. Here the lone pair is available, here the lone pair is available, here it is delocalized, so it is least basic. Okay? Pyrrole is least basic here. So these two are to cancelled here. What about this one? In this case, here you have plus psi donation as well. Okay? Plus psi donation of these this R group here. So availability of electron is more in p pyridine, right? In pyridine, there is no plus psi effect, nothing is happening. The lone pair are on the same position. Other pi bonds are getting delocalized. So that's why p pyridine, then you have pyrrole. So answer is first is the correct answer here, right, everybody? Then you have next is JEE Mains 2020 question. Let's talk about that, right? Here again pKb they are asking you. Remember that Kb and basicity is inversely proportional to pKb. You have to define it. Now if I see availability of lone pair, 2 lone pairs are there, 1, 2, 3 are there, only 1 is there. Here though you are giving the electrons by plus psi, that's good. Here you have but only 1 lone pair where you are giving the electrons, right? Here you have 1 lone pair where you are giving if this is lone pair single bond double bond, lone pair single bond double bond, so they both will be involved in delocalization here, right? But still this lone pair is intact here where you are getting that means still overall lone pair will be more as compared to this, right? Okay. What about this one? What about this one? This is NH2, this is also NH2. Here if you see lone pair single bond double bond, this will be involved in delocalization, but here the lone pair will stay intact, right? So if I see, wait a minute, yes, C, B will be maximum, then A, yes. Okay, so if I see overall here you have 3 nitrogens, where 1 nitrogen has full lone pair and this have like conjugated lone pair available. This has full lone pair available, this has full lone pair available, but here conjugated lone pair is available. So here you have 3N, this has 2 nitrogen, this has only 1 nitrogen, so answer will be basicity will be B, A, C, and pKb will have opposite order. Okay, so what you have to see, if here you had only 1 nitrogen and then it was delocalized, then the answer would be this. But here you have 3 nitrogens. So it's not like resonance will take away all the nitrogen. This is fully available, this is half available. This is fully available, this is available still. Even after resonance, some amount of it will be available. Right? Okay? Understood? Tell me. So that was about your GOC. Right? Okay? Tell me. Those who are saying I'm losing confidence in mock, firstly see the theory, right? Watch the lessons. I have done inorganic as well. Organic I am doing today. then I'll be doing previous year questions as well. Go through that. Okay? After that, if you still feel like that, we will take mock test as well. Right? You just have to stay consistent on the channel. Right? Okay? Yes. 10-minute break now I'll give you. After that, we'll start with the isomerism, which is a very, after that our isomerism is done, you have no idea how much big amount of thing we would have done. After that, only reaction, preparation, and all those things will be left with. Right? Okay? Tell me. Done? Yes, this is enough. Such me, this is enough. You can trust me. Right? So I'll give you now, I'll see you all at, this is 6 now, I'll see you at 6:05. 6:05, I'm no 10-minute break, only 5-minute break. Okay? 6:05 p.m. the class will be resumed. Right? Still break, little 5-minute break. Okay? Just 5 minutes. 2 minutes here, so 6 minutes, 7 minutes, 5, 6, 7, 7-minute break it is. Okay? So I'll see you all. Yes. Chal. Okay, then I'll see you all. Solvi, then do your promise, then be here till the end. Right? Okay? Yes. Now we are going to boost more of your confidence. I'll see you all after 5 minutes break. Right? Okay? Yes. Okay, so everyone, do let me know if I am clearly visible and audible. Yes. Do let me know, everyone, if I am clearly visible and audible. And one more thing, everyone out there. Now, I don't know, maybe some of you have joined now because some of you were saying, ma'am, we will join after the class, after our schools. So, guys, now we will be starting isomerism, right? And I think isomerism we can complete it in 1 hour. Okay. I think by 7 or 7:15 we'll be able to complete isomerism. Okay. Right. So let's start with isomerism. My throat is paining a little bit, so I'll be talking little bit slow. But tell me, that is fine. This much pace is fine. 'Cause, in winters my throat usually, it is paining a lot when I speak a lot. Tell me, because if I now start chillana, if I shout and if I don't know why I'm not able to control that, but if I speak very loudly, then I know my throat will pain so much that I won't be able to take physical chemistry marathon, right? Or today only I'll have to end the in between, right? So that's why I'm eating tablet in between, right? Okay, yes. So now we will start with isomerism. In isomerism, two types you have. One is structural, other is stereo. Structural is also called as constitutional isomerism. Structural is also called as constitutional isomerism, right? So now let's talk about this. Firstly, we'll talk about structural isomerism. So in structural isomerism, you have chain, position, functional, ring chain, metamer, and tautomerism. Each one we will see. If you talk about chain isomerism means, see, isomerism simply means that when you have same molecular formula, but arrangement of atoms is different. So chain means when the parent chain is different. For example, you have these two here, 1, 2, 3, 4, 5. This is the parent chain, and here 1, 2, 3, 4, 5, 6. This is the parent chain. The number of carbon atoms in the parent chain is different, but overall molecular formula is same. That is chain isomerism. Okay. Then in position isomer, what you have, the position of the functional group is different. Like here, it is at ortho position. Here it is at meta position, right? So they are position isomer. Here it is at 1, 2, 3, 4, fifth position, third position. Here it is at 1, 2, 3, 4, 5. It is at second position. So the position of the functional group is different. Function group or the substituents, the position is different, right? Then there is metamerism. Wait a minute. Before metamer, I'll do functional isomer. That is important. Okay. Functional isomer is when the functional group is itself different. For example, you have alcohol and ether. They are functional isomer of each other. You have cyanide and isocyanide. They are also functional isomer. Ketone and aldehyde can also be functional isomer. Then you have carboxylic acid and ester. They also will be the functional isomer of each other. Molecular formula remains the same, right? But the way you write molecular formula remains the same, but the functional group changes here entirely. Ring chain isomer is when you have a ring and you have a chain, and what you observe here, that ring and chain, right, they both have the same formula. Actually, ring and chain both have this formula, CnH2n. This is the formula of alkene as well, and then ring as well. This is the formula of ring and alkene, both, right? So they have the same formula, but there one is existing as ring, other is existing in double bond. That is ring chain isomer, right? Then there is metamerism, from which they ask you the questions. That is with the bridge functional groups, like which has, let's say here, this is a bridge, these are two alkyls, this is a bridge, these are two alkyls, this is the bridge, these are two alkyls, this is the bridge, these are the two alkyls. So when you have a bridge and two alkyls here, what will happen? The alkyl will interchange their positions. Let's say how, right? Let's talk about this. I'll give you one example here. Let's see CH3, this is O, this is CH2, CH3, this thing, right? Either you have, now this cannot show any metamerism. If you see, this will not be able to show metamerism, right? Because if you put 3 here, then it will be one. If you put 3 here, then here will not be any alkyl. So this will never show any metamerism, right? If you see this thing here, this will also never show any metamerism, right? Metamerism is not possible only here. But if you see this thing here, let's say CH2, CH3, right? This is CH2, CH3. So its metamer will be, you have CH3O, CH2, CH2, CH3. Or its metamer can be OCH3, this is CCH3, CH3. So now as you can see, the alkyl chains are changing here in all these 3 cases. So that is why they are showing metamers here, right? Okay, when the alkyl chains are different here, right? Okay, yes Mohan, I'll do that, but please let's firstly focus here, right? Okay, done. Now let's see tautomerism. In case of tautomerism, what you have, right? This is very, very important, because this you will use now in other parts as well. Direct question they can also ask you from here. Tautomerism has 2 conditions. First is alpha carbon should be sp3. Ma'am, what is alpha carbon? You have carbonyl. This carbon is called as alpha carbon, right? It should be sp3. It should have at least 1 hydrogen. That will show tautomerism, right? Now, if I see this here, tautomerism, first thing is it should have alpha carbon should be sp3, at least 1 hydrogen. Then H positive transfer is there. What happens here? This is alpha carbon. What happens? This H positive will transfer, this bond will shift here, right? And this bond will shift here, this H positive will transfer here. So something like this you will have. This is CH3, this is C, this is OH, this is H, this is double bond, and this is CH2, right? This is the situation that you will have. H positive transfer, H positive will transfer, this bond will shift, this bond will shift. Here you will have, this is keto and this is enol, right? But you know what is the best way of doing this? Best way is put 1, 2 and 3 here. Just replace the double bond, shift the double bond from here to here. Here you have a single bond and here shift the hydrogen here. That will be enol, right? Simply you can do it this way as well. What I am writing here, right? Shift double bond, shift double bond, shift double bond. From which position? Shift double bond from 1 to 2, 2, 3. Then hydrogen shifting is from 3 to 1. That's all. This is the keto form and this is the enol form. That is the enol form, right? Okay, tell me. Right? Yes, everybody. After this, what you have? Keto enol tautomerism. See, 2 kind of systems are there. One is 1,3 system, other is 1,5 system. Now, what I want to show you here, that 1,3 system is when the shifting of hydrogen is from 1 to 3 position, right? 1,5 system will be applicable when, let's talk about that firstly. See, if you talk about the 3rd carbon, chances are either it will be sp3 or it will not be sp3. Let's say the third carbon is sp3. Then in that case, you will see that whether it has alpha hydrogen or not. If it has alpha hydrogen, it will follow 1,3 system. If it doesn't have hydrogen, it will not follow any tautomerism. It is not possible only, right? But if the third carbon is sp2, in that case, what will happen? If the third carbon is sp2, then you will check the fifth carbon only when the third carbon is sp2, right? Then you will check the fifth carbon. If it is sp3, then if it is sp3 and it has alpha hydrogen, then only this is possible. I'll show you one of the structures here. It's not this. So tell me, will this show any 1,5 system or not? See, this is 1, 2, third carbon is sp3, and it does not have any alpha hydrogen, so this will also not show any 1,5 system as well, right? I'll show you which will show 1,5 system. Let me just show you which will show 1,5 system. See, if you see this here, right, this is what you have. This will be hydrogens that you will have. So what will happen? 1, 2, 3. See, third carbon is sp2. This is fourth, fifth carbon is sp3 with the alpha hydrogen. This will show 1,5 system. So this hydride will shift. This bond will shift here. Wait a minute. This hydride will shift. This bond will shift here. This bond will shift here. This bond will shift here. And by this system, you have the formation of what you will have? Double bond. This will shift here. This will shift here. This will be OH. Hydride has shifted from fifth position to first position. That is 1,5 system. Okay? Yes, everybody, tell me. Is that clear? Then if you talk about, if they ask you which of the following shows tautomerism or not, what you have to see? This is alpha and this is alpha. Alpha is sp2. This is 1, 2, 3. Or even fifth is also sp2. 1, 2, 3, 4. Fifth is also sp2. So this will never show any tautomerism. Here 1, 2, third is sp2. This is fourth and fifth. It is also sp2. This is fourth and fifth. This is also sp2. 1, 2, 3. 3 is sp2. Fourth and fifth is sp3 with the alpha hydrogen. So this from this particular position, this position will show tautomerism, right? Okay. Yes, everybody. Done, dana, dun, dun, dana, dun, dun, dana, dun, dun. Right? Now let's move to stereoisomers, right? Okay. Now let's move to stereoisomers. And don't forget to like the session if you have not done that. Share this session on your Instagram, tag me over there, share this on your WhatsApp, right? Okay. Yes. So after isomerism, I'll give you the break, right? Okay. Now if you see stereoisomerism is of two types. One is configurational isomerism, then there is conformational isomerism. Let's talk about what is configuration and what is conformational isomerism. Configuration isomerism will have geometrical isomerism and optical isomerism. Firstly, we'll talk about configurational isomerism, that is GI and optical isomerism, right? So geometrical isomerism, guys, it will have cis and trans, but you know what kind of question they ask you? Firstly, which of the following is GI, which of the following is not GI? For that, a very simple concept is this is 1, this is 2, this is 3, or you can say this is also 1, this is 2. Always remember 1 should not be equals to 2. If 1 is not equals to 2, it will show GI. If 1 is equals to 2, it will not show any GI, right? That is the first thing that you must remember while doing these questions here, right? So 1 should not be equals to 2. That is a major important thing here. 1 should not. On the same carbon, 2 groups attached should not be same. Very important. Let's see how do we do that. And alkanes will not show that, because here you need restricted rotation, right? restricted rotation. In alkanes, you don't have restricted rotation. You have free rotation. In alkenes, you have restricted rotation, because when you have two bonds here now, when you have two bonds, the rotation gets restricted. When you have one bond, the rotation is easy, right? Okay, so that is the reason. That is the reason. Lecture will go on till I complete organic. I think I'll have to sleep here today. So let's see. So here you have, see, this is a carbon double bond, this is methyl, this is hydrogen. They are different. In this case, how you will see when you have a ring attached, okay? How you will see. See, here it is simple. They have given you, let's say, no ring is given, they have simply given you CH3, or here they have given you Cl. Then you can say they are also different, it will show GI. What if they have given you a ring? With a ring, how you will make it happen? Okay, let's see that. With a ring, what will happen? You will see the environment. One step you meet CH2, here also you will meet CH2, here also you will meet CH2, here also you will meet CH2. Means same environment is there, same environment. If the environment is same, what you will write? GI will not be shown, right? No GI here. What about this one? Methyl and hydrogen are different. So in this case, the condition is applicable. What about this one? You meet here, you meet Bintu. Here you meet Chintu. Here you are meeting bromine. Here you are meeting chlorine. So environment is different, right? Okay. Here you are getting dosa. Here you are getting uttapam. So environment is different. So that is the reason here it will show GI. Tell me, is that clear? The question on will this show GI or will this not show GI? This is how you will see, right? Tell me, is there any problem in that? Any problem in that? Any problem in that? Now when GI is being shown, right, that means when same groups are on the same side, that is called as cis. When same groups are on the opposite side, that is called as trans. Okay, that is called as trans, right? Okay, yes everybody. Acha, now if you see this here, both same, will this show GI? No, on the same carbon you have same group, so no GI, no GI here, right? GI in cycloalkane. In cycloalkane, how you show GI? Same substituent on different position will show GI. If you have same substituent, same position, no GI. Okay. So if you have same substituent on different position, GI will be shown. Let's say there is one like this here as well. There is one CH3 here. Let's say. Now it will not show GI because same substituent on same position, GI will not be shown. There is no same substituent on same position, GI will be shown. Okay, that is a trick for cycloalkanes. Usually they ask you alkenes only, but still I have given you cycloalkane as well. It's a simple trick, so you can easily understand that, right? Okay, yes, this is guys syn and anti here, right? So syn and anti here, what is syn? Syn means when you talk about that your lone pair and OH are on the same side. Wait a minute. Wait a minute. Wait a minute. Think we oxime, so we are. Wait a minute. Aldoxime we have written now. R and OH, wait a minute. Here we will define it as lone pair and H. If they are on the opposite side, that is anti. If lone pair and H, they are on the same side, that is syn. Okay. So when lone pair and H are on the opposite side, they are anti, right? When lone pair and H are on the same side, that is syn. Okay. Whereas so they don't ask you as such, but still because it is under the same category, that's why I have drawn it here. Right? Okay. Now this is very, very important. They ask you E and Z. So let's see, E and Z is from CIP rule. CIP rule, I'll give you a little bit about, the thing that is important for you to do it in the exam. I'll tell you only that much, right? That is sufficient for you, right, for your exam. Because I have taken the examples like that only so that you know how to do this, right? Okay, see. If I talk about this thing, CIP, Carl, Ingold and Prelog, so more atomic number will give high, we basically give the priority here. Priority will be more is the atomic number, higher will be the priority. Like if you talk about hydrogen and chlorine, chlorine has more atomic number, it will have first priority, it will have second priority, right? So what you do, on the same carbon you give the priority, and then you see, if I say, let's see, first and, I'll just tell you this here, right? This is hydrogen, this is tritium. This has same atomic number. If they are isotope, then more atomic mass will get more priority. So this will get more priority as compared to this. In this case, you have this carbon that is attached to 2 hydrogen and 1 oxygen 18. This carbon is attached to 2 hydrogen and 1 oxygen 16. This all will be cancelled. You are left with different thing, that is O18, this is O16. So if you see this here, O18 is more atomic mass, so it will get more priority. So here it will be first priority, this will be second priority. Now remember one thing, right? When you have E on the, that means when you have 1, 2, 2, 1, that will be E, right? Okay. If you have 1, 1 and 2, 2, that will be Z. E for enemy, enemy is on the opposite side. Just remember that. E for enemy, enemy is on the opposite side. Okay? Sisters together, right? E for enemy and enemies is on the opposite side. C for cis, sisters are always on the same side. Enemies are always, here you can remember this by sisters, cis, right? Sisters are always on the same side, right? That is why cis is together. E for enemy, enemies are always on the opposite side, right? Okay? Yes, just remember this thing. Now if I tell you this one, now if I explain you this one, if you understand this now, that means any question you can do based on E and Z. Because I have taken only the complicated question. I am not taking easy one. What if I give you this thing? This is C, this is chlorine, this is bromine, this is hydrogen, this is CH3. This is not a big deal for you to answer. You will be like, ma'am, this so even we can answer. Ma'am, you solve this one. This one is very easy. Chlorine is lower. This is higher. Higher will get more priority. Now this is 1, 2. This is 1, 2. So this is definitely be E. Simple. Very simple. You don't have to do any as such work. This is little complicated. Not complicated, but you have to know the core thing here. Single bond means 1. If you have double bond, that means it is connected to 2 carbons. If you have triple bond, means it is connected to 3 carbons. Just remember this. Okay. So if I talk about this thing here, this thing is actually carbon connected to 2 oxygen and 1 hydrogen. Double bond means 2 oxygens. Here, this carbon is connected to 2 hydrogens and 1 carbon. I want to see step by step I want to go, okay? So I am teaching you this quite slowly. Reason being, I want every student to get this. First carbon, it is connected to 2 carbon and hydrogen. This carbon is connected to 2 hydrogen and carbon. Definitely because of 2 oxygen, that is on the higher priority. Carbon, carbon will cancel. Hydrogen, hydrogen will cancel. Here you have carbon and hydrogen. Here you have two oxygen. So that will have more priority. This is 1, this is 2. Right? Higher atomic mass, higher atomic number. Right? Here, this has C is connected to 3 carbons. Right? This C is connected to 2 carbons and 1 hydrogen. So you can directly say this one will have more priority. CC will cancel. 2 carbons will cancel. Here you are left with carbon and hydrogen. Hydrogen has less and carbon has more priority. So answer will be 1, 1, 2, 2. So answer is Z is the correct answer here. Tell me. Right? Okay. Cis is different, guys. In cis, right, at least 2 atoms has to be same, right? That's only you can define. Here you can't define cis and trans. All the groups are different. Okay, tell me. Yes? Yes, definitely you will get the entire notes after the class, right? Okay. Then let's see the calculation of GI. They are asking you this a lot. First question they ask you from this is which will show GI, which will not show GI. Then one more question they ask you is calculation of GI and stereoisomerism. Last year only they asked a lot of like 2 simple questions they asked you from that. See, this is the formula that you have to learn yourself, right? But majorly what we have seen, the questions they till now what they ask you is from asymmetrical, and asymmetrical has the same formula everywhere, 2 raised to power n, right? So symmetrical has different formula, right? Where n will be what? N will be number of GI sites. N will be number of GI sites. You can see n is equals to number of double bond showing GI. That is n. For example, you have this compound here. This is 1, 2. But this has 2 hydrogens here. So it will not show GI. On the same carbon, you have 2 same atoms. No GI is there. Here, this is 1 hydrogen and 1 CH3. This carbon has 1 hydrogen, 1 CH3. This will show GI. This 1 hydrogen, 1 this compound, this will show GI. So n is equals to 1 because it is unsymmetrical. So GI will be equals to 2 raised to power n, that is 2 raised to power 1, that is 2. So answer is 2 GI will be shown here. What about this one, everyone? What about this one? Right? Okay. Yes, if I talk about this thing, this is also GI site, this is also GI site, and this is symmetrical in nature, right? Symmetrical means n is equals to 2. So P will be, n is, whenever n is even, P is equals to n by 2. So P will be equals to what? 2 by 2, that is 1. Okay, that is 1. Now P is equals to 1 and the formula of GI is simple. 2 raised to power n minus 1 plus 2 raised to power p minus 1. Okay, n is what? 2. 2 raised to power 2 minus 1 plus 2 raised to power p minus 1 is 1 minus 1. So it is 2 raised to power 1 plus 2 raised to power 0, that is nothing but 3. Because 2 plus 2 raised to power 0 is 1 only, so answer will be 3 is the correct answer here. Right, everybody? Tell me. Right? Okay. Done. Now let's see this JEE 2024 question. Till now, so they are asking you unsymmetrical only, so you will not find the PYQs difficult because unsymmetrical only they are asking you. But still, I have written the formula of symmetrical as well. I have shown you also how to solve it, because what if they ask you symmetrical this year? What you will do then, right? So simple is you will do it like this. Now, if you see this, this is unsymmetrical because this carbon has 1 methyl and 1 hydrogen here. Everything else is symmetrical, but these two things are not symmetrical, right? So that is why this is going to be unsymmetrical, asymmetrical. So here GI is 2 raised to power n. You will have to calculate n here. N is on this double bond, you have 2 different and 2 different, this shows GI. On this double bond, these two are different. One is hydrogen, one is methyl. But here, this and this is same. This group is CH3, CH2, CH2. Double bond, double bond. Double bond, you have CH3, CH3. On this, you have D and H, D and H. So that is symmetrical. Symmetrical, I am saying. This double bond has same. This group and this group is same. Okay, so that's why it is not showing GI. It is very important. See how they played with you, right? This is not showing GI, so this is not GI. This is GI, right? So n is equals to 2, right? So answer will be 2 raised to power n, that is 2 raised to power 2, that is 4. So answer is 4 is the correct answer, right? Okay. Then next question is, okay, so this is based on cis and trans, J 2025 question here, right? Okay. Okay, now inorganic statements, I'm saying propene shows geometrical isomerism. So first is propene, 1 2 3. This is propene, it has 2 hydrogens, so whenever it has situation like this, it will never ever show any GI here because 2 atoms are same here, so it will not show any GI. Trans isomer has identical groups on the opposite side of the double bond, that is definitely true. Cis is higher dipole moment. See, if you talk about cis and trans, right? Cis is you have this situation, trans is you have this situation. So here they are cancelling each other. Has higher dipole moment? No. Trans will have higher, right? So that is wrong. Cis though it will cancel, no? It will cancel each other, right? Whatever it is, it will cancel always, so it will be lower. So cis always have lower dipole moment. Shows 2 geometrical isomer. What about this one? 2 methyl, 2 butene. 1, 2, 3, 4. 2 methyl means on second you have methyl. Butene, butene, butene. This. Because here also it has 2 same CH3 on the same carbon. It will not show GI. Right? Trans isomer has lower melting point than cis. See, if you talk about cis, trans is more symmetrical. That is why its melting point will be more. That is correct. So answer will be B and E are correct, right? How they are saying 2-methyl butene is showing GI? No, 2-methyl butene will not show any GI. Wait a minute. Let me see. 1, 2, 3, 4. 2-methyl. On second you have methyl. But 2. Here you have 2. This is also wrong, guys. Okay, it will not show any GI, right? Okay, it's incorrect only they are asking. Wait a minute, incorrect they were asking. Okay. Wait a minute. Then if I talk about cis dipole moment, wait a minute, have I think I interchange these two things. If I talk about cis, butene, okay, I'll make it butene 1, 2, 3, 4. If I talk about this thing, if I talk about cis, let's specify this CH3, CH3, right? Dipole moment, if I say, has higher dipole moment than trans. Trans dipole moment will be added, then here dipole moment will be subtracted, so it will be higher. Okay, I think I might be wrong then, because according to me logic, maybe some angle difference will be there. Wait a minute, let me just verify that. Let me just verify that. I think so, yes, it is correct only. Okay. Okay, yes, my bad. Yes, yes, yes. If you see this here, my bad, my bad, my bad, right? Cis dipole moment of cis is higher and melting point of trans is higher. Yes. Okay. Okay. So what will happen here? They will get added. They all will get added because here I'm actually na. I think the big mistake that I was doing is, you know what I did? I was thinking same, but I am drawing cis as trans and trans as cis. I think my brain needs rest now. That's what I was thinking, that how is it possible? I am drawing this as trans, this as cis again and again, right? Yes, so this is trans. So obviously trans will get cancelled, na? Right? And cis will get added because this is cis. Oh God, what a blunder I was doing, right? Oh my God, Diksha ma'am. So sorry, right? I think my brain got freeze and I was drawing cis and trans as cis. When I imagine cis, I imagined it like this. Okay, so definitely cis has higher dipole moment because trans will get cancelled with each other. That is also true. And trans isomer, so exactly what will happen? Cis is like this. Okay, so it does not have a proper symmetry. But if you talk about trans, right? Okay, this is like chair on each other. Okay, this is like you have chairs now, so it has a proper symmetry. That is why this has more melting point, right? So answer will be, this is trans will have, cis has higher dipole moment and trans has higher melting point. It will be higher here, right? Okay, so answer will be A, these are the incorrect, and B and C are the correct ones, right? Now, let's talk about optical isomers. Yes, everybody, now let's talk about optical isomer. My bad, my bad. I'm so sorry. Wait, bhai, wait. Optical isomers, if I talk about, first thing is in optical isomers, right? If there is no rotation, that is optically inactive. If there is rotation, that is optically active. Ma'am, what is that rotation? If you pass a compound through a plane, if a plane polar, this is a compound and a plane polarized light is passed through it. If it rotates, then that is optically active. It does not rotate, that is optically inactive. Rotates means if it rotates clockwise, that is dextro, that is defined by this positive and small d. If it rotates anti, dextro means on the right side, if it rotates on the right side. And here in levo, it rotates on the left side. Okay, that is levo. Now, this whether it will rotate on right or left, that you can't define by looking at the compound. That is an experimental thing. But you can define whether it will be optically active or not, right? For whether it will be optically active or not, how you will define it? You will define it by that if there is asymmetry, no plane of symmetry is there, no center of symmetry is there, right? Then, and at least one chiral carbon is there, then it is optically active. Just remember AC. Optically active is the one that is asymmetrical and it is having chiral carbon. That's it. Okay, just remember AC. Optically active is asymmetrical and it has chiral carbon. Ma'am, what is chiral carbon? Let's talk about that. Chiral carbon, I think I have mentioned it here, right? Chiral carbon is that thing which is sp3 hybridized and it has 4 different group attached. For example, this has 4 different group attached and it is sp3. This carbon has 4 different group attached and it is sp3. This carbon is not sp3, others are not chiral. This is sp3 but it has 2 same hydrogen attached. In this case also there is no sp3. This is sp3 but it has 2 hydrogen attached, so not possible. So these are the chiral carbons that you have. Okay, yes. Done. Okay. Now, if I talk about number of double bonds or rings, let's say here I am talking about either you have cumulines that has like double bond next to each other, or you have rings. Rings means you have, let's say you have spiro rings, spiro compounds. Spiro compounds are these, which has one carbon atom, right? Okay, this is spiro compounds, right? This is a trick for that. So if you have even number of double bonds here, or even number of rings, if you have even number of double bonds, then see, if you have odd number of double bonds or rings, then it is inactive, optically inactive. If it has even number of rings or double bonds, then you will see if different substituents on one carbon are attached to different substituents. For example, here it is methyl, this is ethyl, this is chlorine, this is bromine. Now, how many carbon it has? How many double bond? 1, 2, 3, 4, 5. 5 double bonds means odd. It is already inactive. Let's say you have even. This is 1, 2, 3, 4. 4 bonds means even. They have all different substituents attached. So different substituents on same carbon. Different substituent. That means it is active. Let's say same substituent. Let's say here also you have chlorine. Then it is inactive. Okay. Let's see. Here you have chlorine and here you have bromine. Here you have chlorine and here you have ethyl. Now it doesn't matter whether on different carbon you have same substituent or not. I am talking about same carbon. On same carbon you should have different substituent on same carbon. Different carbon doesn't matter. On same carbon you have different substituent. Okay, right? Okay, yes, tell me if that thing is clear. In this case, if I say these are the spiro rings that you have, okay? If you have odd spiro rings, it doesn't matter substituents are same or different, it will be always inactive. If let's say you have even number of spiro rings, here you have methyl, here also you have methyl, here you have chlorine, here you have bromine. Now same carbon has same substituent, it is inactive. If let's say here you have methyl and ethyl, now it will become active because different substituents on the same carbon. Okay, tell me. Done, 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 done. Tell me, right? Now, meso compounds, they always have two chiral centers, one plane of symmetry is there, and they are optically inactive, right? Okay, even after having chiral carbons, they are optically inactive. So here, let's say like these compounds, they have two chiral centers and POS is present here. This is the POS. So this is meso compound. Same with this one. It has two chiral centers, right? And POS is present. So that are meso compounds, right? Next is how to calculate optical isomer. Usually they ask you calculation of GI and calculation of stereoisomers, right? This is what they usually ask. But now here optical isomer, देखो, as such तो usually GI and stereoisomer is asked, but this also they can ask. If they are going on the same line, so they can ask. This is an important thing that they are doing right now. So this is the formula and all you can go through yourself as well. This is the formula. I can't do anything with that. I can just give you the table and you have to learn the formula yourself. You have 20 days for that. I am not taking the marathon 1 or 2 days before the exam. You have time to remember, learn these formulas, right? Okay. Always remember optical isomerism, optically active. Optical isomer, total optical isomers are equals to optically active isomer plus meso isomer, right? Okay, these are the meso, how you calculate meso compounds, how you calculate optically active. You add both of them, you have optical isomer, and racemic mixture or enantiomer will be optical isomer, optically active divided by 2. So now what exactly is stereoisomer calculation? Okay. Now, firstly thing is, ma'am, what is n here? Right? N is equals to number of chiral centers. Like in case of geometrical isomer, n was number of double bonds showing Gi. Here n is number of chiral center, right? Okay. Yes, but everything is different here. The compounds are different. That's why the way we understand it is entirely different, right? Stereoisomer has this calculation. Stereoisomer A 2 raised to power n. That is the formula for asymmetrical. Symmetrical. This is the formula for even. This is how you calculate P. For odd, this is how you calculate the value of P, right? Now I'll tell you how to calculate stereoisomer and stereo center. Let's talk about that. Okay. So if you talk about stereo center, in stereo center, what you do, firstly, so this will not show Gi, right? This will show Gi because here you have one hydrogen and other part is different. This is one hydrogen and other part is different. So Gi site is one and optical isomerism site, there is one chiral center here. Is this also chiral? Wait a minute, let me see. This is so definitely chiral. This is different, that is different, that is different. Here you have none of them are chiral. Here this is also not chiral. Here this one, this is different, this is different. Hydrogen is different. This is also chiral. So two chiral you have. This is also chiral, this is also chiral. Okay. Optical isomer, that means optical isomer I am not saying is 2. That means double bond showing is 1 and chiral center is 2. So value of n here is equals to 3. 1 plus 2, that is 3. So this is asymmetrical. So answer will become 2 raised to power n, that is 2 raised to power 3. That is 8 stereoisomer will be here. Right? Okay. But if I calculate stereo center, center means this is first center, this is second center, and this is third, and this is fourth. So one Gi that you are taking, one double bond, that will have two centers. In this, I am calculating Gi as 1. I am calculating double bond as 1. In stereo center, you will multiply Gi with 2. Number of double bond, you will multiply it by 2 because you want to create the center. So here stereo center will be equals to 2 chiral plus 2 into 1 Gi, that is 4. And stereoisomer will be equals to 2 raised to power n, that is 2 raised to power 3, that is 8. Okay, tell me, is that clear? What is the difference in stereo center and this? Let me see. Okay. Chalo. Now let's talk about the next thing here. That is J means 2022-25 question here. Let's talk about that. How many different stereoisomers are possible for the given molecules? Right? If you see this here, J 2025 question this is. Firstly, this is asymmetrical, so it will be 2 raised to power n. This is, I told you stereoisomer in Gi, so they ask you. Optical isomer also they can ask you. It is the same way, just calculate the chiral center and put the formula, right? So here stereoisomer, firstly this is chiral center. This Gi is showing Gi. So n is equals to 2. Right, so stereoisomer will be 2 raised to power 2, that is 4. So answer will be D is the correct answer, isn't it? D is the correct answer. Tell me. But if you are able to do whatever I am teaching you, trust me, you are ready for the exam. You are ready, you will be ready for the exam. Those who know that I am not skipping anything here, I am doing everything. Okay, calculations done now, everybody. Now let's see this thing here, RS configuration. Dekho, RS configuration is that topic which you can also skip, right? Because as such, it is not very high priority topic. but I am taking it for those students who don't want to skip anything. Okay? So this is for those students because it's a very simple data. If you know CIP rule, it's not a tough thing to calculate. So what you do here is lowest priority group, mostly hydrogen, is on the vertical position. That means on the vertical position here or here. Then clockwise will be R, anti-clockwise will be S. If it is on the horizontal position, everything will be opposite. That means clockwise will be S, anti-clockwise will be R. Just remember, if vertical, on the vertical position you have lowest priority group, that is the fourth priority group, then you will have S, clockwise means S, anti-clockwise means clockwise means R, anti-clockwise means S. Okay. Now I'll tell you this all I'll teach you. Firstly, let's see this. How do you define S and R? See this thing. 4 groups you have. Here carbon is 1 oxygen, 1 oxygen, 1 hydrogen because double bond. This is carbon is 1 hydrogen, 1 hydrogen, 1 oxygen. Here carbon is 3 hydrogens. Here it is hydrogen. So hydrogen always have lowest priority. Here carbon, carbon will be cancelled and you will see Cc will be cancelled. Here HH will be cancelled. Here you have 2 oxygens, so it will have first priority. It is CIP rule only that we discussed for E and Z. Okay, CIP rule only it is. Right? Yes, let's go. 1 and 2. Right, 1 and this will have second because this is oxygen, this is 2 hydrogen connected. So this is 2, this is third. Can you tell me, here it is on the horizontal position. So clockwise will be S, anti-clockwise will be R. This is 1, 2, 3. It is anti-clockwise. Clock moves like this. This is anti-clockwise. Anti-clockwise R, so this is R. Here answer is R. Okay. Acha, see this. Okay. So here this is fourth because it is hydrogen. Carbon will be first. This will be, after carbon you have nitrogen. Wait a minute. Array. Oxygen will be first. It has highest atomic number. Then this says atomic number 8. This is 7. This is 6. So it is 1, 2, 3. Highest atomic number will get high priority. So if you see 1, 2, 3, this is moving like this. This was moving like this. This is also anti-clockwise, but here lowest priority group is on the vertical position. So it will be R. Okay, understood? This is some really good level question. If they ask you, only then you do this. If you want to skip, you can. If you want to skip, it is not so very emergency of doing this. But if you do, it is better. At least this much you should know how to learn R and S. Acha, now what exactly is the criteria of doing this? If you have one chiral carbon, like here you had only one chiral carbon, what you do? If both are R, that means I am comparing two compounds. If both are R, they will be, formula should be same, okay? It's not like, ma'am, these two are R, ma'am, they are also identical. No, formula should be same. Formula is same and both are R or both are S, they are identical. If one is R and one is S, they are enantiomers of each other. Enantiomer means non-superimposable mirror image. Identical means superimposable mirror. Now my hands are enantiomers, they are non-superimposable mirror images, right? Okay. Distereomers are not even super mirror images of each other. Dekho, if you have two chiral carbons, right, what will happen? I'll show you this here. If you have two chiral carbon, this and this is chiral. Let's say what you find out, both opposite. That means this is R, this is S. This is R, this is S. Or you have this as R, this as S, this as S, this as R. Or you have this as S, this as R, this as S, or this as R. Means this carbon and this carbon is opposite, this carbon and this carbon is opposite. Then they are enantiomer. Both are same. Both same means what? Both same means this is R, then this is also R. This is S, then this is also S. Or if this is S, then this is also S. This is R, then this is also R. That is both are same. Then it is identical. Okay? One opposite, one same. What do you mean by that? If this is R, and this is R, this is S. This is one case. Or you can say this is S, this is R, this is S, and this is S. So one same, one opposite. That is distereomer. Okay, tell me, is that clear? Done. Let's see how many likes you have made. Let's see that. Okay. So now then there is DL. If you talk about DL, what is DL? DL is simple. They are mirror images of biomolecules. We'll see that. Oxidized group on the top. Here it should be oxidized group. Okay. Last chiral carbon. This is the last chiral carbon. This is the last chiral. This is not chiral. This is not chiral. This is last. If here OH is on the left side, it is L. If OH is on the right side, this is D. Capital D and small d does not have any relation with each other. Dextro and levo is different. This is different. Okay. Now, if last chiral carbon, let's say here you have, if last chiral carbon, that is so we have done. See, what if you have a compound which has NH2 also, right? Okay, now what you will do? Can you tell me? If there is NH2, then OH has no value. Then you will not see the last chiral carbon. You will just see that if there is NH2, then you will just say that NH2, if it is on the right side, this is capital D. This is only in case of NH2. In other cases, you will see only OH, right? Okay. Acha. Now, let's see epimers and anomers. What do you mean by epimers and anomers? Yes. Okay. After epimers and anomers, I'll just give you 5 minutes break and I'll just join back, right? Okay. Because then hydrocarbons we will start. Conformers is a part of hydrocarbons. Rearrangement of carbocation is also a part of hydrocarbons only. So after this part, I'll just join back, right? After 5 or 10 minutes break, I'll give you, right? 5 minutes break, I think, is enough. So if I talk about epimers, epimers are diastereomers that differ in configuration only on one carbon. For example, only on one carbon. Here everything is same, but on this carbon, they have different configuration. Epimers is a term used in case of sugar only, right? So epimer means when they have different configuration only on one chiral carbon. Others are same. Anomers are cyclic epimers, right? In this case, anomers are epimers, but epimers may not be epimers. So anomers are what we call, in this case, they also differ in the position here, like alpha and beta. They differ in the position, right, on the first carbon here, right? They are anomer, they are cyclic epimers, right? They are cyclic epimers, right? Okay, tell me. Tell me. C2 epimers, like on the second, you have different configuration. C2 means, where 1, 2, this is second carbon has different configuration. This is C4 epimer means 1, 2, 3, fourth carbon has different position, 1, 2, 3, fourth. So glucose and galactose are epimers of each other at C4 position. Glucose and this we will do more in this biomolecules, right? We will do more of this in biomolecules, right? Okay, tell me, is that clear? Achha, next will be conformers of ethane, but for that I'll just give you break for 5 minutes, right? I will give you bigger break, guys, at 8:30 when we are done with conformers and some part of hydrocarbons. At 8:30 I'll give you big break. Okay, that will be the dinner time. At this point, only 5 minutes break now. Okay, yes. Okay. Hmm. Okay. My energy was dropping. So that's why I thought, then let's eat a little bit. You want this? I love this. It's peanuts coated in sugar, jaggery, in fact. It's the best thing. Trust me. I eat like in this season, I eat this like crazy. Like I can finish one packet in just one sitting. Hmm. So whenever I feel low and whenever I feel like oh, my energy is dropping, I just have a little bit of it so that my energy can lift, right? Okay, because dopamine is very important. I used to do this like when I was of your age as well. And I used to eat little bit of it, and while eating, I don't know if you are also eating side by side. I do a lot of snacking and all when I am studying. I have to do a lot. Do you also do the same? Isomerism is almost done, right? You can ask me if there is any problem in this because we are on the last part of isomerism, that is conformers, right? Then we'll start with rearrangement, right? Okay, tell me, what is your favorite thing to eat when you are studying? Like, I have a lot of water, and I have usually I have that haldiram namkeen or moong dal, or I have this yeah, this I told you, peanuts coated with a lot of jaggery, especially made at home. That is the best. Yes. What is the name, ma'am? Yeah, I don't know what is the name of this. Like in my where I live, we call it gachak. I don't know what it is called in other parts of India, but that's why I told you it's peanuts coated with jaggery. It's very tasty. It's very tasty. You must try it. It's my favorite thing. I think no biscuit, no chocolate, nothing. Everything is zero in front of that. Right? Chocolate and all, though I don't like in front of it. Yes. Chalo. Now, ma'am, you are mute. Ma'am is on mute, huh? Hmm. Can you see the lifting of my energy as soon as I ate it? Can you see that? So I'll have a little bit tablet as well. You'll say, ma'am, what are these tablets? You know, when you speak a lot, my throat gets sore very soon. So that's why. You know, it's better to take care of your health, isn't it? Hmm. Shares all the important things I have taught. You can go through this, right? Okay. Hmm. Everybody, while studying, I forgot to eat. Ma'am, happened today. I forgot to eat breakfast. No, I never forget to eat. That is my main priority in life. Okay, so if you talk about conformers are, they are because of the rotation itself. You have a back carbon, you have a front carbon. Because of the rotation, the conformers will exist, right? Because of the rotation itself. So if I talk about stability order, staggered is when this is the actually what happens here. I'll just draw this one, just 1 minute. I don't think so without drawing you will be able to understand what I want to say. Okay, I'll just give you a quick thing about it, right? Okay. One methyl, other methyl, ethane I'll draw. Others, na, it will take a lot of time for me to draw. Then we will do only conformers today, right? I have explained it in the detailed lectures, but now as we are doing revision, so I'll just do a little bit. I'll just show you that what exactly is that, and after that we'll move ahead. So there is this dihedral angle that you have. So conformers are due to the rotation. So what exactly happens here? You have this front carbon, you have this back carbon, okay? You have this front carbon, then you have this back carbon. Wait a minute. Yes. So you have this front carbon, then you have this back carbon. This is front, this is back, right? How we draw it in 2D is, we draw it circle with the front carbon and back carbon with this dot, right? Then if I say they both are overlapping, this angle is 0. That is called as eclipsed because this is hiding. This is hiding. Can you see this is exactly hiding it? So that is eclipse, like you have moon eclipse, solar eclipse, same way this is atom eclipse. Okay. So now if you can see this is hiding, there is 0 dihedral angle, that is angle is 0. So that's why it is drawn like this, 1, 2, 3 and overlapping it will be. Overlapping, that's how we draw it in 2D. Right? If I say this is front carbon, this is back carbon. If I say the angle is 60 degree, now it is staggered. Staggered means scattered. Right? Now the angle is 60 degree, it's not hiding any groups here. Right? So what you draw, one of them you draw like this, other you draw like this. Okay, that is staggered. So definitely which one is more stable? Always remember staggered is more stable than eclipsed. Reason being because repulsions are less. In case of eclipse, repulsions are more. Okay, that is the reason. Now next is in case of propane. In case of propane, let's say this is methyl. Okay, let's say this is methyl. So again staggered is the one that is having 60 degree angle. So how you draw it is, you draw one CH3. Let's say I am drawing it like this. You draw CH3, then all of them are hydrogen that has angle of 60 degree, right? When I talk about eclipsed, right, it is this methyl, you can draw it like this. Methyl is hiding this hydrogen, they are hiding each other, this is also hiding it, so that is eclipsed. That is how you draw it. Again staggered is more stable than eclipsed. Reason is same. Okay, reason is same because of repulsions. Then conformers are butane are mostly asked to you. What is conformers of butane? In case of conformers of butane, what they ask you, in this case you have 2 methyl, okay? Let's say this is methyl. So what will happen? Okay, Samriti, I'll ask the team why it is not available, okay? Because I have sent it. I don't know it was not available. I'll today take care of it that by tomorrow inorganic and organic both are available to you, okay? So yes, now see this. This is totally fully eclipsed because methyl is hiding methyl, right? If I see this structure, this will be fully eclipsed. Fully eclipsed means methyl is hiding methyl, right? Then when you mark an angle of 60 degree here, right, like this is called as gauche. Gauche and anti both are under the category of staggered only, but when two methyl are next to each other, they are next to each other like this, okay, then they are gauche. If you further make it, this is partially eclipsed. Why? Methyl is not hiding methyl, hydrogen is hiding methyl, methyl is hiding hydrogen. So when you have this situation, that is partially eclipsed. When you have this situation, further you decrease it. Now can you see, this is the kind of situation that you will have. This green and this green are anti to each other. That is why it is called as anti, right? So if you see the repulsions, the stability order, anti has least, methyl should stay away from each other if they want to be stable. So these two are anti to each other, methyl repulsions are least, that is why it is most stable. Then if you talk about in case of gauche, that is this, also they are least repulsions because they are not overlapping each other. If you talk about this situation, it is now repulsions are there with hydrogen and methyl, hydrogen and methyl. In case of methyl and methyl, so many repulsions are there, that is why it is least. So anti-gauche, partially eclipsed, then fully eclipsed. That is the stability order, and the stability order is very, very important. Okay, it is very important for gauche. It is for this one. It is very, very important, right? Okay. Then you talk about gauche effect. Gauche effect is if there is hydrogen bonding. In some cases, gauche become more stable. Gauche conformer become more stable due to hydrogen bonding. So you have this thing here. You have ethane. So what will happen here? This is front carbon. This is back carbon. So what will happen? In this case, this is OH and this is F. They will cause hydrogen bonding with each other. That is why this will become more stable. Here though you don't have any hydrogen bonding. Here also you don't have any hydrogen bonding. Here you have hydrogen bonding. That's why they are becoming more stable. Okay, right? Done? Acha. Then there is chair conformer. Then there is conformers of cyclohexane. That much detail you don't have to go through. Just go through this thing that there are 4 conformers: chair, boat, twisted, and half chair. Right? In all of them, chair is more stable, most stable. You will see mostly in this form only. It's a Twitter sign, right? So then you have twisted boat, then you have boat, then you have half chair. Okay? Understood? Done? Tell me. Just remember the stability order. Now let's see rearrangement of carbocation and ring expansion, ring contraction, that I will use heavily in reaction part. Okay, let's see that. Shall we, everyone? Tell me. Ready for it? Rearrangement of carbocation. Let's do that. Okay. So rearrangement is done to reach a more stable carbocation intermediate. Like we know that the stability of intermediates are like this: 3 degree, then 2 degree, then 1 degree. Carbocation showing back bonding will always be more stable irrespective of degree. Carbocation showing resonance will be more stable than carbocation not showing resonance. Let me tell you how. Right? So if you talk about rearrangement of carbocation, for example, you have, now I'll give you 3-4 cases here. Okay? Right? See. For example, you have, let's say, this is CH3, this is CH3. Okay, let's make it like this. This is C, this is CH2, this is CH3. This is in fact CH. Okay? This is the carbocation that you have. This is what kind of carbocation? This is a 12th portions. I'll be starting now. right? I have just completed GOC, isomerism and all these parts, right? Now see this thing. CH3, CH3, CH, and this is this. This is 2-degree carbocation, right? Rearrangement will take in such a place that what will happen? Hydride will shift here. But now the question is, ma'am, why methyl cannot shift? So always remember the order of migratory aptitude is like this. Migratory aptitude is happy me. That is hydrogen, phenyl, pH, happy me. Hydride has the maximum migratory aptitude, right? So this hydride will shift here. See, this hydride will shift here, right? If I want to make it more like in a better way, I'll say this is C, this is H. So this hydride will shift here with the electrons. Okay, this hydride will shift here with the electrons, and hence in the answer what you will have, in the answer you will have CCH3. This is CH3. This is positive because hydride has shifted here. This becomes CH2 and CH3. Can you see this is a 3-degree? I'm so sorry. Those who were wearing headphones, I'm so sorry. Unexpected. Right? So, this is 2-degree and this is 3-degree. Right? Okay? That is why rearrangement has occurred here. Now, for example, ma'am, you have, let's say, this is CH3, this is CH3, right? This is pH, this is CH positive, this is CH. Now, can you tell me which one will cause the rearrangement? Can you tell me where you will see the rearrangement? Just tell me that whether phenyl will go or this CH3 will go. Happy me. So phenyl has more migratory aptitude. So phenyl will move here, right? So that is the reason. Here what you will have CH3. This is C positive, CH3. This is CH. This is phenyl, right? And this will be CH3. So that will be the carbocation that will be formed here, right? Okay, yes, done. Now let's see this thing here. What if you have a compound which is, let's say you have pH, C, this is pH, this is C, CH3, and this is CH3. Tell me, will there be any migration here or not? Will there be any migration here or not? This is also 3-degree. It is stable only. Then do you want to cause migration or not? Right? Tell me, is that clear? Right? Here in this case, if I shift it here, what you will have? You will have C, this is pH, this is pH. This pH means phenyl, no? This will cause resonance, isn't it? So that is why, because of this resonance, this will become more stable. So that is the reason I will make it this carbocation. Why? Because this is 3-degree plus resonance. That is why this will be more stable, right? Okay. Next is, if you talk about, this is shifting here. Now, those who want to see it for the board, right? See, definitely it is more in depth. It is like this, these all things are way above board level. But yes, you can do one thing if you want to watch it for board examination. After hydrocarbons, I'll do some naming reaction, just where I am going more in detail. You can skip that part, but you can, like all the important reaction of class 12th, everything that will be, you can join the this after 9 p.m. right, if you want to cover class 12th. Yes, right. So if you see this over here, this is 3 degree plus this is the resonance over here, right? Then what about this one? What about this one? Here you have what? Here you have, let's say, back bonding. This is O, this is positive. Yes. Now tell me, will you cause any rearrangement here? Will you cause any rearrangement? This is 2 degree, right? If I shift it here, let's say if I shift it like this, if I shift hydride here and I have this thing, now there will be back bonding, 2 degree plus back bonding, so automatically it will be more stable, so rearrangement will occur. Maximum this much you need to know, and after this, that's it. This is maximum that you need to know. Okay, tell me. Yes, done. Okay, now let's talk about ring expansion and contraction. What we will do with the ring expansion and contraction, see, simple trick I will give you here. Ring expansion, always remember 6-membered ring is more stable than 5-membered. 5-membered is more stable than 7-membered, then 4. 6, 5, 7, 4, 3. 6, 5, 7, 4, 3. Just remember this order. Okay. So if you have a 4-membered ring, do you want to expand it and convert it to 5-membered? Yes, because 5-membered is more stable than 4. So I can do that. How I will do that? Put 1, 2 and 3 here. Simple thing is here what you need to do. Join these two and break the bond of this one. Right? So what I need to do? Wait a minute. I'll just show it with this one. Where the bond formation is happening, that is this one. Where the bond breakage is happening, that is this one. Here the bond is getting break. Okay. So here what you will see, this, right? And positive will shift to the second position. This, the bond of 1, 2 and 3 will break, 1 and 3 will join and positive will shift here. Okay. Then, do I want to cause this or not? Do I want to do this expansion or not? Tell me. Is this expansion required or not? Is this expansion required or not? Let me see that in the chat box. Let me see that in the chat box, right? Is this required or not? Let me know in the chat box, right? Then we will talk about ring contraction. No, ma'am. Why no? Tell me why no? Because, ma'am, this is 6-membered and you are only saying 6-membered is more stable than 7. Then why will I do ring expansion? So it will not be there, right? So there is no need of ring expansion here, right? Aise hi nahi ring expansion you will do. You will see whether it is required or not, right? So here same thing I'll apply. I'll choose 1, 2, 3 here also. From the carbon, this is 1, 2, 3. It is contraction. Same thing. I will break the bond of 2 and 3, join 1 and 3. Break the bond of 2 and 3, join 1 and 3. Break the bond of 2 and 3. This bond will break. So what I'll have this kind of situation. This will be, and this carbocation will shift to 1 to 2nd position. This will be this kind of position. Okay. Can you see? Have you seen this somewhere? Have you seen this compound somewhere? Let's see who will identify. This compound is like this. Have you seen this somewhere? I have taught you some really amazing thing about this. Right? Tell me. Why ring contraction of 4 is more stable than 3? Why ring contraction? 4 is more stable than 3, right? Ma'am, why ring contraction? 4 is more stable than 3. Yes, this contraction will easily happen. You know why? Can I see? Dancing resonance. Very good. Very good. Very good. So, ma'am, dancing resonance, ma'am, it is making it very, very stable. So, ma'am, definitely there no chance that this will not happen. Easily this will happen. Right? This is dancing. Acha, tell me, 5-membered to 4-membered. Right? Contraction. This is difficult because 5-membered ring is more stable. So, it will not as such would want to go into 4-membered ring. Right? Okay? Done. But if it goes, because see, whenever positive charge is on the ring, right, if you can avoid, you can avoid that, right? On the same pattern this will happen. So I am just writing the important thing here, that how does this happen, right? Write 1 2 3. Break the bond of which one? Break the bond of 2 and 3. Attach which one? Attach 1 and 3. Positive is shifted from first to second position. Right? Okay? Same thing we are doing here. Right, everybody? Okay. Now, are you ready to start hydrocarbons? Matlab, I have this wish. It is 7:38 now. Okay. If we complete, and I'll give you break because you know, even my mom is waiting outside for me to have my dinner, right? So she said ki please give break to students at 8:30. She's like scolded me for that. Students need to eat also, you also need to eat. I'm like, okay, I'll definitely do that, right? So I'll go at 8:30, right? Otherwise your mom and my mom they will scold us, right? So 8:30, let's try to do as much as possible, right? Okay, after that, I'll give you good amount of dinner break, right? Like 20 minutes break, I'll give you. Aram se have your dinner. Ready? Tell me. Is it possible to complete it today? Yes. Don't worry. This is your Diksha ma'am, your own Diksha ma'am. Ma'am, carbon, no, carbon ion and free radical does not have any rearrangement. Carbocation has. Okay? Yes. Are you ready? Let's see how many likes you have given till now. Yes. Very good. Spam the chat box with green hearts. Spam the chat box with green hearts. Spam it. Let's finish hydrocarbons. Before the dinner, I don't know if we will be able to do that or not, but this is my wish that if we do, that would be a great thing. Right? Okay? Ready. Now let's start with this one. First is preparation of alkenes. In preparation of alkenes, first reaction is Wood's reaction. Let's see what are the things. So you will see most of them are my handwritten notes mixed with flow charts. All these things will be there. Okay. So it's a proper content that you were looking for. Right. That's why I told you a lot of hard work I have put into these things. Right. Let me just have that medicine because I think today I'll be able to teach you only with the help of that medicine. You have preparation of alkenes. So what you have? Wood's reaction. Wood's reaction is you have Rx with Na and Rx. So what exactly happens here, right? Na and X will leave and R will join together, right? Okay. And those students who are preparing for boards, you can join now only because there are so many reactions that are in hydrocarbons that I will not repeat again, right? So if you are preparing for boards, stay here, right? Your part has started, right? Rx with sodium and this and dry ether. Now, those students who are confused about mechanisms, I'll tell you where you need to learn the full mechanism, where you only need to understand the what type of mechanism and what is the intermediate involved. So if I talk about this thing here, in this case, what will happen? Free radical mechanism it will follow. It will follow a free radical mechanism. Symmetrical and even number of carbons are formed here. Odd number are not possible. Very mixed alkanes are formed, which does not give us pure alkanes, right? So, why dry ether is used here? First thing is, dry is used because sodium is very reactive. Ether is used to increase the solvation because you have Na and you have ether, right? What will happen? This will increase the solvation of sodium. That is why more energy will be released. It will level up the reaction more, right? That is why this is used here. Now, what is the mechanism? That is free radical. Homolytic cleavage will take place. It will give you free radical, and that free radical will combine together to give you alkene. So what you need to remember here is, ma'am, it is a what you need to remember, ma'am, it is a free radical mechanism. How free radical mechanism will help you? Can you tell me that? What kind of questions they ask you? Shall I tell you that? Tell me. Shall I tell you what kind of questions they ask you? They ask you these questions. For example, why I am drawing it so small, so that you know these, I'll just draw one question here. For example, chalo, there I will write the note, okay? This is, let's say you have Br and Br here, right? Free radical mechanism will help you answer these questions. What will happen? A free radical is formed by taking out both the bromines. Two possibilities are there. First possibility is that you have intramolecular. Second possibility is intermolecular. Two molecules of this are attached together, right? So always remember, intra is preferred over inter unless intra has anti-aromatic compound, anti-aromatic product. What I am saying here? Tell me, is this anti-aromatic or aromatic? What is this? What is this? This is, ma'am, anti-aromatic. So usually intra is preferred only. But in this case, intra is not preferred. In this case, inter is preferred. Right? In this case, inter is preferred. Right? Otherwise, intra is preferred. If you draw one more compound here, if you draw one more thing here, right, where no such anti-compound is formed, let's say you have this. This is Br, this is Cl. Now it will form this kind of situation where you have two free radicals. Now definitely intra is preferred. In fact, intra is forming an aromatic compound. Even if intra is forming non-aromatic, that will also work. It should not form anti-aromatic. Okay? Right? Done? That's it. Then if you talk about Wood's reaction, Wood's fatigue reaction. In Wood's fatigue reaction, what you have, right? Rx, see, Wood's reaction same, you know, everything else is same. This I told you what kind of good level question they can ask you, right? In Wood's, you have only alkyl, right? In Wood's fatigue, this is alkyl part. This I am just asking you to remember it like that. There is no logic here. Ki Woods is alkyl. This is just a way of remembering, right? Fatigue, aryl. So here you have one alkyl and one aryl, right? Everything else is same. In fatigue, you only have aryl. So here two aryls, they are joined together. They will make this thing, right? and they will make biphenyl or diphenyl, right? Okay, all of them has inter form. I just said this follows free radical mechanism. If it follows free radical mechanism, after this a free radical will be generated here, a free radical will be generated. So here you have free radical. I said the way these free radical will make a bond, either it can be intra or it can be inter. Intra means these two are joining to make a double bond here. Inter means two molecules of the same thing. See, same free radical, same free radical. Now their free radicals are joining to make this compound, right? These free radicals are joining to make this compound. That is called as inter, right? That is called as inter. Now what we are saying that usually intra is preferred, but in some cases inter is preferred. When intra gives you anti-aromatic, then inter is preferred. Otherwise, always intra is preferred. Here it is intra. Intra is within the molecule, inter is two molecules. Okay, tell me. Sanjana, please don't spam, right? Okay, don't spam. Let others also learn. If you're spamming now, instead of I'll be doing question part. Don't worry. Right now, understand what is provided to you. Right? Okay? Yes. Done. Tell me. Wood's fatigue and fatigue reaction. Is that done? We are thinking that today if we will be able to complete this or not, and she is saying, ma'am, do organic chemistry, all the theory part and 1000+ question, ma'am. Tell her, beta, please. I don't want to say anything, you only tell. I don't want to say anything, right? Okay. Sometimes I feel like students, if I teach you 1000 questions plus theory, 2-3 hours though, without even speaking, if I even change the slides, 2-3 hours it will take me just to change the slides without even speaking anything. Right? Yes, I'll do that, right? Okay, tell me. Now here is Franklin. Now just like you had sodium here, just like you have sodium here, in the similar way Franklin will have zinc. Okay, in this case same thing will happen and you will have the formation of RR. Again here symmetrical alkanes are formed. But in case of Corey-House synthesis, you have the formation of unsymmetrical alkanes here. If you see Corey-House synthesis, here Gilman's reagent, that is R2CuLi, is formed here. And in this case, what you have, this alkane that you have, this benzene with addition of this CH3CH2. That means whatever R you have, let's say you have added Rx plus R dash 2, or you can say you have added R2CuLi and R dash X. So what will happen? Answer will be R dash. So that means unsymmetrical alkanes you can form here in Corey-House synthesis. So that is a very important thing, that in Wood's reaction, in Franklin reaction, you are not able to make unsymmetrical, but in Corey-House synthesis you are able to make unsymmetrical alkene. Right? Okay. Then there is Sabatier-Sanderson reaction, where what you will have the formation of alkane from what? You will have alkene or alkyne with nickel and hydrogenation. Basically it is catalytic hydrogenation reaction. For alkene you need 200-degree temperature, for alkyne you need around 300-degree temperature, and you will have the formation of alkane here. Right? Okay. Yes. Then what you have, soda lime decarboxylation, again a very important reaction. In this case also intermediate knowledge is very important, right? So we'll talk about how this works. Soda lime decarboxylation. right? Soda means NaOH, and lime means quick lime, that is CO. You use here. First thing is, first question, you should know directly what is formed here, because direct questions are being asked to you related to this very important reaction. This is, in this case, you have the formation of this whole will leave and you have RH. Okay, so the number of carbons that are there in the carboxylic salt, sodium salt of carboxylic acid, this is one carbon less alkane will be formed here. That is RH will be formed here. Ma'am, then what is the mechanism here? What intermediate is formed here? Intermediate formed is carbocation, carbanion. Let's see how. So what will happen? Because this is partially negative positive, so it is in an ionic state. What will happen? This bond will shift here and this bond will shift here. It will eliminate CO2 and this R negative carbanion will be formed here. Now, ma'am, do I need to remember this mechanism? No. Otherwise, it's a simple thing only. But remember, Wood's reaction free radical. This is carbanion. Wood's reaction free radical. This is carbanion. Okay. Ma'am, how does it matter? For rate of reaction. If they ask you rate of reaction, how they will ask you rate of reaction? Let me just teach you that. Rate of reaction, they can ask you this way. They can ask you rate of reaction this way. They can say that here what you have, yes, rate of reaction can be which of the following has more rate, like okay, tell me that okay, tell me which one will have more rate of reaction, which one will have, they can give you 3-4 compounds and ask you which one will have more rate of reaction, right? Tell me, this is A and this is B. If you see here, no mesomeric effect is not obeyed. Why? This is not a benzene ring. So here it is minus I, here it is plus I. This is carbanion. I want to see the stability of carbanion. What carbanion will be formed? R negative. In this case, this carbanion will be formed. In this case, this carbanion will be formed. Isn't it? So accordingly, I'll answer which carbanion will be more stable. Which carbanion will be more stable? Here you are taking out the electron, you are stabilizing it more. When to a carbanion, you give the electron, you make it unstable. When you take out the electron, you make it stable. And that is why GOC is obeyed in reaction also. Right? Okay? Understood? Tell me. Is that clear? Soda lime decarboxylation. Then you have Kolb's electrolysis. In Kolb's electrolysis, what you do? In this case, what you need to remember that this is also a free radical. Free radical is generated. Free radical formed. Okay? Free radical formed. What will be the answer? It will be double. It is same as Woods. Answer will be same as Woods. Same as Woods. Just in case same as Woods, it will be, I'll tell you how. First thing is, just like in Woods reaction, you had Rx. From there, you had the formation of RR. Here you have RCOONA and you have the formation of this RR. Okay, that is the first thing. Second thing to remember here is, what is formed at anode, what is formed at cathode, right? So you have CHCCO. Here you have one electron is added, one electron is subtracted. So here you will have free radical formation, right? After this, what will happen? After this, this will also have homolytic cleavage. You will have R free radical and CO2 will be eliminated here. So CO2 is eliminated at anode, write it here. CO2 is formed at anode. Okay. Then RR is formed at anode by this. At cathode, what is happening? Water will accept the electron, it will form H free radical, then H2 will be formed. Just remember this thing that H2 is formed at anode, and here OH negative means it will be basic medium. Medium will be basic. Okay, these are the important things that you must know from this particular mechanism here, right? Okay, yes. Tell me. Yes, very good, Shaurya. Even if that, very good, Shaurya, very good. Ma'am, even if it was benzene, even then it will not show metamerism, ma'am. Why? Because it is meta position, mesomeric effect is not obeyed. Very good, right? That thing is clear now. Now see one more thing, right? I told you, I gave you this reaction, same question in case of woods as well, same kind of question they can ask you here. You have COONA. You have COONA. Because of free radical is formed here. Free radical like this is formed here. This free radical can either undergo intra, it can give you this anti-aromatic, but it is not possible. Usually intra is preferred. Intra is preferred, but if intra is giving you anti-aromatic, then it will not be preferred. Then you will say, we need, ma'am, we have to go through aromatic, ma'am. Why? Because, ma'am, it is not possible to have anti-aromatic. Same thing, right? Okay. Sai, in case of organic chemistry, as such, we don't take care of balancing. Okay. We don't take care of balancing as such, right? Okay. Then there is Clemenzin reduction and Wolff-Kishner reduction. Let's see how it is done. Here it is wrong. Wait a minute, let me just correct that. Yes. Okay. So if you talk about, this is a wrong reaction that is written here. Let me just correct it here. If you have Clemenzin reduction, in Clemenzin, what will happen? Double bond O is converted to CH2. C double bond O is converted to CH2 in the case of Clemenzin and Wolff. But in Clemenzin reduction, you have acidic conditions. But in Wolff-Kishner reduction, you have basic condition, you have hydrazine, then you have basic conditions like you have KOH, ethylene glycol, right? Ethylene glycol, right? In this case, again, the answer is same, that here what will happen? Double bond O is converted to H2, but this will be in the basic condition. This will be in the basic condition. Okay, next let's see. Right, done. Next, let's see, next one, from Grignard region. Now, this is a very important concept. Okay, let's see that, let's understand Grignard region, what will happen. Right, at Grignard region, what is going to happen? Let's understand that. So, Grignard region basically gives you two kind of reactions it shows. First thing is how Grignard reagent is formed. Grignard reagent is formed by this particular reaction. I'll tell you how. You have alkyl halide. Alkyl halide reacts with Mg in presence of dry ether. Why dry ether is used? Because we want to, if we don't have dry ether, then what will happen? This Grignard reagent in presence of water is directly converted to alkane, and that is the reason we have to use dry ether here. So our MgX is formed. This is called as Grignard reagent. This is called as Grignard's reagent. That is an organometallic compound like Gilman's reagent, right? Now Grignard reagent is very excited for one thing, that is proton. Grignard reagent is like, you give me proton and take away everything from me. So proton is from water or alkyne or alcohol or acid, it doesn't matter. If you give it proton, it will directly be converted to alkene. This is the first kind of reaction that Grignard reagent shows. Second kind of reaction that we will see, that is shown by Grignard reagent, is that you have RMgX, and here what you do, you have any carbonyl group here, right? Now we know that in carbonyl group, this is partially positive, this is partially negative. So what exactly will happen here? This is partially negative, this is partially positive, right? So what will happen here? What will happen? This negative is going to attack here. Do you know why this is partially negative? Because metal is very highly electropositive. So all the carbons next to metal will be partially negative only. So that is why it will attack on the carbonyl carbon. These electrons will move here, and the answer that you will have is carbon. This is O negative. Mgx will be attached here, right? Here two bonds will be as it is, and here R is attached. And here we will see this further, right, in the formation of alcohol as well. As of now, just see that two kind of reactions you have here, right? Two kind of reactions. First is Grignard reagent react with proton source, right, to give alkane. Second is it give carbonyl, with carbonyl compound, it act as a nucleophile. Okay. Acha, what is nucleophile? What is electrophile? Nucleophile is the one that is itself electron rich. Okay. It can have lone pair, it can be negative, it can have negative charge. That is a nucleophile. Okay. Or it can have pi bond electrons, right, that are free to attack. Electrophile is that is electron deficient. It is electron loving. It will go and attack on the more electron density. Nucleophile will attack where the electron density is less, right? Okay, tell me. Then there is this reduction of alkane. If you talk about 1 degree, 2 degree and 3 degree alkane, right? Wait a minute. Reduction of I think this is 1 degree, 2 degree alcohol, right? Okay. This is alcohol. Yes. See, all of this is alcohol. If you have 1 degree, 2 degree, 3 degree alcohol, what will happen? Right? If you have 1 degree alcohol with LiLH4, it is alkane. 2 degree alkane. 3 degree, it will be alkene. Here, with 1 degree alcohol with NaBH4, no reaction. This all are converted to alkane. There are two different things that with 3 degree alcohol reaction with LiLH4, it forms alkene. And with 1 degree alcohol with NaBH4, there is no reaction. Okay? That you must know. Right, everybody? Now, next is reactions of alkenes. Now, let's talk about the reactions of alkenes. So, first is, if I talk about hydrogenation reaction, right? Let's talk about hydrogenation reaction, where what will happen? Hydrogen is replaced by chlorine. First, it will form chloromethane, then dichloro, then trichloro, that is chloroform, then tetrachloromethane. So, in the presence of H mu, now always remember free radical mechanism occurs in case of helper, HELPR. Matlab, if you have heat, electricity or light or peroxide or free radical already, then free radical mechanism will take place. Okay. Now, that because it has H mu, right? In cold electrolysis also free radical mechanism took place because it is electricity is there, right? So in this case, because of this H mu, homolytic cleavage will take place. Firstly, so this cleavage will take place, you will have the formation of Cl free radical. Then it will attack here again, this homolytic cleavage will take place, you will have the formation of CH3 here. Now, this CH3 and Cl, they will combine together to form CH3Cl. That will happen. Cl can combine to form Cl2. Cl2. CH3 can combine together to give ethane. and CH3Cl can combine together to give CH3Cl. But from here, they don't ask you the questions from the mechanism. They can ask you questions from reactivity and selectivity, right? So here what you need to understand that F2Cl2 Br2 and I2, F2 though reactions you will not even see. Why? Because F2 is such explosive that it does not react only. It is very explosive, so it is not preferred. I2 is a very slow reaction, that is the reason. But if I talk about alkenes, 3 degree, 2 degree and 1 degree alkane has, the priority goes like this. Why? Because free radical, which free radical is more stable? 3 degree is more stable, then 2 degree, then 1 degree. That is why this is the priority of alkanes here. Then selectivity, if I talk about, out of this, chlorine is highly reactive. So it is not selective. This is highly reactive. This is the reactivity. Have you seen some people? They will just react. They will not even think. They will just react. Some people, they will think so much. They will very selectively, they will speak. Right? So now you have this kind of situation. The situation is that Cl2 is very highly reactive, Br2 is very selective. You can see it from the table as well. That this is 3 degree, this is 2 degree, this is 1 degree. For 3 degree, Cl2 is like, Br2 is so much crazy about this 3 degree. It is 600 times more than 1 degree. This is 82 times more than 1 degree. So in case of Br2, always this will be the answer. 3 degree, hydrogen will be replaced by halogen. 2 degree will be less, 1 degree will be even less. 3 degree hydrogen will be replaced by the, because 3 degree free radical is so stable, bromine is very selective, right? Okay. What about chlorine? Chlorine is not at all selective. Chlorine is very reactive, and that is the reason maybe 2 degree, maybe 3 degree, maybe 1 degree, we don't know, right? So we'll see that. So here what will happen, I'll say that if I talk about this thing here, CH3, CH2, how many 1 degree hydrogen I have? This carbon, first I'll talk about this carbon is connected to 2 carbon, it is 2 degree. This is connected to 1, it is 1 degree. This is connected to 1, it is 1 degree. So how many 2 degree you have? 2 degrees, 2 hydrogen are 2 degree, 3 hydrogen. How many 3 degree? No 3 degrees there. How many 1 degree? How many 1 degree hydrogens are there? 3 plus 3, 6. Firstly, you will see the carbon. 1 degree, 2 degree, 3 degree. Then the hydrogen connected to 1 degree carbon are 1 degree hydrogen. The hydrogen connected to 2 degree carbon are 2 degree hydrogen. Okay. Now 2 degree will be multiplied by 3.8 and 1 degree will be multiplied. This is the factor that you need to multiply. If there is some 3 degree, you will multiply it with 5. Let's say there are 3 degree, you will multiply it with 5. Okay. Here. So it will be 6 and this will be some 7.6, I think, right? So here what you will see, definitely this is more. So 2 degree is selected over 1 degree, right? So answer will be CH3, CHCl and CH3. Now don't say, ma'am, but here it is 2 degree only. You were saying different answer will be there. It can be different, it cannot be different. That depends upon how many hydrogens you have. Okay, tell me, is that clear? Everybody, is that clear or not? Is that clear? Okay, now let's see the physical properties here. If you talk about the physical properties, what we have in physical properties of alkene. Melting point and boiling point, if I talk about, melting point is directly proportional to packing efficiency. Packing efficiency of even is more as compared to odd. That is why melting point of even carbons are more as compared to odd. Okay, that is important. Then boiling point is directly proportional to molecular weight, and if same molecular weight, then it is inversely proportional to the branching. Okay, done. Mostly in all the cases you will see boiling point like this only. Solubility, if I say, alkanes being non-polar molecules are soluble in non-polar solvent, right? They are soluble in non-polar solvents like benzene, ether and chloroform. They are insoluble in polar solvents like water. Their solubility decreases with increase in their molecular weight, because more steric repulsions will be there. That is why solubility is decreasing here, right? Then we have alkenes. Okay, then we have alkenes, right? Everybody tell me, alkenes we have done. Now let's do alkenes. Alkenes, let's see what you have here. First is there is Lindlar's catalyst and Birch reduction. From alkyne to alkene, how you will make? If you want to make cis alkene, then use alkyne, add PD and H2, catalytic hydrogenation in the presence of this Lindlar's catalyst. That is this thing. Okay, this is Lindlar's catalyst that will stop the reduction to alkene. It will not further go to alkane part. So it is PbSO4, quinoline, sulfur or CaCO3. Birch reduction is, you have alkyne, you add H2, and this is Birch reduction reagent, which is sodium or lithium in presence of liquid ammonia, and here you have the presence of transalkene. Okay, so this is important when you can make cis alkene, where you can make transalkene, right? Okay. Then guys, you have, next question is, for the formation of alkene only, you have dehydrohalogenation and you have dehydration reaction. Okay, so if I talk about dehydrohalogenation, let's see what you will have. See, in case of dehydrohalogenation, you use alcoholic OH or alcoholic NaOH. Okay, these are the things that you use for dehydrohalogenation. Here hydrogen will be eliminated, X negative, right? And hydrogen will be eliminated, it will move it here. And always in both the cases, it is according to the major product will be according to Sedzeff rule. Major product will be according to Sedzeff rule. That means more alkyl substituted, alkene is the major product, or you can say more alpha hydrogen, more stable alkene. Okay, so halogen will go, and on the beta hydrogen will go, alkene will be given. Now what if you have beta on both the positions, right? I'll give you this example here. If you have, let's say, halogen here, or this also can be OH, they will give the same thing, right? Here it is called as dehydrohalogenation because hydrogen and halogen both are eliminated. In this case, OH and H is being eliminated. That is why it is called as you can say dehydration. So here OH will be eliminated. This is alpha, this is beta, this is beta. Now tell me which beta will be selected. Beta dash or beta? Which will be selected? The one which gives you more substituted alkene. So this is more substituted alkene. This will be major. Okay, unless there is also this exception. Okay, exception is in this case. Here in these two cases, the answer will be same. But let's say there is some other elimination reaction. This is a point that they can ask you. If you have fluorine as the leaving group, let's say halogen is fluorine. In that case, I'll just write it here. Okay, this is the exception. if fluorine is leaving group, right, or base is sterically hindered, very big base you have, then you have Hoffman product, that you have less substituted alkene is the major product, that is Hoffman. Okay, tell me, is that clear? Simple. Very rare chances that they will ask you this much, right? I don't think so, but still I have given you, you should know that there is some exception also here, right? Okay. Ha ma'am, 8:30 dinner break ma'am will go. Yes, I'll give you dinner break, right? Tell me beta, these two reactions are very important. Tell me if these are clear. These are very important. Dehydration, concentrated H2SO4 or H3PO4 or PCl5, P2O5, all these are the reagents of dehydration. Okay? Done? Acha. Then vicinal dihalides. How vicinal dihalides will give you alkene? See, vicinal dihalides you will have to take X negative from here, then H positive from here, and this will move here, right? Okay, wait a minute. I have done zinc now. Two halogens, so see, X negative here and this X here, this will shift here. D halogenation, this is D halogenation. For dehalogenation reaction, you use zinc dust. It's not a very famous reaction, but you must know what we do here, right? Even if you have geminal, you will do the same thing. Geminal or vicinal, whatsoever you have, apply zinc dust, add zinc dust, and same thing will happen, right? Okay. Then next is Wittig reaction. Now Wittig reaction, dekho, for JEE means, so as such this is not important, right? But you can just go through this once, but it's not important. So I'll just mark a cross here. If you want to skip, you can skip. Okay, so it's totally your choice. Not like very important or this has been asked, nothing like that. Okay, so if you have a ketone, as you have phosphorus halide, what you do here is this RR here, it is converted to double bond. This double bond stays as it is. This CH2 will go here, and this double bond O will move here. That's it. That will be your answer. Okay, that is a Wittig reaction. Again, this is a very different reaction mechanism. Even if you see this reaction, that is more than enough. Mechanism, so you forget it only, right? Now you have reactions of alkenes. In reaction of alkenes, what will happen? Let's see. Okay. Firstly, you have Bayer's reagent. Then you have Becker's process. Okay, firstly, let's talk about Bayer's reagent. Right, there is one more thing that I want to teach you in Bayer's reagent. That is not here. So I'll teach you that again. See, in Bayer's reagent, even if you have cold dilute KMNO4, these are the reactions of alkene. If you have Bayer's reagent, that is cold dilute KMNO4, that is of pink color. Here it will give you this will give you anti-addition product. Okay. Actually, in this page you can delete. I'll do this after some time as well. I'll do this in alcohol. Wacker's process you can remember. So I'll teach you again. Okay, I'll teach you this again. Okay, as of now, just remember one thing. Bayer's reagent is the test of unsaturation where you add pink KMNO4. If it decolorizes, then it will give you vicinal diols. Right? Vicinal diols are given here. Wacker's process is what? Wacker's process is you have alkene, you add H2, you add PdCl2 and CuCl2. This is converted to CH3CHO directly. CH3CHO is formed. That is also Wacker's process. This also you can skip, but this is very important, right? Wacker's and this Wittig reaction, it's your choice. You can skip as well, but the other things that I am doing, that you cannot skip. Which you can skip, I am showing you that, right? Then addition of H2. Now this is very important. One thing I want to teach you here before moving ahead. Acha, see, addition of H2. It's a syn addition. Remember that addition of H2 is syn addition, right? Remember that. What will happen? You will have a double bond. Break the pi bond, add H2, H2. Break the pi bond, add H2, H2. That is syn addition. Okay? Even in alkyne, you do the same. That is the syn addition. Right? Addition of X2, if you see, that is anti-addition. That is anti-addition. Okay? But remember one thing. If you have, why syn and anti is so important? Why, ma'am, syn and anti is so important? So what I'll do now, I'll just erase these examples, because examples, how much you will do, right? And I'll just directly show you that what point, a very, very important point for you, right? Some good level questions if they ask you. Dekho. A table, you must know, a table, simple table for these kind of question is, if you have cis or trans, and what will be formed here? See, if you have cis, alkene is what kind of alkene? And trans. See, always remember cis, you can say positive, trans, you can say negative. Cis will be if you have anti-addition or you have anti-addition. Wait a minute. Cis will, firstly, if cis has syn addition, if cis has anti-addition. If trans has syn addition, trans has anti-addition. Syn will always be positive, anti will be negative. This is positive, this is negative. Now see, tell me one thing. Positive multiplied by positive will give you positive. Beta, please see this. Hana, I'll give you break within 2-3 minutes. Please, Hana, please. Even my mother is waiting outside. I know that we have to eat dinner. Please wait. Positive, negative, this will give you negative. Negative will give you negative. Negative will give you positive. Now remember, negative means stereo and positive means erythro. Positive means erythro. Negative means stereo, positive means erythro. Now the next question is, ma'am, what is stereo, what is erythro? Okay, I'll give you just this example. For example, I have this compound here. For example, I'll just tell you what is erythro, what is stereo. Just see this. See, what if you have this kind of compound that is cis? Okay, this is a cis compound. You are adding, let's say, deuterium here, because I want to see whether it's stereo or erythro, what is formed. Cis means positive. Cis means positive, and this is a syn addition. When you have cis and you have syn addition, answer will be erythro. Erythro means what? Erythro is that compound where you have same kind of compounds on the same side. Okay, DD on the same side, HH on the same side. Other things will remain the same. Okay, but if you had trans here, let's say you had trans means you had this thing. Tell me trans, you add same D2 here, you know what would be the answer? You have trans. Okay, this is syn addition. Addition of H2 or D2 is syn addition. Negative, this will give you stereo. Stereo, you know what is stereo? Wait a minute, I did the opposite. Erythro is same. Erythro is same side. Okay. Stereo is opposite side. So D and D here, and this is H and H here. Okay. This is some good level question. Okay, tell me. Clear? Just 2 more questions now. After this slide, I'll give you break. Okay, this is the last slide that I'm going to cover. After this, I'm going to give you break. So X2 and H mu is what? Anti. Anti means what? Substitution reaction free radical mechanism, right? First thing you need to remember, this is a free radical mechanism. Okay, this is a free radical mechanism. Wait a minute. This is not anti. My mistake. H mu is the different. Okay, firstly let's talk about this. X2 in CCl4. Suppose you have alkene. Okay, this is alkene. Alkene. You have cis alkene. Here I will draw trans alkene as well. Okay. Transalkene as well. Now, if I draw this here, tell me one thing. Is it anti or syn? Whenever you have CCl4, this is actually breaking the pi bond. This is anti-addition. This is addition reaction. This is addition reaction. If you have here H mu, this is substitution reaction. Okay. In addition reaction, what you have? This is cis, anti is minus, this is positive. Answer will be therio. Answer will be therio, means X and X are on the opposite side. This is CH3, this is CH3, this is H, this is H. Anti means negative, trans also means negative. Negative, negative will give you positive. That means therio will be the answer. Therio means X will be on the same side. Tell me. Is that clear? When X will be on the same side, different side. Just remember that chart, okay? Now see, X2 in CCl4 is addition. It will break the pi bond. It will make alkene. But X2 in H mu is substitution reaction. It will be free radical mechanism, and that is why allylic or benzylic systems. If you have C double bond C, halogen here. Okay, I'll just show you this. C double bond C, you have CH3, this is CH2, this is H. Here you add X2 in presence of H mu. This is not addition. It will see the allylic carbon. It will substitute allylic or benzylic hydrogen. That will be substituted. So it will give you CH2. It will remain same. This is C, CH2X. Right? Or you have benzylic, CH3. You give X2 H mu, it will do allylic substitution like this, CH2X. Okay, tell me. That's it. Done? Now I'll give you your dinner break, right? Now let's do dinner break, okay? So we have completed till now 200 slides we have completed, 140 more slides to go, right? But we'll do that, okay? So you can see I am not doing it the previous way we have completed the chapters. I am making sure that if there are two same kind of compounds that you have, kind of reagents, like there was no use of doing this here, but still this is in haloalkanes, still I did it here. Why? Because I know these are the two things where students get confused, right? Okay, chalo, we'll do that today itself. I think it will take us 1 or 2 a.m. it will take us. Arey, no worries, now we'll sleep tomorrow, right? We'll sleep tomorrow. I'll wake up at around 11 noon. I'll wake up easily. Okay, you also do the same thing, right? Okay, chalo. Now let's take break of 20 minutes. 25 minutes you can take break. Tell me what good break I'll give you now, right? Because after this I want full energy like before. Done, students? Everyone here, how much break do you need? Tell me. 30 minutes तो बेटा नहीं. No 30 minutes. 30 minutes, no. It will be too much. Okay, I think 20 minutes is good enough break. So I'll see you all at 8:50. Okay. How much break you need? Tell me. 30 minutes, 20 minutes. So sweet. There are some students who are like, ma'am, I think 25 minutes is good. Okay? Because if I give 30 minutes now, it will automatically be 39, 8. If I say now, I'll see you all at 8:40, 8:50 or like 50, 55 something I'll see you all at. Right? Okay? So, The time starts now. I'll see you all at 8:50 or 55. Okay, I'll give you on the Telegram channel. I'll inform that I'm back. Okay, so it's break time. I'm giving you the break. Yes. So see you all after the break. Hello, yes everyone, I am back. Do let me know if I am clearly audible and visible to all of you or not. Tell me everybody in the chat box if I am clearly visible and audible, and let me just inform the students. Break is over. So I have informed the students. Yes. Tell me everyone. Yes, you are audible and visible. Done. Great. So let's start. Till here, though, everything is clear, right? Till here, everything is clear, right? What we have done. No problem. Shall we move ahead? So next is addition of HX. So in addition of HX, you have Markovnikov and anti-Markovnikov rule, right? So if I talk about Markovnikov rule, that means negative part will be attached to less number of hydrogen, right? If I say here negative part will be attached to more number of hydrogen, right? Okay, but in this case Markovnikov anti-Markovnikov addition, negative part is attached to less number, and Markovnikov you simply add HBr or HCl or HI, right? But in this case you have HBr and peroxide, that will show anti-Markovnikov addition, right? In this case HBr and peroxide. One more thing, if you have HCl and peroxide, if you have, they show anti-Markovnikov. If you have HCl or HBr or HI and peroxide, they will still show Markovnikov. I'll just write it here. If you have HCl or HI and peroxide, they will still show Markovnikov. So if you have HCl, peroxide, it will show Markovnikov. If you have HBr, peroxide, it will show anti-Markovnikov. So Markovnikov is shown by when you don't have peroxide, right? Anti-Markovnikov is shown when you have HBr with peroxide. HCl with peroxide or without will show the same Markovnikov. HI with or without peroxide will show Markovnikov only, right? So that is the thing. Now if I see this here, now if I see this here, beta I am responding only, right? Okay. Thank you, thank you. Okay, great. So now if I see this here, let's understand this with HBr, right? Let's say you have HBr peroxide. This is peroxide, right? If you have HBr simple, in that case you will see CH3, this is CH, right? This is CH2, less number of hydrogen, negative part to less number of hydrogen, that is here, right? That will be the answer. And anti-Markovnikov will be here, that is negative part to more number of hydrogens, right? So it will be this. So you can see the product is entirely different, and that is anti-Markovnikov and Markovnikov, right? Okay. Now acid catalyzed hydration. In this case also we apply Markovnikov addition, but this is rearrangement of carbocation, right? Okay, for example, you have, let's say you have a compound which is let's say this is CH3, C double bond C, this is C, this is phenyl, this is CH3, and this is CH, this is CH, this is CH. Now in this case, if I talk about that, you have acid catalyzed hydration. That means you add H positive and then you add H2O, right? In this case, what is happening? You are breaking the double bond, but here Markovnikov addition is taking place by arrangement of carbocation. Firstly, carbocation is formed here. Let's say this is CH3, this is CH, this is CH. Which carbocation will be more stable? If I talk about this thing here, this carbocation or this carbocation, see both of them as such there is no difference, but if I make this carbocation, rearrangement will make this kind of situation that will show resonance. So that is why what I'll do, I'll make this carbocation here, right? So carbocation that I'll form is this one. So I'll make a carbocation here and you will add H2 here, H here, right? After that there will be rearrangement. That means what I can do is I can shift this hydride here. This can give me CH3, CH2, CH2, this is C and this is phenyl and this is CH3. If you see this here, this was 2 degree carbocation. This is 3 degree plus resonance stabilized carbocation. So definitely this particular carbocation is more stable here. When I say this carbocation is more stable, in that case I can easily say CH3, CH2, CH2. I'll write it as CH3. Wait a minute. This is CH3. Now I will add OH here. CH2, CH2, and this is CPH. This is OH, and this is CH3. Okay? Tell me, is that clear how we did it? Is that clear how we did it? How we did it? Right, everybody? Tell me. We will definitely do PYQs, don't worry. Right? Firstly, let me just complete this thing. Ozonolysis are of two types. One is reductive ozonolysis, then there is oxidative ozonolysis. In reductive ozonolysis, what you do, break the double bond and attach double bond O on both sides, on both carbons of double bond, right? In this case, whatever you have here, replace further, what you will do, replace hydrogen attached to carbonyl carbon with OH. Now let's see how we are going to do this, right? Now let's see how we are going to do this. Let's see, you have a compound where you want to do the oxidative ozonolysis here. Let's see. Oxidative and reductive, I'll teach you both, right? If you want to do the ozonolysis, what you will do, right? You have double bond. Ozonolysis of double bond is very, very famous and it's a very frequently asked question, right? So many times this question has been asked. So if you see this over here, you have carbon, let's say double bond. Let's say this is CH3, this is CH3. Let's say this is CH3 and this is H. Okay. This is the alkene. So what you will have here? What you will do here? Firstly, what you will do here, everybody? See, you will break the double bond for reductive ozonolysis, right? You will break the double bond and attach double bond O here. So break the double bond, this becomes C, this is CH3 and this is H here. This becomes C, this is CH3 and this is CH3, right? Now you need to attach double bond O. So this is double bond O, this is double bond O, right? That is the answer for reductive ozonolysis, right? This is what you have to do. Now for oxidative ozonolysis, further what you will do? To the carbonyl carbon, there is only one hydrogen that is attached. So you will convert that hydrogen into OH. Everything else will remain same. Okay, you will convert that hydrogen into OH and everything else will remain same. Tell me, is that clear or not? That works for all of you or not? Break the double bond or double bond. I'll give you one more example here. For example, you have this thing. Let's say this is hydrogen and this is H. Okay, let's say this is the alkene that you have. This is hydrogen and this is H. Again the same thing, break the double bond. This is H, this is H, this is double bond O, plus this is C double bond O, this is CH3 and this is H. Now for oxidative ozonolysis further, what you will do, this H is converted to OH. Okay, this will be OH, this will be C double bond O, this will be CH3 and this is OH. So this is nothing but carboxylic acid. This is called as H2CO3. That will further break down into H2O and CO2. And here you have CH3COOH. So that is the answer here. Tell me, is that clear? Reductive ozonolysis and oxidative ozonolysis? Yes, definitely it covers. Okay, now that is done. That is done, everybody. Acha, one more thing you have here. If you have KMNO4, let's say you have a double bond and they give you KMNO4, right? That is oxidizing agent. If you have alkene, you have KMNO4. Then also the same, you have dilute KMNO4, dilute alkaline KMNO4. Okay, this will be the answer. If you have same thing, oxidative ozonolysis is nothing. If you have KMNO4, you let's say concentrated, or you add acid here, or you have K2Cr2O7, then this answer will be there. Okay, because these two things are interrelated, that's why I have given it here, right? Tell me. Right? Yes, everybody. Tell me, is that clear? So now next thing is, what we have here is given below are two statements. One is labeled as assertion, other is labeled as reasoning. So the question says that this can be subjected to Wolff-Kishner reduction to give this. Okay, so it can give you this. Okay, Wolff-Kishner reduction is used to convert double bond O to CH2. This is so true, but this is false. You know why? Because Wolff-Kishner reduction means basic conditions. And you know what will happen whenever you have this Cl? This is very base sensitive group. And that is the reason here this will not be formed. Rather, what will happen in case of Wolff-Kishner reduction? This will be converted, this will be eliminated, and here it will give you ene, and this nothing will happen to this double bond O, because this is base sensitive. This is base sensitive, and that is the reason this reaction Wolff-Kishner would not occur only. Because base sensitive, if you have any base sensitive group, the base will take this and it will form alkene here, right? Okay, base, what base does? Base does dehydrohalogenation. So instead of this Wolff-Kishner reduction, dehydrohalogenation will take place. Dehydrohalogenation takes place. Got it? That is your PYQ that has been asked in JEE 2023, right? So answer is assertion is false and reason is true. This is true that it is used to convert this, but that will not happen here, right? Okay, now other questions, wait a minute, other things that you have for this particular reaction are that we will do in the end, right? Okay, wait a minute. Wait a minute. Okay, I think by mistake I missed it, right? So don't worry, I'll just do that. Firstly, let's focus on other things, right? By the time we are completing this, I'll do it in the end. Alkynes and aromatic part, I think by mistake I missed it, right? Chalo. Now let's see haloalkanes and haloarenes. Now, if I talk about haloalkanes and haloarenes, let's understand that in case of haloalkanes and haloarenes, what you have here is you have SN1 and SN2. That is a hot topic of of haloalkanes and haloarenes. So what you do here, carbocation is the first thing is SN1 is two-step reaction, right? And this is one-step reaction. This is one-step reaction. Here you have the formation of carbocation as an intermediate. As you can see this over here. Here what will happen? Firstly, leaving group will go and you have the formation of carbocation where attack can happen from both the places. That is why retention product is formed. Retention, you can say, that is why racemic mixture is formed. Racemic mixture is what? Which has retention as well as inversion product both, right? And here attack can occur from both the sides, that is nucleophilic attack. So we can say rate of reaction in both the cases, if you can see, as it depends upon the breakage of this C and X bond. So more easy it is to break this bond, more easy will be the nucleophilic addition, nucleophilic substitution, and that is the reason here this bond will break easily, as you can see, right? Okay, so that is the reason here you have Ri, Rbr, Rcl, Rf, both of them has C. Then here rate depends only on the first, as you can see in RDS, you only have the substrate, you don't have any nucleophile here. So it depends only on the substrate, right? It depends upon the stability of carbocation, as carbocation is formed in the rate determining step. Then order is 1, molecularity is 2 here. This is very important that here polar protic solvents are used. Polar protic solvents like you have water, right? Then you have ethanol. These are polar and they give proton, right? Polar aprotic solvents are like DMSO, acetone, right? DMF, all these are polar aprotic solvents, right? So in this case, you have weak nucleophile. You know, weak nucleophile will wait for the carbocation to get formed, and only after that it will give you the product. Firstly, the carbocation will be formed. Okay, yes. Thank you, Sanjana. So only then the carbocation, it will wait for the carbocation to form, right? Then racemization, retention and inversion both will happen. Definitely inversion will be slightly more as compared to, like if retention, you can say if retention is 49%, this will be 51%, like slightly more, right? In reality it is slightly more. So if you talk about SN2, this is a one-step reaction. One-step reaction means here directly the product is formed and you have a 5-membered transition state here. And after that only you have the formation of the product. But the amazing part is that here inversion will take place. Here inversion, and that is also called as Walden inversion. Okay, so in this case Walden inversion, if you see this here, the product will flip here, where this will go on the opposite side, you will have the addition of the nucleophile, right? And if you see, this does not depend upon the carbocation, it is not formed only, this depends on the steric hindrance. More is the steric crowding, more bigger groups are there, it will be difficult for the nucleophile to attack, right? So steric hindrance is less, and that is the reason here it is, because of carbocation, this is 3 degree, 2 degree and 1 degree is least. 1 degree will never prefer this SN1, but in this case it is 1 degree will prefer, then 2 degree, then you have 3 degree, right? Wherever carbocation is becoming stable, this will prefer. Wherever you have weak nucleophile, this it will prefer. Strong nucleophile. Now, ma'am, what is weak nucleophile? What is strong nucleophile? See, weak nucleophile is like you have water, that is a weak nucleophile. You have, let's say, weak nucleophile, matlab neutral, I'll just write here neutral nucleophiles. Like you have NH3, ammonia, that is a weak nucleophile. Why? Because this is neutral. So I can just write here neutral nucleophiles. And here you have charged nucleophiles, right? Negatively charged. Negatively charged nucleophiles like OH negative, OR negative, these are strong nucleophiles, right? Then if I talk about the inversion, Walden inversion will take place here, right? Okay, tell me, is that clear? Is that clear? Now let's talk about some more reactions, right? Done. Let's see. Preparation of haloalkenes. So in this case of haloalkenes, what you will have SOCl2, that is the retention, and SOCl2, wait, I'll just tell you one thing here that you should know, not full mechanism. I'll just give you one very, very important thing. Thank you so much, the moon. Thank you. So if you talk about SOCl2, right, and in this case, when only SOCl2 is there, what will happen? Only SOCl2 pyridine intra. This will give SNI mechanism. Intramolecular. This only they can ask you, nucleophilic addition, substitution, right? And this will give you SN2. That is why inversion is there. There you will have retention because intramolecular substitution is happening, right? Okay, just remember this, that it will be SN2 and this will be SNI, right? Then this process is called as Darson process, where you have ROH, alcohol, you add SOCl2 and pyridine, and it gives you RCl. That's how haloalkanes are formed, right? This I told you, where there will be retention, where there will be inversion. Similar kind of processes Reed's reaction, where you have alkane. Now in case of alkane, you have here thionyl chloride. This is sulfuryl chloride. Sulfuryl chloride. This is the same kind of question. Product is different here. Product is same, reactant are different. This is thionyl chloride. This is thionyl chloride. Okay. So this is SOCl2, and here they have given you SO2Cl2. And you have the formation of RCl, SO2 and HCl are eliminated here. Right? Okay? Yes. Tell me. Molecularity of SN1 is also written here. See, it is order is 2, molecularity is 2. Right? Okay. Next is you have diazotization reaction. And wait a minute. So many reactions now we have here. Wait a minute. Preparation of alkyl halide now. I have so many reactions are there in this flow chart. So I'll just give you that. Before doing a diazotization, let's see. There are some reactions that will be in the flow chart. Okay? Yes. Moon, then you need to charge your phone, right? Okay. So preparation of alkyl halides, if you see, in the preparation of alkyl halides, what you will have, right? This is HCl, POCl3, CHCH2. So what will happen in this case? A very simple thing. First thing is you have alcohol. Whenever you have PCl5 or like and let's say you have PCl3, okay? So let's say you have PCl3, or you have PBr3, or you have PI3. In this case, you have the formation of OH is replaced by the corresponding halogen, and you will have the byproduct as H3PO2. Okay, that will be the byproduct here, right? Okay. Wait a minute. Mm. Then this will be 3. Wait a minute. PCl3, this will be 3, this will be 3. Right? In case of PCl3, you will have the formation of H3PO3. When you have PCl5, wait a minute, let me just verify this. You have PCl3. Okay? PCl, Cl, Cl. This is ROH, OH, OH. This R and Cl will go H3PO3. Yes. So in case of PX3, you have the formation of byproduct, that is H3PO3. In case of PX5, you have the formation of byproduct, that is POCl3. Right? That is formed here. This is how you will do it. And just replace OH with the halogen. This we have done, that SOCl2, when alone SOCl2 is there, this is SNI reaction, right? And this is Darson process only. When you have SOCl2 along with pyridine, this is SN2 mechanism, right? Then next what you have here, if you have Lucas reagent, now what is Lucas reagent? See, in Lucas reagent also you have alcohol, and this is also used to distinguish 1 degree, 2 degree, 3 degree alcohol. So what exactly you do? You have Lucas reagent, you have HCl, and you add anhydrous ZnCl2. What will happen? OH will be replaced by Cl here, but which will give more readily the Lucas test. So remember that 3 degree, then 2 degree, then you have 1 degree. Okay, then 1 degree. 3 degree will give you turbidity immediately, just after it, instantly. 2 degree will after 5 minutes, and 1 degree after 30 minutes, and that to prolonged heating, right? Then there is this reaction that has HBr and NaBr, right? You add H2SO4 here. What will happen? Again, directly OH will be replaced by Br, right? Then if you have Hi and KiH3PO3, this will give you, this OH will be replaced by I here, right? Okay, understood? These are the preparation of alkyl halides from alcohols, right? Done, everybody? Tell me if there is any problem. Tell me if there is any problem. Let me see. Preparation of alkyl halides. This is from alkene. Let's understand that. Right? This is from alkene. Let's understand that. Right? Okay. Tell me, everybody. Tell me. Understood? Yes. But our next live will be on Monday, right, for physical chemistry. Right? Done? Preparation of alkyl halides. Let's understand this. From alkenes, how you will do it. Okay. Firstly is HBr. I have already showed you this. HBr with peroxide. This follows anti-Markovnikov rule. We have learned it, right? Then this, when you have Br2 at a very high temperature, this will give you substitution. Do you remember? See, X2 in H mu. Substitution reaction, this is substitution reaction, and in that substitution I'll write there as well, that if you have any kind of, let's say, wait a minute, in this case either so you can have X2H mu, or you can also have NBS here. It will also give N-bromosuccinimide, will also give the same answer. Okay. Acha. Let's see more here. Right? NBS, again, it will replace the allylic carbon with bromine. Here, allylic carbon is this carbon with bromine, right? Then if you have HBr in presence of CCl4, this will follow Markovnikov addition. This will follow Markovnikov, simple. If there is peroxide, it is anti. If it is HCl, whether it's peroxide added or not, it will always follow Markovnikov addition. This will also follow Markovnikov addition. Br2 in CCl4, this will break the double bond here and you will attach Br, and this will give you vicinal, right? Okay, understood? Then next you have, if you have any alkene, you add Cl to H mu. We know that hydrogen will be replaced by Cl, right? Then after that, once you have chloro or bromo alkane, you add NaI and acetone, right? That is called as Finkelstein reaction, where Cl will be replaced by iodine here, right? Then you have CH3 C double bond OAG. This is called as Hunsdiecker reaction. In Hunsdiecker reaction, what you have? This CH3 C double bond OAG, when you add Cl to H mu or Br to H mu, whatsoever you are adding, I am just adding Br to H mu. What will happen? You will have the formation of CH3Br, that is the alkyl halide, along with the elimination of CO2 and AgBr as the precipitate, that is Hunsdiecker reaction. Swartz reaction is same as Finkelstein. You have chloro or bromo alkane here. You add inorganic fluorides and chlorine will be replaced by fluorine here. That is it. Okay? Yes, everybody? Tell me. Clear? Done, everyone? Now, next will be diazotization reaction, right? Diazotization reaction. In case of diazotization reaction, this NH2 will give you N2Cl, right? That is diazotization reaction, right? When you have NaNO2 HCl 0 to 5 degrees Celsius, it will give you N2Cl. And you know, when you slightly warm it, we will see so many reactions of this one. When you slightly warm it, it gives you phenol, right? So that's how amines and phenols all are connected to each other. Ball-Schiemann reaction is this N2Cl, diazonium chloride. When you add HBF4, it gives you fluorobenzene, that is Ball-Schiemann reaction. But if you add here NaNO2 along with copper couple and you heat it, then it is going to give you nitrobenzene. Okay, then the reaction, this part is not under Ball-Schiemann, only till here it is Ball-Schiemann reaction, right? Okay, yes, that is only the method of fluorobenzene. Swartz is only fluoro and this is only idobenzene, right? Okay, then you have next one, that is Sandmeyer's reaction and Gettermann's reaction. So what is Sandmeyer's and what is Gettermann reaction? Sandmeyer reaction is when diazonium chloride, you add a salt, right? You add a salt here, right? Salt, copper salt with Cl2, then you will have wait a minute. If you have copper salt here, then you will have chlorobenzene, right? If you have bromine salt, you will have bromobenzene. If you have CuCN, then you will have cyanobenzene. Though this is not called Sandmeyer's reaction, but this is the same category, so that's why I have put it here. Now, if you have copper with HCl, then it will form, this is Gettermann, and here you will use copper powder, right? If you use copper powder with HBr, it will give you bromobenzene, right? Okay, tell me. These are some of the very, then Hunsdiecker reaction, I have just told you there, RCOAG with Br2 CCl4, it will give you CO2 will be eliminated, AgBr will be eliminated, RBr will be eliminated, right? And that's how you have the formation of alkyl bromide. Okay, then there are some more important reactions of haloalkanes that you have here, right? Let's talk about those reactions, right? Okay, everybody, tell me in the chat box if that is clear. Now, if you see this here, reaction of haloalkenes, in this case, let's see, firstly, are we left with any preparation? Yes. Let's do 3-4 more preparations here. Okay. Huh. Mostly, though, it we have done only. Wait a minute. This I will just put it here. Swords. I'll put it here. Okay. So now if you see Swartz is there, Swartz so we have done. RX with inorganic fluorides will give you this, right? And Finkelstein also we have done. But let's talk about Ullmann's reaction, right? Okay. And here also remember that here Ri with NaCl, dry acetone, if you use Ri here, instead of chloro or bromo, if you use ido here, the reason that we use dry acetone here, right, and the reason that here sodium is used, because once Ri is formed, that gives no reaction with dry acetone, and that is the reason we use it, right? Okay. Now, Ullmann's reaction is, you have, it is same like fatigue reaction. Instead of sodium, you have copper. Instead of chlorine or bromine, you have iodine. So this will be eliminated and you will have the formation of biphenyl here, right? Okay. And that was under the reaction part, but I've just covered it here. Now let's see the next part, that is preparation of alkyl halide. Yes, everybody? Because some, it's not like some reactions are part of 3-4 chapters, okay, 2-3 chapters. So you will see that some reaction is going here and there, because I have tried to pick reactions. See, no matter how, because when you do study individual chapter, there are so many reactions that are repeated, right? So now I am not repeating those reactions. Okay, I will not be doing that. Now if you see this here, disonium chloride, if you see, right, from here how chloro this is formed. Sandmeyer reaction I taught you, Gattermann reaction I taught you. Then we have Ki and you vomit, you have idobenzene. That if I talk about fluorobenzene, you have N2BF4, benzene disonium, this is formed. And from here, Ball-Schiemann reaction, you have fluorobenzene that is formed. Right? Okay? Done? Acha, then other reactions of other way of forming these chloro, bromo, this halobenzene is that you have Cl2, FeCl3, this will give you C positive electrophile. This will give you Br positive electrophile, right? And that is the reason you have the formation of chloro or bromobenzene. In case of I2, you are using a very good oxidizing agent so that this reaction is not reversed. You can also use here HNO3 so that this reaction is going forward and it will give you idobenzene. But the best method of preparing idobenzene is this method. Okay? Yes. Done? Now let's see. This reaction is also very important. Reactions of haloalkanes. Where in this part, so what exactly you have here? This reaction, I'll tell you why this is so important. So for example, you have RX. It is reacted with AgNO3, NO2. Because it's a covalent compound, what will happen? You have the formation of R with oxygen to it is already bonding, making a bond here, ONO, right? So what, that's the reason that it will have RNO2. If RX is reacted with KNO2, then it will make the compound that is RONO. Now because oxygen and nitrogen both are free, now oxygen is also free, because with K it is K positive, NO2 negative, so it can make a bond with ONO as well. Yes. Okay? Huh. So I have just done it there only. Here you will have RONO. Okay, that will be formed here because it's an ionic compound, right? Then you have, wait a minute, on the similar lines, you have AgCl as well, Ag as well. So for example, Rx is reacted with KCN. And if Rx is reacted with AgCN, so here carbon is not free. So bond will be with this nitrogen, right? So it will be RNC that will be formed here. Here this is free, right? So that is the reason negative positive. Here it will form RCN. Okay, this is a very, very important question that they ask you. ONO2 I have written kya? ONO yaar, ONO2 nahi, ONO. Right? Okay? Yes. Tell me. Everyone, do let me know. Is that clear? Is that clear? Is there any problem in that? Till here, if everything is clear, do let me know, so that we can start with reactions of alkyl halides. Right? Now, let's start with reactions of alkyl halides. So, let's talk about more reactions. Acha, first is dehydrohalogenation. This we have done. This part so we have done dehydrohalogenation. That it will, we did it in formation of alkenes. In the preparation of alkenes, we did it. Right? Then reduction of alkyl halides. If I talk about alkyl halides, what you have here, alkyl halide, whenever ZnHCl is used, it is automatically reduced to RH. So that is formed here. Right? Okay. Then you have Wood's reaction, all these reactions. Let's talk about that. So Wood's reaction, Wood's fatigue and fatigue reaction, that is a repetition only. We did it in the alkanes part. You will see a lot of reactions will be repeated. Friedel-Crafts is a new one for you here. So benzene, when it is reacted with CH3Cl, right, what will happen? This CH3 will be generated and it will attack, electrophilic attack it will do, and it will form toluene. Similarly with Mg metal, what will happen? CH3 with any haloalkane with Mg will form Grignard reagent. And I told you Grignard reagent with proton source directly forms alkane. Right? Okay? Done? Yes. Next is reaction of aryl halides. We have in more reactions of alkyl halides. Let's talk about them. Dow's process we are going to do in detail as well, right? See. Dekho. Chlorobenzene, first thing is the reactions of chlorobenzene are very difficult. Okay, why the reactions are so difficult here? Because if you talk about chlorobenzene, right, if you talk about it because of its resonance, what it has, because of the resonance, if you see this over here, this forms a partial double bond here, right? And that is why this phenyl cation is not at all stable. This bond is very difficult. Moreover, firstly, partial double bond is difficult to break. Then even if you break it, you will have phenyl cation. Moreover, the repulsion of nucleophile and the lone pair is very high. Then this is sp2, and sp2 is very electronegative, so it will not give off its electrons, right? So nucleophilic substitution reactions are very difficult. But one reaction, two types of reaction it can give us. That is Dow's process. Let's see how. We will see this even in alcohols. I'll do this in detail, right? So now you just see that what kind of reaction it shows you. First kind of reaction is nucleophilic substitution reaction are very difficult, but still it shows these kind of reactions here, right? So that is with Dow's process. If you talk about, this is called as Dow's process. In Dow's process, what will happen under very drastic condition, I'll tell you the full mechanism as well. Under very drastic conditions, what will happen? This Cl will be converted to OH here with the formation of benzene, right? And what about this one? If you don't have drastic condition, but you have on the ortho and para, you have the NO2 group. In that case, what will happen? In that case also, nucleophilic substitution reaction is possible. Otherwise, it is not possible here, right? Otherwise, it is only in these two cases it is possible, right? Then, if I talk about electrophilic substitution reaction, it does show electrophilic substitution reaction at a very good rate. So, halobenzenes are ortho and para directing. That is why whatever reaction they will show it on the ortho and para position. So in this case, you have Cl positive electrophile that will be on the ortho and the para position. In this case, you have NO2 positive electrophile that will be again on the ortho and para position, right? Then you have this thing, one more thing, I'll just show you where the electrophiles will be there. Wait a minute. I had taken that page where I have written all the electrophiles and all. So I think now I am not able to find it, but eventually will do, right? Then you have, if you have H2SO4, here the electrophile will be SO3H, electrophile will be SO3, then it will attack on SO3 here, then internal hydrogen transfer will take place, and ortho and para position, you have always para will be the major product here, right? In this case, this is Friedel-Crafts acylation. In this case, you have CH3COO positive as an electrophile. It will attack on the ortho and para position, ortho being the, para being the major product here, right? Okay. Then Friedel-Crafts acylation, Friedel-Crafts alkylation, you have CH3 positive electrophile here that will attack on the ortho and para position, para being the major product again. Now the reaction with metals, we have done Woods reaction, Woods fatigue reaction, all these reactions we have already done, right? Okay, tell me, is that clear? Don't worry, there are so many reactions that will be in some other this, right? Okay, tell me, is that clear? Okay, most welcome. Yes, now let's see this over here, right? Now let's see this. Now let's see some more things. I think in alcohols we have done this part, haloalkenes, halorenes, hai na? We have done mostly. Wait a minute, okay? I'll just see after in the break, I'll take 15 minutes break and I'll see if there is some part left or not, right? If there is some part left, I'll teach you that, right? I to think so all of them is created, but still I'll have to see, right? Okay. Now let's start with alcohol, phenols and ethers. Right, everybody? Let's start with alcohol, phenols and ethers here, right? So alcohol, phenols and ethers, let's study that. Let's study that. See, here like so many reactions, because some reactions are not there, I have put it here. So accordingly, there are so many reactions. So oxidation, firstly, Oxidation of alcohols is very important. So for that you must know mild oxidizing agent and strong oxidizing agents. So mild oxidizing agents like PCC, PDC, then you have CrO3, then you have CrO3 in presence of let's say water. Simply you can write it there, right? Wait a minute. Yes. CrO3, yes. Okay. Then here you have CrO3, cold KMNO4, K2Cr2O7. Then you have CrO3 with H2SO4. This will be CrO3, CrO2, sorry, CrO3. Okay, with H2SO4. This is CrO3 with acetone, right? So all these are weak oxidizing agents, mild oxidizing agents. So how they are going to react with 1 degree, 2 degree, 3 degree alcohol, this is what we will talk about, right? Okay. So if I talk about 1 degree alcohol, 2 degree alcohol, let's see how we are going to do that. Right, everybody? Let's see. So mild oxidizing agents will convert this into aldehyde, right? Then 2 degree will be converted to ketone, 3 degree will not show any reaction. Strong oxidizing will convert this into ketone and this into ketone, it's ketone I am saying, this into carboxylic acid, right? This will be converted to ketone only. This will show no reaction. In copper at 300 degrees Celsius will convert this into again aldehyde, simple aldehyde, and this will be converted to ketone only. And here this is very important that copper at 300 degrees Celsius will convert this into alkene, right? Okay, yes. Tell me, better just do one thing, okay? This is, I am ending it. Shall I end? Tell me. I'll end this. You want this session to end? Let's end this. Okay? Chalo. PPT I'll provide you. Do it on your own. Chalo. Okay. Bye bye. Done? Yes. Now let's see this, okay? Chalo. Now, I'll just ignore them. It's been 2-3 hours when the session, beta. When someone is doing something for you, they're not asking anything from you, na. It's not like you're on gunpoint. You have to be in this session. Nobody is asking you. You are not in this class as of like in offline form. You are here, and I can see you can't bunk the class. You don't want to see, go. Why you are here? Who is asking you? No one is asking you. This is only for sincere students. You are not sincere, you can go. Who is asking you to stay here? Ma'am, inorganic chemistry in 1 day. Ma'am, organic chemistry in 1 day. Ma'am, I want, ma'am, 1 hour, ma'am, organic chemistry. Ma'am, 30 minutes physical, ma'am, complete it, ma'am. 30 minutes physical. Okay, I'll do this. Okay, some churan I'll make and I'll throw it at you. Right? That way only some magic can happen. Otherwise, though, it will take time. Right? Either I'll do, okay guys, tuck, done. Bye. Should I do that? Don't create nonsense here. Huh? Don't create nonsense. stupidity. पता नहीं why you guys like, some people na, they like, from the past 5 hours I'm controlling, I'm like, okay, I'll not say anything, I'll not say anything, I'll not say anything. Do you think it is easy? My throat na, it is literally so sore right now. I'm not able to speak. I know I'll have to take medicine. I hate medicine, I hate antibiotics. I'll have to take that. I could have rested. Chalo. So this is about mild, strong and copper at 300 degrees Celsius. Now what if you have very strong oxidizing agents, then what will happen? What if you have very strong oxidizing agent, then 1 degree alcohol is converted to carboxylic acid, 2 degree alcohol, right? Let's see 1 degree alcohol, so even with the strong it is converted to carboxylic acid. What will happen to 2 degree alcohol? What will happen here? You will have this alcohol is converted to ketone, then ketone will be converted to enol form. This will be tautomerized. How it will be tautomerized? This is 1, 2, 3. Here you will have double bond. This will be converted to H. Tautomerism will take place. After tautomerism, this double bond will break. Here you will have, wait a minute. This double bond will break and here you will have C double bond O and here you will have C double bond O, H and H. Then further, this H and H is converted to OH. All the carbon hydrogens that are next to carbonyl carbon are converted to OH. Then further, this will be converted to H2CO3. Okay? H2CO3. And that's how you will have carboxylic acid as the answer. Right? Okay? Tell me. Understood? Yes. Acha, now if you have 3 degree alcohols, then what will happen? Right? Let's talk about that. In 3 degree alcohols, what will happen? I'll just draw this here. In 3 degree alcohols, let's say this is the 3 degree alcohol, what will happen here? Because this is with very strong oxidizing agent under drastic conditions, right? We are trying to do oxidation. So firstly, so it will be converted to alkene, right? So just like in copper at 300 degrees Celsius, this will be converted to alkene firstly. Then here after alkene, what will happen? This bond will break, you will attach double bond O, double bond O. Okay, same alkene attach double bond O, right? Right. Now if you see, this is further converted to H2CO3 by replacing this with OH and OH. So that I can see is further converted to C double bond O, OH and OH. That is nothing but H2O plus CO. What about this one, ketone? That is the same thing. Can you see here also it was ketone? Same thing will happen here again, right? Ketone will be converted to enol form. This is CH2, this is double bond, this is OH. Enol form, again this pi bond will break and this will be converted to CH3C. This is OH, this is double bond O, plus this will be C, H, H double bond O, which this thing will stay as it is. This will be further converted to H2CO3 and then to H2O plus CO2. Okay, so in the end, what is the product that you will have? Your product will be CH3COH and H2CO2, that is formed from this part and this part. This is under very strong, like this. Done? Tell me everybody. Done everyone? Tell me. Is there any problem in that? Right? Okay. Now there is another oxidizing agent like you have MnO2. Right? In MnO2, what will happen? Let's talk about that. Okay? In MnO2, it selectively oxidizes primary and secondary allylic alcohols. So it will happen. This thing will be oxidized to CH2 because this is allylic. C double bond, then C, this is allylic alcohol. This is benzylic alcohol because to benzene, next carbon, it is OH is attached. So this part is converted to C double bond O. This part is converted to CHO. Right? So Mn2 selectively oxidizes primary, secondary allylic benzylic alcohols. Primary alcohols yield aldehyde, secondary alcohols form ketones respectively. Right? Okay. Done. Acha, then let's talk about this one. Let's talk about this one. See if you can remember this or not. Tell me. If we talk about alcohols now, there are three ways of forming alkenes to alcohols, right? Let's see about these things. First is acidic hydration that we have already talked about. That in this case, carbocation will be formed and rearrangement of carbocation will take place here. In case of oxymercuration, demercuration, just remember these are the reagent, that is mercury acetate and H2O and NaBH4 is the reagent. And here negative part to less hydrogen will be attached, that is Markovnikov rule will be obeyed here. In case of hydroboration oxidation, these are the reagents H2B6, THF, peroxide and OH negative. Their anti-Markovnikov means OH negative to more hydrogen, that will be obeyed. Right? Okay. ठीक है, समझ में आई? Got it? So what we have here, what we are doing here. Understood now what we are doing here? Now next is, right, pinacolone rearrangement. So it is not like so important. It is very important when I talk about JE Advanced, but in your case it is not so important, but just see this once. What exactly will happen? H positive will attack here, so this will become OH2. So this will leave from this side and you will have the formation of a carbocation here, right? Now in carbocation again, what will happen? Some alkyl part will be rearranged, that is rearrangement. So this will shift here, you will have OH, this carbocation is carbon with positive, this is carbon with positive along with back bonding. Because of this back bonding, this is highly stable, and after that what you will do, this is RC, this H will leave from this side, this H will leave here, and this will be double bond O, and this will become Cr3, and that is called as pinacolone, right? So either though you can do this, or if you want to leave this, I'll just mark a cross here, you can also leave this. Okay? It's like very rare chances that they will ask you this, right? Then this has very high chance, Kirchhoff's reaction. We'll also study this in alkynes. I think I by mistake missed the pages of alkyne, so in the break I'll just paste the pages of alkyne as well, alkyne and aromatic as well. There are some important reactions there as well, so I'll just paste it for you. It's a very small part, alkynes and aromatic. It will hardly 2-3 pages will be there, right? So Kirchhoff's reaction, what you have alkyne, you have it is same as acidic hydration. So what, I'll just give you one more example. Let's say you have CH3C triple bond, this is CH, right? Now what will happen, you will have the formation of a carbocation CH3C positive, right? Then you will have CH2, this is double bond, right? Now what you will add, according to Markovnikov rule, you will add OH negative to the less number of hydrogen, H positive to the more number of hydrogens. Okay, OH negative to less number of hydrogens and H positive to the more number of hydrogen. This is how you are going to add this. This will form enol, this will form enol, and what you will do after this you will convert it to keto form, right? That is, this hydrogen will shift here, double bond will shift here, right? That is Kirchhoff's reaction. Understood? Paste the notes means ma'am, where will you paste the notes? Paste the notes means I didn't get you. Paste the notes means what? Just give me a second, guys. I'm just getting a call in between. Just give me a second. Okay, so then, yes. Wait a minute. This is like Lucas test you have now. This is two tests you have for alcohols. One is the Lucas test, that is also called as this Grooves test. Okay, Grooves process. Right? Tell me. Wait a minute, guys. Wait a minute. Just wait a minute, guys. Just give me a second, okay? Wait a minute. Yes. So if I talk about Lucas test or Groove's test, as you can see this over here, we have already done Lucas and Groove's test. So here what exactly happens? Lucas reagent is anhydrous NaCl2 and HCl. 1 degree, 2 degree, this I have already told you there that 3 degree will show immediately turbidity will be there. Then after this 3 degree is maximum, then you have 2 degree, then you have 1 degree. This will be immediately, this will be after 5 minutes, and this will be after 30 minutes, and that too after prolonged heating, right? Then you have Victor Meyer test, right? In this case, as such, you don't have to remember everything. Just remember that in primary you have red color, in secondary you have blue color, and in tertiary you have colorless. So just remember one thing like this: R, then you have B, then you have C. RBCs, na, you have RBCs. RBCs in our body. So just remember this thing. This much is enough for you, right? But still, I have shown you the reaction. Firstly, HI, then AgNO3, then HNO2. In the end, the color that you have is red color for primary, blue color for secondary, and colorless for tertiary. Right? Okay. Tell me. Is that clear? No, I'll complete it today only. Don't worry. Don't worry. We don't have as such. Only 100 slides are left. 100 slide what I'll teach you in next class. Right? So alkene to diol. So what you have here is this I told you that in alkene to diol, when you have diol, for syn addition, whenever you have KMNO4 or you have osmium oxide, then you, let's say you have this kind of alkene, right? Then what will happen? By the syn addition, this bond will break and you will have OH by syn addition, right? But if I say you have anti addition, whenever you have peroxy, this kind of acid is there. For example, MCP meta chloro peroxybenzoic acid, MCPBA, yes, MCPBA, metachlorobenzoic acid, like this. Okay, so you have on meta position, you have chloro per this acid, ठीक है, peroxy acid, ठीक है, metachloro peroxybenzoic acid, benzoic acid, I'll just draw H here, right? This thing is there. Or you have, let's say, CH3 acetic acid but with metachloro, so with peroxy. So this is peroxyacetic acid. If you have this thing, okay, so that's why directly I have written, if you have this group here, that will give you anti addition, right? Okay, then you have let's say this is also very important, right? That if you remember, I told you that RMGX, how it will behave and give you primary, secondary and tertiary. So I'll just write it here. Let's say you have RMGX, right? You have this reaction. Let's say this is RMGX. You have this reaction with HC double bond OC, right? Double bond H, right? What will happen? In this case, this is negative, this is positive, it will attack here, this will shift here. So it will give you, this is H, this is C, this is H, this is OH. Okay, it will be OMGX, but after hydrolysis, this will become OH, right? And this R will be there. So it is giving you primary alcohol. So aldehyde will give you primary alcohol. If you see, you have RMGX with, this is very important reaction, okay? You have aldehyde apart from methanol, right? What it will give you? Again, this will attack here, this will shift here, and it is going to give you R This is C, this will become OH, this is H, and this is R dash. It will give you secondary alcohol. Then again you have R MgX, this is R C. If you have ketone, let's say you have ketone, so it will act here, it will shift here, and what it is going to give you, again this is R, this is COH, this is R dash, this is R double dash. Okay, this is tertiary. So primary, secondary and tertiary alcohol it is going to give you, right? Okay. Acha, is there, ma'am, any other reaction like that? Ma'am, it also gives other reaction like that? Yes. Grignard region shows other reaction as well like that. But I'll just show you, that is for the preparation of COH, right? So I'll just show you that. That is for the preparation of COH. So you have RMgX, right? If it reacts with C double bond O, these are two again very famous reactions, negative positive, very frequently asked reactions. This is become C, it will become O negative, and this will double bond O, and this R will be attached, and O negative will have the attachment of MgX, then further it will lead to OH. That is the formation of carboxylic acid from Grignard reagent, right? You also have one more reaction, that is if you have RMgX plus you have here, let's say HCN. No. Achha, that is not here. Cyanohydrin will not do here. Yes. Okay. So these are some of the reactions of Grignard reagent that are very, very famous. Right? Then we will do phenols. Let's understand phenols. Right, everybody? Tell me. Then if I talk about reduction, okay, aldehyde is converted to 1 degree, ketone is always converted to 2 degree alcohol, acid derivatives are always converted to 1 degree alcohol. But one thing to remember, that LiAlH4, it will only reduce aldehyde, ketones, acid and its derivative, everything, but it will not reduce double bond. It will only reduce double bond in the cinnamic systems like this. PH, CH, double bond, CH. Only in the cinnamic systems, it will reduce the double bond as well and this as well. Okay. Then NaBH4, this is very important. NaBH4, this can reduce aldehyde, ketones and acid chlorides, but it will not reduce CO, it will not reduce ester, it will not reduce carboxylic acid or any other thing, right? It will not reduce that. Okay, done everyone? Next is you have phenols. Now before moving towards phenol, let me see the important preparation of alcohols and that we'll do firstly. Okay, before doing this, we'll do preparation of alcohols here, and then we will do reactions of alcohols, right? This is, we have done preparation of alcohols. This is just from the flow chart. I just want to see that there is no reaction that we are left with. Okay, like important reactions I don't want to leave, right? Okay, those reactions that I am not giving importance to, you can automatically feel that they are not important, right? So preparation from alkenes, we have done hydration. Here carbocation is formed, we have seen. Hydroboration we have done, right? Then we have also done oxymercuration, demercuration. Then from the carbonyl, see, aldehydes, the reduction will give you alcohols. Aldehyde that I have just told you here, aldehydes will give you primary. I have just written it in a different way. Aldehyde will give you 1 degree, ketone will give you 2 degree. Okay, so you can see this over here. Aldehyde gives you 1 degree, this gives you 2 degree. reduction of carboxylic acid in ester. See, if you have LiLH4, that can reduce carboxylic acid to primary. And esterification reaction also you can do, right? That is not esterification. No, esterification nahi. You have acid, when it reacts with R-OH, it gives you the formation of ester. Right after that, after the this is not very important reaction. This is you just reduce it and you will have the formation of this. Okay, means we simply want to say if you have ester, this is esterification reaction. And remember that in esterification reaction, this bond will break, and here this bond will break. OR will be, this OR will be from alcohol. Okay, remember this part, that the OR will be from alcohol. Now ester is esterification. After that you add H2 and you have alcohol here. Then from Grignard reagents, what you have? You have RCH2, CHO. This also we have done, isn't it? How aldehyde reacts with Grignard reagent to give primary, secondary and tertiary alcohol. This also we have done, right? Okay, so preparation to we have done very beautifully, right? So now I'll do reactions of alcohol. ठीक है जी? Reaction of alcohol. Wait a minute. I think reaction of ether, preparation of phenol is there. Phenol. I think we have done it already. Right? Okay? Tell me, everyone. Yes. Now let's see next, that is phenol. So preparation of phenol from cumene process is a very, very important process, where what you do, cumene hydroperoxide reaction, industrial preparation of phenol. This is, cumene is isopropyl benzene. When you react it with O3, this has peroxide linkage here. When you add H3O here, when you hydrolyze this, it gives you acetone and phenol here. That is cumene process. Byproduct is also very important. In Dow's process, what happens? This chlorobenzene, it will be converted to phenol. Let's see the mechanism here. See, mechanism is, firstly this OH will attack here, it will take out H positive and these electrons will shift here, right? And in this, by this time Cl will be, we will take out Cl here, and you will have the formation of benzene as an intermediate. So what exactly happens? Base will take out proton, this will shift here, and on the same, this you can show that this will shift here. You don't need to do this much big step here. You can directly show that this is happening. How this is happening? Okay, you can directly show that this is happening. Okay, this is NaOH, this is H. It will attack here, it will take out proton, this will shift here and this will shift here. So you will have the elimination of NaCl here, and this will be benzene that is formed here, right? Now this is under the category of elimination. Firstly elimination is there, then you have addition. So this is under the category of elimination addition reaction. Okay, this is under the category of elimination addition reaction, right? Now after this, again you have the, here it is NaOH is acting as a base, here OH is acting as a nucleophile. So when it is acting as a nucleophile, it will attack here, these electrons will again shift here. So OH will be there, and this is this is the negative part that you have. Now to this negative, what will happen? Internal shifting of hydrogen, and this will shift here, and you have O negative. Then you add Na, this is ONa, then that is converted to OH here, right? Okay, so all you need to remember is that here you have the intermediate, that is benzene. benzene, and this is elimination addition reaction, because firstly elimination is taking place, then you are adding OH. Okay. In reactions also you need to understand that what is the important part, because this is not a subjective paper. They're not going to ask you everything. You should know, but this is the, if you know full mechanism but you have not taken care that this is elimination addition, and they ask you this Dow's process is elimination addition, you are not able to answer that, you are already ruined, right? So that thing you must know. Then cumene process, chalo this to we have done, right? Okay. Acha. Next is Colby's reaction. Let's talk about that. In Colby's reaction, what you will have? You will have phenol, NaOH. This is converted to phenoxide ion. Then you have CO3 that is converted to salicylic acid. Let's see how it is done. Let's see how it is done, right? So if you have this here, firstly what will happen, right? Base is going to abstract the proton and this will give H positive here, like here you will have this, it will leave and this will give O negative here. Base is going to abstract the proton and you will have phenoxide ion. Now this phenoxide ion will show resonance. This bond will shift here, this bond will shift here. It will show you this resonance on the ortho position. It's not like para salicylic acid is not formed, but ortho is formed in more as a major product because of hydrogen bonding, right? So here you have ortho negative, para will also have negative, same thing will happen on para position as well, if you are thinking about that, right? So CO2 we are going to add, and CO2, this is the electron, here electronegativity is more, here it is less. So what will happen? It will attack like this, right? And these electrons will shift here. So you will have CO negative CO. Now what will happen? This H will shift and this bond will shift here. This bond will shift, this H will shift here. You will have salicylate ion. Then you add Na positive. Then you acidified it and you will have salicylic acid, right? Okay. Major important thing is only here, right? This all part is simple. Just remember, base will attack, it will form phenoxide. Then on the ortho position, this carbon electrophile is going to attack. And after that, so nothing. You have, once you have C double bond O negative, then you just have to interchange the hydrogen. Hydrogen it will take, right? This bond, hydrogen will leave, this bond will shift, this bond will shift, and you will have salicylic acid. Tell me, is that clear? Okay, done. Then you have Reamer-Teamer. Again, very important. You have phenol, you have CH3, NaOH, you acidify it. What will happen? You will have salicylic aldehyde. But with CCl4, you will have the formation of this thing, OH, and this is COOH. Okay? Okay? Understood? Tell me, understood or not? So in this case, you have the formation of dichlorocarbene, right? What will happen? This I told you, if you remember, in I have not told you there that I taught NEET aspirant. So sorry. Yes. So a base will what will happen? Base will attack here. You will have, what will happen? Base will eliminate the proton. This will shift here, and you will have the formation of CCl3, right? You will have the formation of CCl3, right? Once you have the formation of CCl3, then Cl negative will also eliminate, and you have the formation of dichlorocarbene. This is the electrophile. Now, question that is asked here is, electrophile is generated from chloroform and base, and this is dichlorocarbene, and it is generated by alpha elimination. Okay? These are the MCQ based questions they can ask you from here, right? Then next is what you have here. Base firstly will abstract proton, you have phenoxide ion, it will resonate and it will give you this thing. Now this is not lone pair, this is electron deficient carbon. Why? Because here you have only 6 electrons, 1, 2, 3, 4, 5, 6. So it is going to attack here, right? And what is going to happen? CCl2 will be attached here, right? Okay. Now, which one, what thing will have negative? Firstly, so here you will have negative, right? You will have negative over here. You will have negative over here, right? What will happen now? Uh, Negative, this H positive will eliminate. It will attack here and it will form CHCl2. This will be shifted here. Same way here also we did the same thing if you remember. Here also we did the same thing. I eliminated H and bond shifted here and it went here. Same thing I am doing here. Same thing. It's not like these reactions are very different, but yes, obviously difference is there, right? So this will shift here. You will have O negative. This is CHCl2. Now OH negative will again, what will happen? Do you remember how Cl is replaced by OH negative, right? So 2Cl will be replaced by OH negative. Carbon cannot handle 2OH. So OH negative will be eliminated, H will be eliminated, bond will shift here. You will have CHO, then acidified, and you will have salicylic aldehyde. Okay, tell me. Then you have ethers. This is again very, very important reaction, Williamson synthesis reaction. In this case, what you have RX and NO, you have alkyl halide and alkoxy and you have alkyl halide and what was this? I forgot the name only. Oof, what was this? Alkyl halide and alkenoid. What was this, guys? Alco what? Forgot that only. So see, first thing is this should be primary halide, right? This has to be alkoxide, such. I think, what was that? Right? So many names I have taken today, na? Alkoxide, okay? Alkyl halide and alkoxide, but the condition is this has to be primary, okay? Otherwise, this reaction will not take place, right? So that is the thing. If you want to prepare this thing here, you will choose CH3X as the alkyl halide and you will choose this as the alkoxide. Okay, done? Yes. Then you have ether and concentrated HI, right? See, it's not like there are not other reactions. You can form unsymmetrical ether by adding Ag twice O as well. But they never ask you that, right? And I am doing important reactions here. So I'll tell you, you have ether, you add concentrated HI here. What will happen? This is important part. Okay. Where less steric hindrance is there, right? So if R and R dash are primary, then SN2 mechanism, right? So I will be attached where less steric hindrance is there, right? If one of them is 3 degree, then it is SN1 reaction. If I say one of them is 3 degree, okay? If let's say this is CCH3, CH3, CH3, then carbocation, then I will be attached here and here alcohol will be formed. If let's say this is also CH3, this is also CH3, this is also CH3, this is 2 degree. If I say, okay, both are primary only will take, let's say this is this. Okay, now where less steric hindrance is there, there I will be attached. So I will be attached here. Okay, so that's how you will give the answer of HI, and this is also a very important and famous reaction. Right? Okay, tell me. Tell me. Right, after this we'll do some reaction of phenols and test of phenols, ether. Right? Yes. Chalo. I think question though today I'll have to give you for homework only. The question that I bought for you, we'll see. So firstly, let's see for the preparation of phenol. Dow's process we have seen. This Dow's process we have seen. Then there is one more process, that is sodium salt of salicylic acid. If you have sodium salt of salicylic acid and you react with soda, basically this is soda lime decarboxylation reaction. So this will be converted to H, because we know that in soda lime decarboxylation this part is converted to RH. So here this will be H, and that's how you will have phenol, right? Then this is from cumene also we have done. From disonium chloride, how it is formed we have seen. If you vomit, this is directly converted to phenol. Then from benzene sulfonic acid, this is also important. This is directly converted to SO3Na. You fuse it with NaOH, this is converted to this, that is sodium phenoxide. Then it is converted to phenol. Then this is from phenyl magnesium bromide. You have benzene MgBr. This, whenever it is reacted with proton, okay, this is MgBr, okay, whenever reacted with proton, it will directly give you OH here. Wait a minute, if I directly reacted with proton, then it will give you benzene, right? But if you have half of O2 and then rise it, it will become OMgBr, and then this is O negative, M positive. Then you react this with H positive, this will be replaced by H positive, and you have the formation of phenol. Okay, done. Then you have the reaction of phenols. If you see this over here, reaction of phenols, what you have here, see, first thing is phenol with zinc will give you benzene. Then phenol with Br2 aqueous will give you 3 substituted bromine. Phenol with Br2 in CS2 give you only mono substituted. With dilute HNO3 it will give you mono substituted. With concentrated HNO3 it will give you tri substituted nitro. With CH3Cl, because it is ortho para directing, it is going to make CH3 positive as the electrophile, and this is going to see in all these cases electrophile is attacking now on the ortho and para position. Here CH3 will attack on ortho and para position, para being the major product. Here if you see, okay, yes, if you have H2SO4, this is directly going to give you para SO3H, because SO3 is the electrophile here. If you react this with, this is acidic, so with base or metal, it will give you salt, that is sodium phenoxide. With Na2Cr2 7, it is going to give you benzoquinone, very important. Directly base, it is going to give you sodium phenoxide, and after that this is Cole's reaction that we have just discussed. This is Reamer-Teamer, that also we have discussed. Acha, when you do reduction, all the pi bonds will break and this will give you OH here, right? Okay, tell me. Done? Then you have test of phenols. See, test of phenols, what you have, ferric chloride test. Just remember that. Salt you don't have to remember. Just remember with ferric chloride, it gives you violet color compound. And with bromine water, definitely it gives you white color precipitates of tribromo substituted product. Right? Okay. Then preparation of ethers, we have done one important thing here. From alcohols by dehydration also it is formed. See, alcohol dehydration also gives you alkene. But if it is at a temperature 413, then what will happen? This will be eliminated, it will give you ROR. So it can also give you ROR at 413 Kelvin. Then from alkyl halide Williams synthesis, we have done it in detail. And all of this is Williams synthesis that is written here, right? Okay, then let's see reactions of ether. So here most important reaction is HI that we have seen. And this also I have told you that where HI you will do. Now for example, this is there. Whenever one of them is 3 degree, then it follows SN1 mechanism. Then halogen is attached where carbocation is more stable. So halogen will be attached here, H will be attached here. That's why CH3OH and this is formed here, right? This trick also I have written when I wrote about HI. Then let's see electrophilic substitution reaction of this anisole. Same thing. Br2 in ethanoic, this will give you Br2 positive, Br positive electrophile. Para will be the major product here, right? Then you talk about any other reaction. Friedel-Crafts reaction, this will give you CH3 positive as the electrophile, para being the major product here, right? Then here it will give you CH3CO positive electrophile, para being the major product. Nitration will give you NO2 positive electrophile, para being the major product. Right, everybody? Tell me. Right? Acha, one thing to remember here. I wanted to tell you something here. Wait a minute. I forgot. I just wanted to tell you something. Let me see. This we have done. That was that here usually para is the major product, but only in case of orthonitrophenol, ortho is the major product because of the hydrogen bonding, and ortho is also steam volatile. Steam volatile. Right? Okay? Tell me. Beta will complete everything. Okay? Instead of motivating, na, you are demotivating me. I can see that. You are like, chalo, I think we'll be able to do it. Yes, we will be able to do it easily. Easily to nahi, but we will be able to do it. Okay? Okay? Tell me. Tell me, everyone. You complete, ma'am. We are with you. Good. Tell me. Any problem till here? Any problem? I'm already dead. I mean, that situation, I think I will not talk to anyone for one day. Yes. So, tell me, do you want to do a bit of aldehyde as well before taking the break? Tell me. I am to telling, let's do. है ना? Let's do aldehyde as well. ठीक है? Let's do aldehyde as well. Shall we do? Right? Okay? No, I want to complete it today, guys. I'm literally in that. I'm not that person only. Okay? If I'm decided something, I will do that. No matter what. Very stubborn kind of person, right? So, aldehyde ketones and carboxylic acid. I always push my limits, don't worry. So firstly, let's talk about Tollens reagent, right? In case of Tollens reagent, what you have, always remember, all these reagents, aldehyde will give the test, ketone will not give the test. Aldehyde with Tollens reagent, it is getting oxidized. And what all shows Tollens reagent is aldehyde, formic acid, alpha hydroxyketone, hemiacetal, all of them will show Tollens reagent test. Then you have, if I talk about hemiacetal and ketal formation, what is exactly hemiacetal and ketal? Wait a minute, I think other reactions. Felling test I'll do firstly, right? I'll just do this firstly. Okay. Felling test is aliphatic aldehyde. It is only shown by aliphatic aldehyde. You have two solutions, Felling A and Felling B, right? Felling B is also called as Rochelle salts. And remember this thing, this reaction you can see for yourself. Just remember that aliphatic aldehyde will show this test, right? Then you have Benedict solution. In Benedict solution, instead of sodium tartrate, you have citrate here, right? Everything else is same. That in here also what you have, blue color, this what happens, blue color to red color precipitate you will have. Even here you have the same thing, blue color to brownish red color precipitates you will have, right? It's just that Felling solution you can you have to prepare it before Felling solution you have to prepare it on the spot, and Benedict you can store it as well, right? Then you have, wait a minute, wait a minute, wait a minute, yes, now you have hemiacetal and ketal formation, right? So see how hemiacetal and ketal preparation will work. So again, very important reaction. See, I have covered all the important reactions only. So whatever is written here is important, right? So you have RCHO, you have H positive. What will happen in this case? Even if you don't remember the process, just directly remember from aldehyde you have the formation of acetal and hemiacetal. Hemiacetal is when carbon has one alkyl, one hydrogen, one OH and one OR group, and acetal has two OR group, one R and one H. See, R and H so will remain here, right? Here you will have OH and OR, here you have both the OR. In this case, this part will remain. This CR, this part will remain. In hemi is ketal, you have OH and OR, just like here you had OH and OR. In ketal, you have OR on both the sides. Okay? Then, if you see this here, you have ethylene glycol. This is another way of preparing ketal, but this is called as cyclic ketal. When water is eliminated here, this COOCH2CH2 that is prepared. Again, this is a very important reaction. Right? Okay? Done. Then guys, you have the preparation from the Rosenmund reduction, where you have COCl, you have Lindlar's catalyst. This HCl will be replaced by hydrogen, and that is your benzaldehyde is formed. Next, let's understand, before aldol condensation, let's understand cross aldol and everything. Let me see Itard's and Getterman reaction, okay? Let's see. Itard's and Getterman reaction. Yes. In Itard's, what you do? You add chromyl chloride, you add CS2. Directly, toluene is getting converted to CHO. Even this intermediate you should know, right? Okay. Then Getterman-Koch reaction, you have COHCl and anhydrous-ClCl3 CuCl. Directly this is converted to benzaldehyde, right? Okay, tell me, is that clear? Is there any problem in that, everyone? Is there any problem, right? Is there any problem in that? Do let me know in the chat box. if there is any problem in that. Okay. Okay, before Canizaro and all, let me see if there is some other reaction that we must do before that. Yes, we can do these reactions. Acha, these are in the, we'll do this. Wait a minute. Chalo, pehle I'll just do flow chart here, okay? I'll do flow chart here. Learn, so you can learn it anyway. I'm just trying to make a sequence here. Preparation of aldehyde. See, let's see if we have done all the reactions or not. You will see all of them will be repeated here and there only, right? So, if you see oxidation of alcohol on very good oxidizing, with very good oxidation, they are converted to aldehyde, right? Isn't it? We have seen aldehyde and ketone preparation while doing oxidation of alcohol. Do you remember that? Yes, we have done that, right? Catalytic hydrogenation of which thing? Of alcohol. Dehydrogenation of alcohol, when you take out hydrogenation. So this copper at 300 degree also we have done. This is also oxidation. That also we have done in oxidation part. Gattermann-Koch reaction I just showed you for benzaldehyde. Friedel-Crafts acylation. In this you add R, C double bond O. You put it here, you will have acetophenol kind of products here. So ketone is formed. From alkynes, see from alkynes how it is done. Do you remember Kirchhoff's reaction? Do you remember Kirchhoff's reaction, everyone? Do you remember that? Kirchhoff reaction. How we prepared from the tautomerism, we prepared this. Ma'am, what about, ma'am, this B2H6? Achha, see one thing. If you have break the pi bond, you attach, let's say this is CH3, let's say this is CH3, this is CH3. So according to anti-Markovnikov rule, you will obey this, right? So I'll just put, let's say this is CH, this is CH, this is C, this is CH3. According to anti-Markovnikov rule, OH will be attached here. Okay? Why? Because of anti-Markovnikov rule. Then you will do tautomerism. It will lead you to CH3, C, H2, C, double bond OH. Aldehyde is formed, isn't it? By hydroboration oxidation of alkynes, you have aldehyde formation. You have aldehyde formation. By this, you have the formation of ketone. Got it? Yes, tell me. Tell me. Is that clear? Acha. Now next is what? Next is aldehydes and ketones. Now we have seen, do you remember we have done ozonolysis where we used to prepare aldehyde and ketones? Yes, we have done that. Rosenmund reduction, I taught you COCl will be converted to CHO. We have done this as well. Reduction of nitriles. In fact, we will see this in amines, but let's do it here only. Reduction of alkynes, nitriles with this or this or this reagent. This is called as Stephen's reduction. That is important, right? SnCl to HCl. It is directly converting this to RCHO, right? That one is important. From esters, you have Dibble. With Dibble, it is directly converted to RCHO. Dibble directly converts esters to RCHO. Important, Dibble converts ester to RCHO. Okay? Then oxidation of 1,2 glycols. So once you have 1,2 glycols, its oxidation, what will happen? This will break and it will give you RCHO and R-CHO, right? Diglycols you have now. Whenever you oxidize this bond will break and it will convert it into, just break the bond and convert it into double bond O, and that will be your answer. Itard's reaction we have done. Side chain chlorination, this is important. This actually firstly forms, here firstly you have the formation of, CHCl2, right? then that is converted to CHOH. Okay, then that is converted to benzaldehyde, or I'll just draw this thing, then that is converted to benzaldehyde. Okay, okay, reactions of now ketone. What is reaction? See, we have seen Tollens reaction. If you reacted with K2Cr2O7, directly it is converted to carboxylic. This is your Fehling test. This is Benedict solution test, right? Where sodium, instead of tartrate, you have citrate. So you have the formation of red precipitates here, right? Okay, here you have the formation of silver mirror. Then in the reduction case, it will reduce it to further alcohols. It will go backwards to alcohols. So this will be reduced to alcohols. Okay. Reduction, I have told you, na, aldehyde is reduced to 1 degree, ketone is reduced to 2 degree. I have written it in my notes, right? So this also we have seen. Clemenzin reduction. What is Clemenzin reduction? Double bond O to this. Wolff-Kishner reduction also we have done in alkanes part. HI with red phosphorus, directly it's a very good reducing agent. It will directly give you CH2, right? Okay, tell me. Done? Tell me. Acha, before carboxylic acid, I'll teach you some very, very important reactions here, right? Let's do that. Okay, first is this aldol condensation. Mechanism of aldol condensation is not important. I'll just directly tell you how to answer it, right? Okay, let's see aldol condensation, how to answer it. In aldol condensation, firstly you should have alpha hydrogen, at least one alpha hydrogen. Let's see, you have CH3C double bond OH. One molecule, whether you are doing cross aldol or you are doing self aldol, always remember this. This is CH2, this is one alpha. In one molecule you will open the carbonyl part, in other molecule you will open the alpha hydrogen part. So what will happen, directly do this thing, connect the carbonyl part with alpha hydrogen. Okay, once you connect it, what will happen? See, you will have CH3, carbonyl will be converted to OH. This is OH, this is CH2. Okay, this is CHO. That's it. You have already, you are almost there. You have aldol, aldehyde and alcohol. Now from the alpha beta position, take out water. So what will happen? CH3, CH, double bond CH, CHO. Alpha beta unsaturated aldehyde is formed, right? Okay, tell me. Done? If you have cross aldol, in that case, multiple products will be there. Okay, tell me which one do you want me to make? I'll make only one. There will be 3-4 products. When CH3 will react with CH, when this will react with itself, when when this ethanol will react with itself, when this propanol will react with itself, when this will behave as a carbonyl and here alpha hydrogen will attack, or when this will behave as a carbonyl and here alpha hydrogen will attack. Which one do you want me to react? Tell me. Which one? Beta, I will not be taking your physical chemistry marathon. Okay? If this continues, I will not be taking that. Okay? Tell me. Tell me, tell me, tell me, tell me. CH3CHO cell, what I have done here? What was this then? What was this then? This was CH3CHO self only, na? Right? Which cross do you want me to do? Do you want me to take carbonyl carbon and hit this alpha? Or do you want me to take this carbonyl and this alpha? Tell me. So I'll do cross. I'll do it. Chalo, I'll take now this carbonyl carbon and this alpha. Okay? See, whenever you take carbonyl carbon of this one, right? You don't take alpha of this one. You take alpha of this one. This will become CHO. This is CH. Alpha carbon of this. And this is CH3. Always connect carbonyl with the alpha. Once you connect, you will have CH3, C, double bond O is converted to OH. This is H, this is C, H, CH3, this is CHO. From this alpha beta, you take out water. This is H and this is OH. You take out that and you will have the formation of CH3. This will be formed. Okay? Tell me, is that clear? Okay? Now let's talk about Cannizzaro. How do you cover Cannizzaro reaction? See, in Cannizzaro, simple funda is that disproportionation will happen, right? Mechanism you don't have to do for Cannizzaro, right? Mechanism is not important here. Okay? Let's see how do you answer it. Simple. Cannizzaro reaction, valve will be converted to alcohol. Same number of alcohol you make, 1 carbon alcohol and 1 carbon carboxylic acid salt, right? But ma'am, the question is, what if we have cross Cannizzaro? Which one will be alcohol? Which one will be carboxylic acid salt? So less hindered will be salt. We see this is less hindered, so this is converted to give. This is giving you HCOONA and this is giving you C6H5 CH2OH. That is alcohol. Tell me. Is that clear? Is that clear? Tell me. Using cross-aldol, ma'am, can benzaldehyde? You can use it, but cross-aldol you are saying. See, if other part has, let's say you have benzaldehyde, one is benzaldehyde, which has no alpha hydrogen. Let's say other has alpha hydrogen. Because for aldol, at least one should have alpha hydrogen. That means at least one compound should have alpha hydrogen. Only then it is possible. Okay? If both are benzaldehyde, then to, because for aldol, alpha hydrogen is important. If there is no alpha hydrogen, aldol will not take place. Right? Okay? Yes. Beta, do you think this much big lecture I can record? Possibly nahi hai, right? It's not practical only to record it. So, now let's move to ketones, right? Okay, let's see. Aldehyde and ketone preparation, so we have done. Let's talk about what kind of reactions it shows you. For example, it is reacting with HCN. Let's say HCN. It is reacting with HCN. This is H positive, CN negative. It will attack here. This is very important reaction. This will jump here. This will form COH. See, it is forming CO negative, right? Here H positive will attack and here you have CN. And that is called as cyanohydrin. This is called as cyanohydrin. hydrant. Okay. And this reaction I'll teach you after the break, because there is one thing that I forgot to put here. Some things that when you see, then you will, okay, this thing also I forgot. In NCRT, there is a chart. I want to show you that chart. So this reaction, I'll do it there. Okay? I'll do this reaction again. Then you have haloform test. In haloform test, what you do? You have a ketone, you add NaOX, or these all different reagents you can say. And important part is this does not affect carbon double bond, right? So now this haloform is formed. If this is CHI3, this will be iodoform and this will be of yellow color, right? Now what are the things that show haloform reaction? Let's talk about that. If you have CH3, C double bond O, methyl ketone, or you have CH3, this kind of compound, that will show you iodoform test. Otherwise, iodoform test will not be shown. And iodoform is a very, very repeated test that you have. Okay? Thank you, Mehreen. But I'll just take rest after this. Okay? I'll take rest. Don't worry. Right? This is the last break. I'm going to give you 10-15 minutes break, and after that, I'll just finish this because not that much we are left with. Thank you so much, Mehreen. Thank you. Yes. Okay. See, esterification reaction. Again, if you want to do the mechanism, you can do that. But at this point, my duty is to tell you what is reality, right? So, from this mechanism, you need to take out the crux of this mechanism. That what is important here, that this bond will break. Here, this bond will break. So, in the ester, this part is from alcohol. This part is from acid. This is from the mechanism, the conclusion that we have drawn, right? Okay, done. So next is Helmholtz-Zielinski reaction. In this case, what you will have RCH2COH, and the alpha hydrogen will be replaced by halogen in presence of X2 red phosphorus and water. Then you have Dibbel. Dibbel is diisobutyl aluminium hydride, which will convert any acid derivative or nitrile into RCHO. Okay? That's why I have directly written it here. Okay? Done? Tell me. Is that clear, everyone? Is that clear? Tell me. Now, let's see preparation of carboxylate. 3 slides we are left with, right? Not on this, just because after this, just 2 very small chapters you have, right? And that alkyne and aromatic part is also very small. So, very small things we are left with right now. Okay? So, preparation of carboxylic acid C from nitrile, you can prepare it by the hydrolysis. Full hydrolysis, right? From RMgX with CO2, this reaction I showed you also to prepare. This reaction is very important. Okay. Then even if you have amide with hydrolysis, you will prepare. This is not partial, this is full complete hydrolysis. Okay. Oxidation of very like mild oxidizing agent also, if you are using for RCHO, that will convert it into acid. If you are using alcohol, then you need very strong oxidizing agent to convert it into carboxylic acid. And do you remember that part where I was converting primary, secondary and tertiary alcohol to carboxylic acid? That is also under this created under this category as well. We can see that. Okay. Then like you have CN, CONH2, acid chloride or anhydride, you do hydrolysis, it will convert, or ester. All these are acid derivatives. This is acid derivatives. all the acid derivatives with hydrolysis are converted to carboxylic acids, right? Then if you see alkene and alkyne, you react this with KMNO4, right? This is directly converted to carboxylic acid. Very strong oxidizing agents here. Do you remember how I did it? Tell me how many of you remember this? Do you remember we have done this? Alkyne, break the double bond, attach double bond O, then ketone, tautomerize it, then the break double bond O, then it was converted. How many of you remember? I have given you full-fledged how to convert alkene to 3-degree alcohol was converted to alkene. The process that I followed, that same process will be followed here, right? Okay, in this case, so when you break the double bond, this will be OH, this is already enol, then you convert it into ketone, then the same part, how to convert ketone to carboxylic acid, okay? So same, it's not like some new reaction it has, it is the same, try to relate it, right? It is the same. This will be converted to enol, now enol to ketone, then ketone to carboxylic, so we have done in 2-degree alcohol as well. So this reaction also we have done. Then this is very, very important reaction, that you have any alkyl chain. Condition is it should not be tertiary. Any alkyl chain, you oxidize it, it will be converted to COH. Okay? Understood? Okay, ji? Tell me. Jyoti, I'll just show you the reaction here. I'm 281 slide, na? 279. Wait a minute, let me see. See, this is what I am talking about. How we converted firstly ketone to carboxylic acid. Okay? So this is how we converted, this is a reaction. Alkene to carboxylic acid. Same thing I am telling you here, that if you have, wait a minute, 270, na? This one. Same thing I am telling you here, if you have alkene now, so you can directly convert it to carboxy, that is the same thing only, right? Okay? Then now, reaction of carboxylic acid. Acid, it reacts with any of this, carbonate, bicarbonate, metal or base. Metal or base, it will give you salt plus hydrogen. With base, it will give you salt plus water. With bicarbonate or carbonate, it will give you salt plus carbon dioxide and water. And these reactions, you must have learned it in 9th or 10th class, right? Then reaction involving cleavage of COH. Okay, this bond, cleavage, right? So that is also the same thing. If you break this bond, what you will have, either you can convert it to anhydride or you can convert it to ester. You add here Cl, it will be converted to acyl chloride. You add NH2, it will be converted to amide, right? So all these reactions are possible, right? Reaction involving cleavage, involving this bond cleavage. That means COH group is converted. So if you have COH group, you use reducing agent. This entire group is converted to alcohol. Okay? And do you, tell me, who will tell me this? What is this reaction? Let me see if you can identify. The reactions are here and there repeated only. Okay? What is this? Do you remember this? Soda lime decarboxylation. This R is converted to RH. Isn't it same thing? Cole's electrolysis, that is also reaction of carboxylic acid, right? Helmholtz-Zielinski reaction we have done. Ring substitution in aromatic acid. So can you tell me why this is meta-directing? Because it shows minus M effect. That is the reason it is meta-directing. So whether you give it Br positive electrophile, or you give it this electrophile, NO positive electrophile, it will give you meta product. ठीक है? Okay, understood? So this is a reaction. Phenol will not give NaHCO3 test, and this phenol will give FeCl3 test. Carboxylic acid will give NaHCO3 test with the elimination of CO2, and FeCl3 test, it will not give violet color. Right? That is the distinction. Tell me if that is clear. Now shall we take break? Right? After the break, wait a minute na, एक चीज, where it is? My own PPT, I am not able to find things. I was looking for one page. I wrote all the electrophiles. Where is that page? If it is not here na, then I'll just paste it on. Dekho here. Here I have pasted all the electrophiles. Wherever you paste it, okay? I'm just random because it is every chapter you have this. So before amines I am pasting it. Okay? Every chapter you have this. Hai na? The way I am making the electrophiles, this should be clear. When you have these reagent, these are the electrophiles that you have. Okay? In this case, वैसे तो we have electrophile is SO3. Okay, SO3 is the electrophile. But SO3H is, because of internal transfer, you will see SO3H. Right? Okay. Tell me. Now after this, we'll start with amines. And very few things we are left with. Some 60 pages and some 5-6 more pages will be there from hydrocarbon, alkyne and that part. Okay, ji. Now shall I see you at 11:30? Okay, I'll see you all at 11:30. Okay, tell me. Thank you so much, Harini. Thank you so much. I can't take off here. I'll be taking off. I am on off only. Off only. I'll be taking off. Actually, tomorrow I have NEET ka class, so I don't want to break the flow. Then Monday I'll take marathon. On Tuesday I have one NEET class, and after that I'll take off for 2-3 days. Okay? And after that I'll take your class on 4th of Jan. Okay? Now on 4th of Jan, what I am thinking to do is because now I'm doing theory, then I'll be doing questions, as many questions like PYQs I'll pick. Right? So let's see. 4th Jan is the date that I have decided, because that is Sunday also, and in the morning we can start the session relaxing. We'll do all the questions with fresh mind, and I think that will be a good plan. And by the time you will have time, 31st, 1st, 2nd, 3rd, for if you want to revise all the 3: physical, inorganic, organic, है ना? ठीक है? चल. Now, okay. Now what I'll do? Now I'll go and I'll see you all at 11:30 p.m. Right? So 11:30, see you all. Hello. So, students, let's complete the rest of the part. Are you all ready? Tell me. Morning 9 a.m. you have physics marathon. That's amazing. So, are you also ready for that? I'll just free you by like in next 30-40 minutes. We'll be done with the class. Right? Okay. So, wait a minute, let me just teach you the remaining part of hydrocarbons here. I'll just import the PPT here, right? Just give me a second. Mostly reactions are like very, very easy reactions you have, but these are important reactions. Okay? Thank you. Thank you. Right? We are teachers, right? That's why we are able to do, because we know that you guys have trust on us, so we can't break that trust. Right? Acha, now listen. There are some important reactions of hydrocarbons. Let's talk about those important reactions. Okay, these are the remaining reactions of hydrocarbons, right? Okay. So this is about controlled oxidation reaction directly mentioned in your NCRT. When methane is reacted with O2 with copper, it gives methanol. When it is reacted with O2, it gives, in presence of molybdenum oxide, it gives methanol. When it is reacted with O2, then it, in the manganese acetate, it gives ethanoic acid, right? That is specific reactions that you have. Then if I talk about controlled oxidation of tertiary tertiary alkane, in that case with KMNO4 it gives you alcohol, that is tertiary alcohol. Again, an important reaction, right? Then aromatization, very, very important. So whatever is the number of carbons you have, what will happen, it will form the aromatic ring, right? This is a very important reaction. Like chromium, vanadium, molybdenum oxide can be there under very high end temperature and pressure. This will form, because these reactions are used in mixed reaction. They will start from here, they will take you to benzene, then they will show you the reactions of benzene, right? Then there is oxidation part. Oxidation part is complete oxidation. So this is a simple trick of this. Now this thing can be useful in physical chemistry as well, that in the oxidation part you have, this is wait a minute, this is alkene, this is alkene, right? And this is alkyne, right? And with the number of carbons that you have, accordingly you will have, if you have, let's say, 1 carbon 1 CO2, 2 carbon 2 CO2, like the number of carbon will define the CO2, and the number of carbon will define the water that is there. If it is alkyne, it is n minus 1. If it is alkene, it is n. If it is alkane, it is n plus 1, right? Then you talk about these elder reaction. In this case, you have alkene, two alkenes you have. What will happen? This bond will shift here, this bond will shift here, this bond will shift here, and that is how they are going to form, this bond will shift here, they are going to form this new compound here, that is called as Diel elder reaction. And this is also a very important reaction that you have. Okay, this is also a very, very important reactions, right? Okay, yes, sure beta, take rest and take care of your health. Now this is again a very, very important reaction from where starting they start usually the reaction. Your PYQs you will see that. So what exactly they do? When calcium carbide is formed this way. Calcium carbide is reacted with water, it gives you ethine. Calcium. Magnesium carbide with water gives you propine. These two are very, very important reactions. Okay? Calcium carbides give you ethine, magnesium carbide give you propine. Very important. Very important. I'm marking something now that is important. Now see 3-4 reactions that are completely formation of alkynes here. So alcohol causes dehydrohalogenation. Firstly, you will use alcoholic QH, right? Halogen will be eliminated, hydrogen will be eliminated. Then here you will again use a base, but it is a stronger base. This is a stronger base as compared to this. To take out dehydrohalogenation from alkene, it is easier, so alcoholic QH will work. But here you need a stronger base, so we are using NaNH2. And that's how after dehydrohalogenation, you have the preparation of alkyne here. Then you have geminal dihalides, how they are formed. Same thing. Alcoholic QH, you will take halogen, hydrogen will be there, and you will have this. Again, this you will take halogen, hydrogen you will take, and you will have this. Right? Same thing will be there. Vicinal and geminal. Then from tetrahaloalkanes, 4 haloalkanes. Do you remember I taught you even in alkane and even in alkene, whenever you want to take out halogens, dehalogenation will be done by this reagent called zinc. Dehydrohalogenation will be done by this reagent called alcoholic QH, right? So this will cause dehalogenation reaction. Dehalogenation reaction. Okay. Then you have other, that is Kolb's electrolysis. Same way, you will have the formation of free radical CH, free radical this, and they will combine together to give you alkyne here. Okay, triple bond will be formed. Right? Same thing we did. Grignard reagent. Most of the reactions in alkynes are repeated of alkane and alkene only. So in this case, you have step-up reaction. So what you have, these are the reactions of alkyne. So let's see how do you prepare alkyne from alkyne, right? Alkyne, how it is prepared from alkyne. So here you have 2 carbon alkyne. It is reacted with Grignard reagent. So this is negative, this is positive, positive will be replaced. So instead of H, you will have MgBr here. Instead of H, you have MgBr. Now, this is a Grignard reagent. Grignard reagent, whenever it is reacted with any Ri, so what will happen? This is positive, this is negative, this is positive, this is negative. This R positive will be replaced by this part, and here you will have a step-up alkyne that is formed. Okay, right? Yes, beta, that's why it is taking that much time. Then you have acidic character of alkyne. We are saying the terminal hydrogens are quite acidic, and that is why with metal or any base, they are making salt and hydrogen they are releasing, right? That is the why they are so acidic, because this is sp hybridized. That is why they are so acidic in nature. Okay. Then see, if you have addition of H2, right? Simple, this we have done before as well. How in addition of H2, this will be converted to alkene, right? This will be alkene, okay? This we have done before as well. So this I will delete only. This we have done, right? Okay. Acha. Then you have, see this, Br2. When you add Br2, and do you remember I told you in alkene as well, anti position it will be attached. It is same. Anti position it is attached. Okay, reagents are also same. Br2 in CCl4, right? Then again you add anti position, it will be attached. Okay, it is same. It is parallel to alkene, right? Then addition of HOX. Whenever you add HOX, negative part will be added to less number of hydrogens. So this will be added here, and that will be added here. This is enol, then you will tautomerize and convert it into keto, and that will become alpha haloketone. So with HOX, you have the formation of alpha haloketone, right? Okay. Then hydroboration. In case of hydroboration, you don't have to do that much. Just remember, OH negative will be attached to more number. That means OH will be here, H will be here. Now this is, if you remember, I told you this before as well. This will be enol. This will be converted to keto form, and that will be the aldehyde that will be formed here. When you replace, hydrogen is shifted here, double bond is shifted here, right? Then you have test of alkynes. If it is reacted with CuCl3, it gives you reddish brown PPT. If it is reacted with AgNO2, it gives you white precipitates, and it is also called as tolerance test. So alkyne also gives you tolerance test. Even though they don't make silver mirror, they make white precipitates. Okay, that is a very important line. Okay, then cyclic polymerization C. From ethine, again a very important reaction, that in red hot tube, right, of quartz or copper or iron, what you will have? You have ethine, this bond will shift here, this bond will shift here, this bond will shift here. You will have the preparation of benzene here, right, from ethine, right? Okay. And mesitylene is also formed from propyne. I'll just write it here. Okay. Structure you can see yourself. I have told you what is mesitylene in the starting of this lecture when we were doing IUPAC naming and common names, right? Propyne, it will make mesitylene. Okay, that also they can ask you. Then some other methods, simple is, if you have chlorobenzene with hydrogenation, it will give you benzene. If you have RMGX, this can form RMGX. RMGX, when it sees proton, this will be converted to hydrogen here. So it can form, I told you, Grignard reagent. If it has proton source, it will be, MGX will be converted to proton. If you have sulfonic acid, you add H2O and HCl, this will be directly converted to benzene. Disonium salt, converted to disonium chloride. You add H3PO3 or ethanol, both are important. It will be converted to benzene, right? Then you have halogenation. In this case, what you have, or these are all the reactions, simple, I'll just do it very fast. Cl positive electrophile will attack. Here NO2 electrophile will attack. Here you will have SO3H will attack. SO3 is the electrophile, but internal transfer will take place because we are repeating it so many times. CH3 will attack. CH3 positive is the electrophile. Here in Friedel-Crafts acylation, this I'll tell you why amines will not. Chalo, let's tell you here only. Okay? If you have acylation, instead of this, you will have C double bond O CH3. Okay? That will be formed in case of acylation, that it will show. But they are saying that Friedel-Crafts acylation is not shown by anilines, that we will study just now, because they act as a base and this is a Lewis acid. So they will make a salt. Instead of showing electrophilic substitution, they will form a salt here. Right? Then these are three important reactions. Usually aromatic, they don't show addition reaction. But with hydrogen at a high temperature, they form cyclohexane. And if you add Cl2 in presence of H mu, they break the pi bonds and they attach Cl on each position. But this is called as gamazine. If you have Cl2 in anhydrous Cl3, Cl will be attached, but double bond you will not break here. Okay, that these two are very different reaction from this. Double bond is a break. We will break the double bond. Here double bond is intact. Okay, it is staying intact. Right? Okay. Then Birch reduction. In Birch reduction, what you have? You have benzene, you break one double bond and two double bond, then they are opposite to each other, they will stay. Right? So two double bond that are opposite to each other will stay. Okay, that is Birch reduction. If you remember in alkyne, reagent is same. Okay? There you have trans alkene from alkyne. Here, Birch reduction of benzene will give you this two double bond opposite. But if you have electron donating group attached, then that double bond that is intact will be next to electron donating. So it will be, this will stay and opposite to this will stay. And if you have electron withdrawing group, when someone is withdrawing, you would not want to stay with them. So it will stay away. Double bond will not be next to the electron withdrawing. Here double bond will be next to the electron withdrawing. Okay, but just give me a second. Right, I forgot to bring my water bottle. Got it? Acha. See next. This I told you that any alkyl chain you have in KMNO4, this will be oxidized to COH. Condition is this should not be tertiary. Only then this will happen, right? Then see, last one is two things it will show: addition elimination reaction. This I am just to show you the example. Dow's process is the example of addition elimination. Elimination addition, my bad. Elimination addition is Dow's process, right? If you remember, I told you while we were doing the mechanism of Dow's process. And addition elimination is when occurs when strong electron withdrawing group are attached to benzene, like you have this thing. If you remember, we did this reaction. When ortho and para position, strong electron withdrawing group are attached. Here, when it is converted to, this Cl was converted to OH. This was the example of addition elimination. Here OH was firstly added, then Cl was eliminated. Here Cl was eliminated, then OH was added. Okay? Okay, acha. Now one more reaction that we were left with. Do you remember I told you one reaction I'll tell you in aldehyde ketones that we were left with? I'll just show you that reaction. ठीक है, most of it तो बेटा we have done. Questions ना, I'll give you questions, so even I don't have now the energy left to do questions. ठीक है, so whatever questions we have here, I'll just delete them and I'll take it on the PYQ session only, right? Okay. अच्छा, now let's see one part that we were left with. Where is that, yaar? Where is that reaction? Here you have that reaction. See, here you had that reaction. Whenever you have ketone, you have NH2Z. Water will be eliminated here and you will have C double bond NZ, and this will be the answer that you will have. Now this Z can be anything. Now, based on that anything, you have specific reactions that are mentioned in your NCRT. It can be hydrogen, R, OH, NH2, this or this. Based on this, you have some very important, it's a very important table, right? All the reactions are important. Oxime, Schiff's base, amine, this, all the reactions are important here. Just replace Z with this thing, and that will have a specific name, and product also will have a specific name. Okay, right? Now let's move towards amines, right? That is our chalo. Let's move towards amine. See, first is the preparation of amines. If you see, amines are prepared. If I talk about the preparation of, wait a minute, this is not the preparation of amines. This is the preparation of aldehyde from cyanide, right? Chalo, koi baat nahi. If this reaction is, wait a minute, by mistake. ठीक है. You have Stephen's reaction. So this is RCN, this is SnCl2. This, what will happen? This will be, when this will be converted to imine, and after that this will be, wait a minute, this is not, I'll just move this, okay? Stephen is SnHCl, okay? So I'll just do this. When you have cyanide and you have SnCl to HCl, this is converted to imine, and then after hydrolysis that forms CHO. That's how you can form aldehyde or benzaldehyde, right? Then if you talk about Mende's reduction, in this case, what you do, you have R, CN. In the case of H2 and nickel with sodium amalgam, it will be converted to amine with the same number of carbons, right? Then you have Gabriel phthalimide reaction, in which this is your phthalic acid, phthalic amide. Phthalic amide, always remember, it gives primary amine is formed always here, and R should never be aromatic in nature. These are the important points here. So what exactly happens in this case? Firstly, how phthalic amide is formed? You have NH3. This gives C double bond O NH2, C double bond O NH2. Then this will be eliminated from here, or you can say NH3 will be eliminated, and you will have the formation of phthalic amide. Now, after phthalic amide, when you react it with KOH, you have K positive here, right? When you react it with RX, so R positive will replace this, and after this, what will happen? These two bonds will break. Here you have H and H, which will give you amine. So that is the reason here only primary amines are formed, right? And it should not be aromatic. Why it should not be aromatic? Because eventually you need to break this bond, right? So that is the reason. If it is aromatic, aromatic will have partial double bond. That is why it is not possible to break it. That is why it should never be aromatic in nature. Then guys, we have Hofmann bromamide degradation. How long? Like 30 minutes more, 30-40 minutes more, okay? Hofmann bromamide degradation, if you see this here, in this case, this CO is escaped. This is totally removed and one carbon less amine is formed, that is RNH2 is formed here, right? In this case, mechanism is important. I'll tell you why the mechanism is important here. See, firstly, base will attack, it will take out proton, this will shift here, right? And this bond will shift here. So it will be O negative, and here you will have double bond. Then you have bromine. So what will happen? This pi bond will attack on this bromine, and this bromine will be cleaved here, and this bond will shift back. Now you have R, C double bond O, N, H and Br. Now again what will happen? Same process. Base will again abstract the proton. This will again shift here. This will again shift here. You will have O negative double bond N. Now it is important that what will happen? This R here, right? This R part will shift here. Okay. This is important. Okay. This step is very important. This R will shift here, this Br will leave from here, this will become RNC, double bond O, this bond will shift here. So this is very, very important. This they ask you, what is the intermediate that is formed? So intermediate is isocyanate, that is RN's double bond C double bond O. That is very, very important that this thing is formed here. Even if you don't want to remember the full mechanism, please remember this, that this thing is formed here, right? Okay. And after that, what will happen? After hydrolysis, you have the formation of RNH2 and CO. Okay, ji? Next is carbylamine reaction, which is again a very important reaction of this one. In carbylamine reaction, it is the test of primary amines. Here also, because this reagent was there in Reamer-Temer reaction as well. So just like in Reamer-Temer, you will have the formation of dichlorocarbene here. Okay? This also they ask you. These two mechanisms have dichlorocarbene. Okay? Now, same thing. Lone pairs, it will attack here because this is electron deficient. You have the formation of this N positive, this is C negative. Cl will leave, right? What will happen here? Cl negative will leave. So firstly, just remember this base is going to attack here. Base will take out the proton. This will shift here, right? Okay. And hence, after all of this, what you have Rn. This is a very simple mechanism. Rn, this Cl will leave from this side, Rn double bond C. Okay, this bond has shifted here, na C. This proton will be here, this bond will shift here, and this bond will shift here. So Rn double bond C and one Cl. Again, same thing will happen. Base will attack on the other H positive. Majorly, our target is to take out these H from, like with the attack of base, we want to take out these H, right? So this H will also be eliminated. This bond will shift here, and this again Cl will be eliminated. You have Mc. So it's a very easy mechanism. Okay? It's a very easy mechanism. There is no as such big thing that is happening here. Simple, till here carbene is formed, it will attack here. Then your task is base will attack on this proton, this Cl will leave, double bond will be there. Base will attack on this proton, Cl will leave, you will have triple bond, and that is your isocyanide. Okay? This is isocyanide. Just remember, this is isocyanide, and this that I showed you, this is isocyanate that is formed as an intermediate here. That is the difference. Okay, know this difference. Then bacha, we have Hinsberg reagent. Hinsberg reagent is this reagent, that is C6H5SO2Cl. When it reacts with primary, HCl will be eliminated. You will have the formation of soluble alkali product. Because of this hydrogen here, it is soluble in alkali. Here HCl will be eliminated. You will have the formation of alkali insoluble product because hydrogen is not available on this product, right? Then tertiary though will not react only. Okay, you can see this here. Tertiary will not react. 3 degree, tertiary means do not react with Hinsberg reagent. Okay, then azo dye test, if you see, again from the para position this will leave, and you need to know the color of the azo dye that you have. Okay, with phenol they give you yellow color dye. Okay, with phenol they give you orange color dye. Phenol, O for orange, right? So this is, with aniline they give you yellow. You need to know the color of these dyes. Okay, this is yellow color dye. Then with the beta naphthol, this is beta naphthol. Okay, you can also write it here. This is beta naphthol. Okay, here it gives you scarlet red color dye, N2. Okay, this is scarlet red color. Okay, tell me. Clear? Then Lissagines test. What is? So Lissagines test will not do here. Okay, this we will do in that case only. Okay, this will do there only. Okay. Lissagines test तो will do there only. ठीक है? चलो. Then these are the flow charts. See, two important reactions, which is thoda sa high level reaction. High level nahi, matlab, if they ask you, you might get confused in this one. Okay, this is NH3, this is CH3Cl. We know that here this is Hoffman ammonolysis. Firstly, to primary amine is formed, right? Hoffman ammonolysis. Then after this, the attack of NH2R with CH3, then this hydrogen will be replaced by this R, this will be secondary. Then this hydrogen will be replaced by this R, this will be tertiary. Then again you will have the attachment of one CH. That is quaternary. So that is Hoffman ammonolysis. But after ammonolysis, if you see this thing, this is called a Hoffman exhaustive elimination. What will happen here? See, you have ammonia, you add Rx here. We know that this quaternary salt is formed in the end. okay, whatsoever is the reason, and quaternary salt is formed. Now when this quaternary salt is reacted with Ag twice O, what will happen? See, elimination will take place. Let's see how. From the alpha position, what will happen? Simple thing. Here this bond will shift here, right? Okay, this bond will shift here, and you have the formation of, simple thing is, next to this nitrogen, make a double bond, break the bond here, make a double bond. That is your elimination. Okay, break the bond, make the double bond here. Okay, now again you reacted with CH3I, again CH3 will be there. Now again you add Ag2O, again this bond will break here, you will have a double bond, right? So this thing is formed and this amine is formed. That is a different reaction, that is Hoffman exhaustive elimination, and this is not in your NCERT, right? Okay, बस बेटा 30 minutes more we have, ठीक है? 30 minutes more. If your eyes are paining, you can take rest and you can watch this after that, right? Okay, this is just another example of that, right? So I'll just delete, I'll not delete the example, you can do it yourself as well. Now see, Shortman-Bowman reaction, benzoylation reaction. So you have amine, you have Cl. So what will happen? Hydrogen and Cl will be eliminated, and here you will have the formation of C double bond O benzene. HCl will be eliminated and C double bond O benzene will be attached there, right? Then very important reaction, C. Amines, they never form mono bromo compounds, they never form. So if you want to have mono bromo aniline, you'll have to go through this process. This is acetylation. So what you do, you replace, like this is NH2 na, you replace one hydrogen with C double bond O CH3. That is called as acetylation, right? This is phenyl, this is NH, one hydrogen is replaced by COCH3. That is called as acetylation, right? And here in this case, after that, when you do bromination, only mono substituted product is formed. And after that, you add water, right? And it will give you aniline, mono substituted aniline, because mono substituted bromoaniline is not possible directly. It will form three bromines will be there. Okay? On ortho and para position, you will have bromines. Now next is that if I talk about nitration, why on nitration I have to do this? I'll tell you here. This is a very, very important question. Aniline on nitration forms, see, aniline is ortho-para directing. So it should not be forming any meta product, but it is forming meta product, and that to 47%. Now why it is doing that? Because aniline in the HNO3 and H2SO4, it is being converted to this anilinium ion that you have. This anilinium ion that you have, it is meta directing, and that is the reason you have the formation of meta product here. But ma'am, we don't want to have meta product. Then do simply acetylation. This is acetylation, convert this to COCH3, right? Then do nitration, only para product will be formed, right? Okay, then this though I have told you before also, diazonium salt with H3PO3 or ethanol or formic acid will give you directly benzene, right? Okay, now see these 3-4 charts here. Acha, this though I have told you na. Acha, this I have not told you. See, aniline when you do, see, phenol when you do bromination with CS2, it will give you mono substituted. With water, it will give you tri substituted. But aniline with anything, it will always give you tri substituted. That is the reason we have to do acetylation. So I will just interchange it here, right? Okay, so that you know why their acetylation was required, right? Okay, Now you are just left with these charts here, guys. You can go through them yourself as well, or I'll just do that. Tell me. Shall I do that? Good morning, good morning. See, Stephen's reduction, when you have NO2, okay, very, very important reaction. NO2 is converted to RNH2 by reacting this with SnHCl or FeHCl or catalytic or this. See, understand one thing, when it is reacted with SnHCl or FeHCl, out of this, FeHCl is preferred. Why? Because it gives you HCl. See, FeCl2 that is formed, it gives you HCl that is used here as the reagent. That is why FeHCl is preferred. Okay? Then Hoffman ammonolysis I told you, Mendius reduction I told you, reduction of amides also we discussed, that amide or ester, all of them will, amides so will see. Direct if you do reduction, here it is going to give you RCH2NH2, this kind of amine. But if you do Hoffman bromide degradation, this will give you RNH2. This is a very important difference. Okay? From amide only you are getting amines, but different amines. Okay? Gabriel phthalimide synthesis also we have seen. Then RNH2 reaction, see, with HCl, it can form disonium, it can form RNH to this. Acha, this is not important. Okay. This Hoffman, this is a monolysis. This we have seen primary, secondary, tertiary amine. Okay, this is acetylation. This is Schockman. I just told you now how hydrogen will be replaced by CO C6H5. This also we have done. Schockman-Baumann reaction. Here you will have RCO. It will replace the hydrogen. Okay, it will replace the hydrogen. RCO, देखो बेटा, simple thing is here this thing will replace hydrogen, here this thing will, whatever is attached to CO, that will replace the hydrogen. Okay, acetylation, benzoylation, right? Again anhydride also, RCO will replace the hydrogen, right? This is carbylamine reaction, we have seen it in detail. Then this is very important. When you have RNH2, just see here, actually though you will have the formation of, here in reality you will have the formation of RN2Cl, but it is so unstable, it directly gives you ROH. If you have disonium chloride, this benzene wala, it is still stable between 0 to 5. This is not at all stable. If you have alkane part here, this is not at all stable. Then this is Hinsberg reagent. This also we have seen. Right? Okay? Yes. Right? Okay. Okay, now these are the reactions of, further reactions of aniline, right? If you see with bromination, it gives you tribromo. If you want to get para-bromo product only, firstly you will have to do acetylation. We have done this in detail. You'll have to replace it with hydrogen, you have to replace it with C double bond O CH3, right? Then you do para-bromo, then you convert it into again aniline, right? Same thing. Nitration also, firstly do acetylation, then you do nitration, then it will give you para. Okay? This is so carbylamine. This is just like in phenol, you reacted with K2Cr2O7, it gives you benzoquinone. Here also same reaction is given by aniline, right? Disonium chloride, NaNO2HCl 0 to 5, disonium chloride salt is formed. With concentrated H2SO4, directly sulfanic acid is formed. Okay, that also reaction is important. They ask you those reactions as well. Okay? Then see disonium chloride. I think this is the last reaction part that you have. Yes. Okay, disonium chloride, most of it we have seen already. Then H3PO2 or you have ethanol, it will give you benzene. This is Sandmeyer reaction, we did it in haloalkanes, halorenes. Getterman also we did it, right? This is Ball-Schiemann reaction. I showed you nitro also, I have done it in haloalkenes. This also, if you remember, we have done there. Acha, this disonium chloride with water. Now this I told you na, when you vomit above 5 degree, then it will give you phenol. This is phenol. This AR is benzene. So this is phenol. With NaNO2 copper directly, it will give you nitrobenzene. If you give it C6H5, it is going to give you diphenyl. Okay? That is Gomberg reaction. Tell me, is that clear? Coupling reaction, so we have seen in detail only, right? Okay. Let's see what is here. Chloro with this. This difference you must know that this is ortho para. That is why we are having ortho para products. This is meta. That is why you have meta product here. Okay? Ortho para meta, how we tell that I told you in resonance. Okay? Tell me. Fatavat se let's complete biomolecules now. Ready? Ready everyone? Yes, you can do this for board exam also. Okay? So, rest of biomolecules, I have done it in detail just now, right? If you have never done biomolecules, bit of those chapters that you have never done, please at least watch it once, right? Okay? But still, I'll tell you some important parts here of biomolecules, okay? Because I know right now you don't have that much capacity to learn everything, so I'll just tell you that what is important and what is not important and what I have to explain, because in biomolecules it is more of cramming, right? So this you must know the reactions of glucose, like with HI it gives N-hexane, with NH2OH, right, it converts, it gives you reaction of carbonyl compounds. Do you remember that reaction? NH2Z with carbonyl, है ना, what it forms? I just showed you that reaction, this reaction. It will give you this compound. Do you remember that? Okay? So same thing is given by this. That means there is presence of carbonyl. It reacts with HCN, right? It gives you cyanohydrin. It confirms carbonyl. It reacts with bromine water to give gluconic acid. Here, it confirms aldehyde group. It reacts with lead. It reacts with acetate to give, and it replaces H5. It gives you 5 acetate groups. That means it shows that there are 5 OH groups present. Then it reacts with HNO2 and it gives saccharic acid. That means there indicates the presence of a primary group. That means the last group is primary, and from there you will have this particular compound, that is glucose, right? Then guys, you must know that on the glucose, this is 1, 2, 3. On the third carbon in the open chain, OH is on the left side. Just remember this thing, right? Okay. Then alpha glucose and beta glucose, what is the difference? See, in case of alpha glucose, the first carbon, this is in the cyclic form. Okay. Cyclic form also, this is how it looks like, right? Okay. Cyclic form. Remember, if you know this form now, you will easily be able to make the pyranose form. First carbon, if the configuration is opposite, on the first carbon, let's say OH is on the right side, that is alpha. If OH is on the left side, that is beta. Okay. Then what you have next is, you must know the structure of these three. Okay. You must know the structure of glucose, fructose and galactose. Draw it multiple times. It should be on your tips. Okay. Draw it multiple times, guys. See, alpha and beta glucose you should know, right? The difference is only over here. everything else is same. Then fructose, you must know how to draw it, right? It's furanose form, this is pyranose form. And glucose and galactose have the difference only in fourth carbon, this carbon. I'll just show you the difference in glucose and galactose. Glucose and galactose has difference only in the fourth carbon. Everything else is same. So in the end, you know what you have to remember? You just have to remember the structure of glucose, this structure and this. Beta glucose, you can just replace, interchange first carbon. Galactose you can form by interchanging the fourth carbon. And here if you want to convert it into beta galactose, वैसे beta galactose is not important for you. You remember this one, this one, this one and this one, because these four are used in your disaccharides, right? Okay, yes. Then these are the glycosidic linkages. This is gold. This particular page is gold for you. You don't have to draw the structures in the exam. Just remember the glycosidic linkages, right? The two monosaccharides, when they are combined, they form disaccharides like sucrose, right? Sucrose. See, all the monosaccharides are one very important thing I am writing. Where should I write it? Chalo, I'll just write it here. I don't have space. Okay, I'll just write it here. All monosaccharides are reducing. Okay? Because on monosaccharides, na? Wait a minute. Sucrose is a non-reducing sugar, right? Others are reducing sugar, right? Sucrose is non-reducing. All monosaccharides are reducing sugar. Yes. Okay? I'll just write it here. Reducing sugar, because this also they ask you directly. Reducing sugar are all monosaccharides like fructose, glucose, galactose, all of them, or disaccharides except sucrose. ठीक है? Okay. Done. Acha. These are the glycosidic linkages of all of them, right? Like sucrose is C1 of glucose and C2 of beta fructose, C1 of galactose, C4 of glucose is lactose, maltose is C1 of alpha glucose and C4 of alpha galactose. And trust me, directly they ask you glycosidic linkages. Directly. This page is very, very important, okay? I can't, like, there is nothing to teach here, right? Okay? There is some things to teach, but that much to better detail, so I can do it only in detail lecture. If you have never done biomolecules, then there is no point of revision, right? Because biomolecules is entirely different from other parts of organic. So I would advise you, if you have never touched biomolecules, please go and see biomolecules chapter that I have just done 1 week back. 2-3x speed, watch that. Because here I am just telling what is most important here. But if you have never done this, you have to go through biomolecules. Otherwise, all these things you won't be able to understand, right? So this is amino acid. Alpha amino acid means COH, and on that means COH and NH2 are on the same carbon, that is alpha amino acid, right? So Zwitter ion, it forms because this is a base, it will accept H positive and this will lose H positive, it forms Zwitter ion. There are two types of amino acid, one is essential, one is non-essential. Essential means which cannot be synthesized by our body. Those which cannot be synthesized in our body have to provide externally. Non-essential means our body can generate it, right? Then if you see, this is the table, and remember that glycine, okay? Glycine is the only optically inactive compound, inactive amino acid. Because in glycine, you know what you will have? Glycine, you have CHHCOH, and this is NH2. This is glycine. And if you see, this carbon is not chiral. This is not chiral. What is not chiral is optically inactive. So they can ask you one more question here. There is only one amino acid which is optically inactive. That is glycine. Okay. Then this is a full chart here of, ma'am, do I have to remember all of this? I'll just point out which are important to remember. Okay. So glycine is important. Important to ऐसे all of them are important. Glutamic acid, aspartic acid, ठीक है, serine, cysteine. It's your choice, right? It means all are important, but this glycine, alanine, leucine, isoleucine, adenine, this you do. Okay, lysine, right? If you can do that, but at least glycine, so you should know, right? Okay, if you're not able to remember all of that, it's okay. They don't ask you as such questions from here. Glycine they can ask you. Okay? If you're bad luck, they ask you any questions from there, then I can't do anything, right? But as such, they don't ask. All alpha amino acids are optically active except for glycine, because there is no chiral in the glycine. Then you talk about proteins. In protein, see, you have primary structure where amino acids are connected by peptide bond. Disaccharides are connected by glycosidic linkages. Amino acids are connected by peptide bonds, right? That forms the primary structure. Secondary structure means you have 2-3 amino acid chains connected with each other. How they are connected, that is secondary. Tertiary means how they are further, how, let's say, 2-3 chains are put in a packet, 2-3 chains are put in a packet, how they are connected with each other, that is tertiary. Quaternary is how these different chains are connected, different tertiary structures are connected. It means the complexity goes on increasing, right? So this is basically, this is how amino acids are connected. This defines whether it is alpha helix or beta plated. All alpha helix. Okay? That is it like this? Is it like this? That will be defined here. Tertiary means whether it is this or this, how they are put in that pipe, that is tertiary. How different tertiary structures are connected, that is quaternary. You know, tertiary structure is actually divided into fibrous and globular. Tertiary structure is of two types, fibrous and globular. Fibrous is like in our hair, they are insoluble, and globular is the one that are soluble in water. Remember, they have hydrogen disulfide bondings, and they have polypeptide coiled around the spherical, they give a spherical globe-like structure. That is why they are globular protein. Then see, last one is nucleic acid. So in nucleic acid, see what all you have to remember here. First thing is, remember in RNA you have ribose, in DNA you have deoxyribose. Okay? Now in all the nucleic acid you have three things: sugar, pentose sugar, phosphoric acid, and nitrogen containing bases. Sugar here in RNA is ribose, in DNA it is deoxyribose, important thing. Then phosphoric acid, they don't ask you different phosphoric acid, just remember the nitrogen bases. DNA has adenine, guanine, cytidine, and thymine. RNA also has adenine, guanine, and cytidine, but instead of thymine, this has uracil. Okay, instead of thymine, this has uracil. Okay, so this is important. Always remember that if I talk about adenine, and it always form a bond with thymine, right, and that to double bond. G always form these are hydrogen bonds. Adenine and thymine, they form 2 hydrogen bonds. Guanine and cytosine, they form 3 hydrogen bonds. This is in case of DNA. In case of RNA, they form two double bonds, two hydrogen bonds, and guanine and cytosine again forms three hydrogen bonds. Okay? Okay? This is very, very important. This part is what they ask you, right? Then from here, this all one more definition they ask you. See, side means don't include phosphoric group here. Nucleotide, you will also group phosphate group here. That is the difference. Okay, the very simple definition that they ask you here. Okay, see, RNA is single stranded. It is single stranded structure. DNA is double stranded. See, double helix structure. Two helix are coiled together here. Right? DNA is double stranded. RNA is single. Okay, so yes, then you have vitamin, Hannah. Here you have soluble, insoluble vitamin, and that is the last page. I'm not going to do questions today. I'll do questions in the next then I will do PYQs now. I'll do it then only. Okay? I'll do it then only. Even now, you don't even have the Hannah, brain right now. Even your ma'am is exhausted, right? I thought I will do it today, but I think it's not possible. Oh, my slides, I think my board is exhausted right now. It's literally running. Okay. Yes. Now I'll pick important question only in the question session. Okay? Acha. Now see this here. See, I have not included full biomolecules. It's a very big chapter. But I have included main important things from where they ask you the questions. Okay. So, vitamins, remember, fat soluble vitamins is KEDA. KEDA. Vitamin K, vitamin E, vitamin D, vitamin A. Right? They are fat soluble. Examples you must know. Water soluble vitamins are B and C. Now remember, they are readily excreted in urine and cannot be stored. That's why they are water soluble. Except vitamin B12. Vitamin B12 is not excreted through urine. Okay? Got it? Yes. Done? Tell me. I think, oh, see, can you see how I have not done anything? My board is like super, like, okay, now please leave me alone. Okay, tell me, organic chemistry. Okay, now purification, that part I'll do. Wait a minute. ORG, marathon, JE. Before talking to you, I'll just start saving this because it will take a lot of time. Okay, so we have done it, right? Acha, see, purification, qualitative, quantitative analysis. I'll do it in physical chemistry only because that was too much in organic already. It was too much. And important reactions, reagent, almost everything I have covered. Like, I don't remember anything what I have not covered, right? Almost everything I have covered. And I too don't think so I have left anything, but still if you think that something I have left, then you can write it down. But in biomolecules, I have only picked up selected things, and even other also I have picked selected things. Some few things will be left, but the important things I have done, right? How it is humanly possible, I don't know. How many hours? 11 hours. Oh my god, I'm so tired. I just want to like close my eyes and now sleep. It's like you are in a war situation and you don't give up till the end. But when you're like, okay, the war is over now, then you're like, okay, now right now I'm feeling like sleepy. Before this, I was not feeling. Now my throat is also paining now. Very good, Harini. Very good, Chakravarti, Pranav, Mahreen, Sibhi, Santosh. Let me see how many of you were here from the starting. Let me see all of you, and I want all of you to comment down in the comment section that yes ma'am, we were here. Let's make it 2000 plus likes before physical chemistry session. Yes, everybody. Yes, problem solving session I'll do after physical chemistry. And physical chemistry I will not be taking so many questions. Only some here and there questions I'll take. Matlab, in physical chemistry, so obviously when I'm teaching, I'll have to take some questions, right? Because without questions, so you won't be able to understand only what I'm doing, right? So I'll take model questions, but more practice we'll do in practice session, right? Okay. Yes. Okay, Om Prakash, Bala, Harini, Sridhar, Suse, Kanchi, Puneet. Very good. Awesome, 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 awesome. Good. Great. Sanjay, they're from this. Very good, Sanjay. I'm so proud of you. Super proud. I am also proud of you. Very good. So, firstly, green hearts for yourself in the chat box. Green hearts for you in the chat box. Everyone. Very good. Chalo. Nonchalant. See, if you, these lectures are good enough, but if you're not done anything, like you have zero knowledge about this, and if you're able to understand what I'm teaching you, then it is good enough. Because important, everything I have covered here, right? So your questions you will see from these notes only. But the problem is, if you're able to like retain that information or not. For retaining that information, maybe you will need multiple revisions. Okay, so teaching though I have taught you, but now retaining is the thing that is on your part. Okay, chalo. Okay then beta, bye bye, and I'll see you all in the next class. Till then, bye bye, take care, bye bye, good night, and now you all can relax and sleep. Bye bye.